I hope you all had tea, coffee. Okay, awesome. We'll be starting shortly. Before that, Publicis Sapient is conducting interviews, as we mentioned, in another hall. So anyone who wants to interview for them, it's express interview. You can just walk away with your offer letters. So yay! And they're also conducting some quizzes where you can win goodies, if you guess the answers right. So please, during the breaks, go to the booths and have an interaction with them. Maybe you walk away with something wonderful today, apart from the talks. Okay? Over to you, Nikhil.
Hello, 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 everyone. Welcome all to track 2. Are you all excited? Yes. Only this much excited. Are you all excited? Yes. Ah, that's better. Everybody had their coffee? How's everybody feeling? All good? Yeah, nice, nice. Good to see that. All right, so let's get started without any further ado to our amazing speaker lineup for this particular track. So now let's call upon our first speaker who's going to kickstart this track. He's a software engineer at Appwrite, and he works at some amazing stuff there. And he's going to talk about how real-time communication actually works, and some amazing stuff about WebRTC. So I hope you all are excited. And with a big round of applause, let's invite on stage Christy Jacob. Hello, Christy. How's it going? All nervous or all set?
I think there's a lot of energy in the room. It's the first session. So, yes, definitely nervous, but let's see how it goes.
Oh, you're going to definitely rock the stage. I know that. All right, so another round of applause for Christy.
Am I audible? Perfect. So, this is going to be the first talk of this day, so I'm really excited. And we're going to talk about a really fundamental technology that's present in browsers today. It's called WebRTC. It's not new, it's been around for quite some time, over 12 or 13 years old. The original version was released by Google back in 2011, so it's been around for quite some time. But the hype recently has come up again, mostly due to COVID and stuff. Essentially, people have been using conferencing applications a lot, and it has caused people to wonder how applications like Meet and Zoom and stuff work, and WebRTC is the answer there. So to start with, WebRTC is a peer-to-peer communication protocol that enables real-time transmission of data between different peers. We talk about WebRTC mostly in the context of browsers, but WebRTC is also, can be used in, other scenarios as well. So essentially, the main highlights here are that it is completely peer-to-peer. That means it doesn't require any server to relay information between, between the different peers. It can be used for transferring any arbitrary data. It can be either video, audio, or images and anything of that sort. But mostly, it's used in the context of audio and video sharing. It's cross-platform compatible. Most of the browsers support it. It's Opera, Mozilla, Edge, Chrome, the latest versions of all of it. And it's open source, so that's always a plus point. And it's the technology that powers things like Zoom, Meet, Teams, and any kind of video conferencing application you can think of. So in this session, we're going to cover about we're going to divide it into two parts. So WebRTC consists of the actual media that flows between the different devices, and also the metadata about the media. So the metadata includes stuff like the codecs that the different devices support, the kind of media streams available, and things like that. And in the first part, we're going to cover the media and how the media flows between the different machines. And then we're going to look at how the metadata part. So WebRTC is built upon some underlying protocols, fundamental underlying protocols. That's a new word, underlying. So ICE is actually the framework that enables the communication between the different peers. And ICE relies also on certain other protocols like NAT, STUN, and TURN, which we're going to take a look at. So let's say you want to talk to a device on the internet. what's the first piece of information that you need? Any guesses? Exactly. So IP address is the fundamental thing that you need to be able to access or address another machine on the internet. Maybe, I don't know, 30, 40 years back, it was much easier because every device had its own public IP. You could address each device uniquely. However, with the number of devices that we have and the limitation of addresses in the IPv4 space, we have resorted to new technologies or new techniques called NATs to mitigate, the transition to IPv6, right? So we have only a limited address space of IPv4 addresses, so we can't really, there are more than billions of devices and less IP addresses which are less than that. So we introduced a new technology called NAT, which is essentially allows you to share a public IP for a lot of devices within a private network. So they can all, access the internet using a single public IP address. And most of us have learned about NAT back in college, so we're just going to do a quick primer on that, right? So if you have a NAT which has a single public IP, this is usually given to you by your ISP, Airtel or Vodafone, whatever. And within your network, you have certain devices, and you have different applications running on different ports, right? So let's say an application on port 3000 wants to communicate with a website on the outside. It's going to send a request to the website. It's going to go through the NAT, and the NAT is going to create a mapping from the private IP port pair to the public IP port pair. And it's going to create a new port for it within its table and create that mapping. So in this way, a single IP address of the router can be used by many processes within the network to communicate with the outside world. So this is what NAT essentially does. But we have a problem. So if you have run ipconfig or ifconfig on your terminal, the IP address that you get is of your local device, right? It's your private IP. So, and this private IP, as we discussed, is of no use if you want to establish a peer-to-peer communication. So we need a way to be able to, find the other peer's public IP. So let's say in a world without mirrors or in a world without cameras, what is the best way to get a description of your face? You would probably ask your friend to describe it to you. You'd probably ask your friend to sketch something for you, right? That is similar. There's a similar analogy that can be used here, which is the stun server. So stun stands for Session Traversal Utilities for NAT. So in scenarios where we have a NAT that is in front of your device, we need a way to detect its public IP address. So essentially, this server just says, so you send a request to a stun server saying, hey, stun server, what's my IP address? And the stun server, it can see, the IP address of the NAT that it came from, and it's going to return that address back to it in a packet. And then the peer can, decipher that packet and figure out its IP address and port pair, right? And so it also helps determine any router restrictions that can be present. So it's not always this scenario that, your peers are able to talk to each other. Even if you find out the public IP, you cannot really establish a communication. So the NAT needs to allow the port forwarding and things like that, right? So there are a lot of restrictions in place which prevent it from happening. Without any networking class is not complete without Alice and Bob. So let's bring them back here. But there's not a cybersecurity class, so there's no Eve in this scenario. So let's say Alice wants to establish a connection with Bob, and Alice is going to send a request to the nearest stun server, which we configure in our code, and it's just going to ask, hey, stun server, what's my IP address? Stun server sends back, Alice, this is your IP address, and this is the port that you're talking to me from, and you're also behind a NAT, which employs certain restrictions. Similarly, Bob performs a similar request, and it's going to get back its IP address and port. And finally, they're going to be able to talk to each other, assuming there are no restrictions. Okay, but we're not in the ideal world, and we do have some problems. So there are different kinds of NAT. The basic or the most permissive kind of NAT is called a full cone NAT. Essentially, it means that any internal device can communicate with any device on the outside, and vice versa. So the first kind of NAT restriction is called a restricted NAT, and in that case, an outside device can only communicate with a device inside the network if there has been a mapping in the table already. Now, the mapping is only present if a device from within the network initiates the communication first. So unless peer A has already talked to peer B prior, peer B is not going to be able to talk to peer A because that mapping is not going to be present in the NAT table. There's also an example of a symmetric NAT, wherein the IP address or the port that's assigned to a device depends on the destination. So let's say peer A tries to make a request to the stun server. It's assigned the port 15001. And if the peer B were to use the same 15,001 port to talk to peer A, that wouldn't work, because in case of a symmetric NAT, even the port number or the IP address is different based on the destination that you're trying to talk to. So what do? Now we have to come up with another workaround, and that's called a turn server. So a turn stands for traversal using relays around NAT. As the name suggests, the turn server is a relay that lets you relay your information between the peers. Now this is a scenario, now initially I told you about how WebRTC is completely peer-to-peer. But here's a scenario where it doesn't respect that. This is a scenario where all your data actually needs to pass through another machine and then go to the other peer. So in this case, the turn server does need to do some processing. It needs to be decently powerful to be able to handle all the media streams, and it does have some additional overhead because you have latencies coming into picture. Cool. So we talked about all of these technologies, and this is where ICE comes in. So ICE is the overseeing protocol which uses all of these things we discussed so far to handle all the connection details behind the scenes. So within each browser, you have an ICE agent which handles the generation of ICE candidates, and it does all of this behind under the hood, so you don't need to worry about any of the complexities. So a direct communication between peers may not be possible because of unavailability of IP addresses, NAT restrictions, firewalls, and so on. So ICE makes that possible. Now, when we start a WebRTC connection, we initiate the ICE generation process. So when we trigger the ICE generation process, both the peers, or as many peers as they are, start to generate a set of ICE candidates. An ICE candidate is essentially a description of a route that a packet can take to reach from peer A to peer B. So this is an example of, we have 5 ICE candidates here. So you can see that the different ICE candidates have different types. The first one is of type host. The second one is called stun server reflexive. The third one is also stun server reflexive. Then we have relay, 2 relay addresses. Essentially what it means is the candidates are going to try each of these paths in the order of their network cost. So each candidate also has a network cost associated to it. So the first one is just 10, 17, 17, and so on, right? So obviously you want to find the path of least resistance. So obviously they're going to try with the first candidate first. And this scenario will work when both the devices are on the same private network. So if you look at the IP address, it's a 192.168. It's usually a private IP. And this candidate would work in scenarios where all the devices are on the same network. Now let's say that doesn't work. You go to the next option, which is the IP address that is returned from the stun server. So the 122.171 is actually my public IP. And if we were in a scenario where my NAT was completely permissive, this is the next best option, where I can directly communicate with another peer using my public IP. And similarly, we have another candidate, which is also using the similar stun server. And finally, if that fails as well, we have the address of the turn server, which is the 216.39. And that is the last option that's going to be tried by both the candidates. So we have a small demo here. This is an example from the WebRTC official guide itself. And here we can configure a list of turn and stun servers, and then we can start generating the ICE candidates. So you can see that it has generated some ICE candidates for us to try. So firstly, we have the host. We have 4 variations of the host. Some of them are based on UDP and some of them are based on TCP. Naturally, UDP is preferred for these kind of applications because we can tolerate a little bit of packet loss in these kind of applications, right? But wherever data integrity is more critical, you would use your TCP over UDP. And then you have the relay addresses. For some reason, you can see that the stun server host lookup has failed. So it has not been able to generate the stun server reflexive address for some reason. Probably the stun server that I'm using is not valid anymore. But this is an example of all those candidates that are generated by ICE. And finally, you get a message saying it was done. Great. So now that we have covered the media part of the WebRTC framework, now we're going to look at how the metadata is passed and how the connection is initiated. So metadata is passed. So with internet or with when any kind of communication is involved between 2 parties, whether it's in the context of the internet or otherwise, you need to establish some common protocol or some common framework for them to be able to communicate. Between people, it's usually a language, right? Between devices on the internet, it can be frameworks or it can be standards like REST or GraphQL, right? You need a standard to be able to talk and communicate information with each other. So in case of WebRTC and exchanging the metadata that WebRTC is concerned with, we have something called STP, or a Session Description Protocol. Even though it's called a protocol, it's essentially just a data format that describes what kind of media and what kind of streams are available at a peer, and that can be sent to the other peer. So there are different parameters. We don't really need to go in depth, but if you're curious, there's a website which goes which deciphers an SDB packet, and you can go ahead and read about each of the fields that are present, and you can learn more about that if you're interested. Cool. So coming back, we have a quick recap between STP and ICE. So STP describes the metadata about the session. It contains information about the supported codecs, the supported audio and video streams, and it is used only during the initial handshake process. Whereas ICE is concerned with the networking part of the connection and how to establish a connection, the best connection between the two peers. And it gathers a list of candidates that you can use, and it chooses the best or the path of least resistance between the two peers to communicate. So now we covered a lot of theory, and now we can move ahead to the practical stuff. So in the browser, if you were to implement WebRTC, or if you were to use WebRTC, you need to handle three main tasks. Firstly, you need to acquire audio and video from any of the devices that are connected to the machine. Next, you need a way to communicate the audio and video. And finally, you also need a way to communicate the arbitrary data if your use case requires it. And similar to, for the three tasks, we have three APIs that help us do it. Firstly, we have the media stream API, and this is facilitated with the get user media function in the browser. It's pretty common, and it is used to access all the devices that are attached to your browser or to your device through the browser. And then this is the main API which is used for all the signaling, for the STP stuff, for the ICE candidate generation and everything in between, RTC peer connection. And this is the class or the API that performs all the heavy lifting under the hood. And finally, we have RTC data channel, which is used for communicating the data. Cool. So let's take a look at the first API, which is the media stream API. And here you can see that if you were to get access to your media, you need to first establish a set of constraints. Now, constraints in this case are just video equal to true. So that is, it's going to return any device which supports a video. So we use a navigator.mediadevices.getUserMedia function, and we pass in the constraints. And there's a success and error callback that is passed. On success, we just get access to the stream and assign it to a video object that is present on our DOM. Previously, we used to use video.src, but now that has been deprecated, and we use src object. And finally, there's an error callback. If something goes wrong, we can get information about that as well. So there's a small demo for Get User Media. This is again from WebRTC samples. It's a really good resource. You can check it out. So when I click on the Open Camera button, it's essentially going to request for my camera permissions. I've already granted it permissions, so it's automatic, just started. But typically, it will ask you for the permission, and only once you explicitly allow it, it's going to get the stream and display it on the video element here. That's a simple demo. And now we can talk a little bit more about the constraints that you can pass. So constraints are a really powerful feature of the Get User Media. It allows you, let's say you have hundreds of devices connected to your machine. It allows you to filter out those devices based on the exact scenario or the use case that you want. Let's say you want a camera that is only supporting 480p. You can specify those constraints using the min width and min height arguments. You can also do that for 720p, 1080p, and so on. And finally, you can pass it to the Get User Media function like before. So here's another example of us trying to fetch different resolutions of video streams. So firstly, we start with QVGA, which is a very basic image. We go with VGA, which is much larger, then HD and full HD. And beyond that, if you try to increase the request for something with additional constraints, you're going to get the over-constrained error because there's no device which can satisfy a resolution greater than 1080p. As you know, the Mac camera is only a 1080p camera. So beyond that, it is not possible. So you get the over-constrained error. We have another example here, which is also incorporating frame rates into the equation. So let's try to set the frame rate to something really low. And when we try to get media, you can see the clear the stuttering of the video, right? And when I'm going to increase it to something much higher, and you can see that it's got much smoother, right? So in this way, you can also filter out different audio devices as well based on the bit rate that the different audio devices support and a lot of other things as well. So it's a really powerful API. The next API that we have is RTC peer connection. Now this is, as I mentioned, the main part of WebRTC. This handles a lot of things under the hood. So if you can look at the image below, it's kind of an abstraction of all the things that it encapsulates. So it handles everything from signal processing to codec handling, peer-to-peer communication, security, bandwidth management, and everything in between. So here's a quick sample of how you would establish or create a WebRTC connection from your side. So we start off with the constraints, and we define some ICE servers. So in this case, it's only a stun server, but you can also define turn servers and additional servers. You start off by creating an instance of the RTC peer connection. Then you get your user media from the get user media function. You get your streams, and for every track in the stream, you add it to the peer connection object. Then you go ahead and create an offer, and this is what generates the STP or the session description protocol object, and you set your local description to that object. Now you need a way to send this across to the other peer. We'll discuss that later. And then you also need to receive an answer. So there are two versions of the STP. There's an STP offer that you generate or the caller generates. And there's an STP answer which is generated in response to your offer. So the answer needs to come back to this client, and we need to set it as a remote description. And finally, we need to handle the ICE candidates. So when the ICE candidates are generated, we need to send it across to the other client. Okay, so let's take a quick demo as well. So we use get user media to start the streams to get access to the user's devices. And upon clicking the call button, essentially it's doing all the things that we discussed in this page here. And it transmits my stream over to another video element on the same page, right? So this is a very simple example, very trivial one. But in the real world, you would be sending that across the network to another device. Okay. So let's take a deep dive into this code example. So let's say Alice and Bob want to talk to each other again. So Alice starts off by creating an instance of the RTC peer connection object. Alice gets access to their stream using the get user media and adds the track to their instance of RTC peer connection. Alice creates an offer, and meanwhile Bob also creates their own instance of the RTC peer connection object. And you need to create a handler for receiving the ICE candidate. So when Alice generates an ICE candidate, Alice needs to send it over to Bob. So Bob receives them, and Bob adds those ICE candidates to their instance of RTC peer connection. Similarly, Bob does the same thing. Finally, when you run the set local description, this is what triggers the ICE candidate generation process. And because we've already defined a handler, these will be sent over to Bob. And Bob, when he receives the audio stream, we need to tap into the onTrack method, which will receive the stream, and we can set it to the video element on Bob's end. Finally, Bob receives the offer from Alice. Bob sets their remote description to the offer, and Bob generates a counter answer to that, which is also an STP object, and Bob returns it back to Alice, who then sets it as their remote description, and the connection is complete. Okay, so here's a detailed example of what we discussed, all the steps we discussed. So first we get the device or the stream using get user media. We create a peer connection, which is the step we discussed here, creation of the peer connection, right? And then we go ahead and create the offer, which will generate the STP. And we need to send this offer across. First, we need to set it as a local description, and this will start generating the ICE candidates from Alice's side. Then we create the answer from Bob. So Bob generates the answer based on this specific offer. And then we set the answer on Alice's end, and that starts the connection. And then you can hang up, right? Okay. So between all of this, we did not discuss one step. How do we send this information, all the control information from one client to the other? So that is where we also need a server again. It's called a signaling server. And essentially, its only job is to relay these packets or the STP and the ICE candidates from one peer to the other. Apart from that, it has no responsibility. It does not need to interpret any of those messages. It just needs to relay it. That's it. And this signaling server is only used in the initial part of the process where we were establishing the connection. Once the connection kicks off, then it's completely peer-to-peer and it's fine, right? And WebRTC does not enforce a standard on the signaling mechanism. You're free to choose any mechanism that you would like, and you're left to using REST APIs. You can communicate that with WebSockets, message queues, and postcards, emails, literally anything you can think of, and even a carrier pigeon, like literally. You can generate the STP, print it on a piece of paper, send it with a pigeon, receive it at the other end, and write it down, and it will still work. Now, in our example, we're going to be using Appwrite as our carrier pigeon. So Appwrite is going to be that signaling server in between, and we're going to use the real-time capabilities of Appwrite to be able to relay these messages between the two peers. So has anybody heard of Appwrite here? Okay, a few hands. So a quick intro about Appwrite. Appwrite is an open source backend server. It is, it's basically makes your life easy when it comes to building apps. All the backend, tasks that you keep repeating yourselves, for example, the authentication, the databases, storage, and functions, and things like that. All of that is encapsulated in really nice APIs for you to use. So all you need to worry about is your front end and your business logic, and everything on the back end will be taken care of by Appwrite. So here's a quick summary of Appwrite's architecture and all the things that it encapsulates. So Appwrite is built on a microservice architecture, and all the different services are different microservices. And you can access Appwrite through the REST API, through GraphQL, through real-time, or gRPC also in the future. And you can access it with any of your favorite SDKs. We have a host of web JavaScript SDKs for the front end. We have backend SDKs in Python, Ruby, Node.js, and so on. So how do you get started? There are two ways to get started. Firstly, it's, you can self-host it. So that's the best part about Appwrite. You can completely own your data and stack. And with a simple Docker command, you can get it up and running. Or the way we recommend is Appwrite Cloud, which is one-stop solution, which is the hosted version of Appwrite. So all you need to do is create an account and go ahead and create your first project. Now, once you create your first project, you're going to have access to your project ID and your endpoint. So you can install the SDK locally, and you can initialize the SDK by creating a new client and setting up your project and endpoint. Okay, now we go back to our example and see how Appwrite comes into the picture here. In the example, when Alice was generating an ICE candidate, we just sent it over to Bob directly because we had access to both the objects in the same browser. But where Appwrite comes in is here. So let's say they are on different machines, right? So we need to send this information to Bob. So once Alice generates the ICE candidates, Alice is going to use the send to server method to send this the ICE candidates to Bob. Similarly, when Bob generates an ICE candidate, Bob also needs to send that information over to Alice, right? Then comes the STP part. So once Alice creates an offer for the call, Alice needs to send it over to Bob. And then Bob receives it, and then Bob can set up the offer as their remote description. Similarly, on Bob's side, once Bob receives the offer, Bob creates an answer, and Bob sends the answer back to Alice. Then Alice can set the answer on Alice's end, right? Okay, so let's take a look at the send to server method. It's something that we implemented. It's not something present out of the box. Essentially, it's just creating a document with an Appwrite. So you can, again, we're coming to signaling mechanism, you can use any method here to send, to implement the logic of send to server. It can be a WebSocket connection where you write to a specific channel. You can send a message to a specific queue or a topic. You can send an email. You can do anything here. The whole point is you need to get this information to the other client. That's it. So in this case, we create a document in the database that contains this information. And finally, we also need to handle the signals, right? So we discussed how we're going to send the signals. Now we need to handle the signals. So in this case, this is an example with Svelte, so where we're using the on-mount and on-destroy callbacks. But it's similar, you'll have similar callbacks in other frameworks as well. Essentially, I am creating a real-time connection to a specific, to the documents in a specific collection. So anytime a new document is written to this collection, it's going to trigger a message that I'm going to receive. And if it applies to my username and my room, or my chat room which I just created, I'm going to process it. So to process it, I have a couple of scenarios, which is the video offer, the video answer, and the ICE candidate. So based on these three different scenarios, we would be doing different operations on our end. And there are some useful tools that Chrome provides, which you can use to access the WebRTC debugging information. So let's say you have any open connections with WebRTC, you can see all the metadata about it and all the debugging information that you need, and to fix any issues that you have. And finally, we have some resources for you to get started. We have the Appwrite documentation, and this is a really good guide from the MDN docs. Really wonderful stuff. I've taken a lot of inspiration from this guide, and you can also use that to get started. And there are some really good talks about WebRTC from Google I/O, as well as some really good videos by Fireship and Traversal Media as well. And that brings us to the end of our talk. So thank you for being a wonderful audience. I hope you were able to get some good takeaways from this session. This just touched the surface, and I'm hoping that you're gonna go back and do some research and probably build some nice apps and share it with me. So yeah, thank you very much, and all the best for the next sessions.
Thank you so much, Christy. Um, I hope all of you had a lot to learn from this talk. Our next talk, oh, by the way, this was actually like this workshop session and didn't seem like a talk at all. So thank you again so much, Christy, for this wonderful, amazing workshop slash talk that you gave us. Next, we have Atishay Baid, who's an engineering manager at Birdeye. And he will be talking about maximizing efficiency and security at Birdeye through innovative front-end development. Please give a round of applause for Atishay. All the best for your talk, Atishay. Looking forward to learn a lot from you.
So hello everyone, good morning. My name is Atishay and I'm really excited to be here to share some of the insights that I learned while working at Birdeye and scaling their large-scale B2B application. So currently I'm serving as an engineering manager with Birdeye, where I have a privilege of leading an exceptional team of talented individuals. I would be really delighted if you guys can follow me on social media networks so that we can take the conversation about this talk or anything in general about JavaScript forward on the social media. Yeah. So now let's look at the application that I would be referring to in my talk. So Birdeye is a B2B application. You can think of it as an extensive hub of various micro apps in itself. So we have apps ranging from a chat messenger. You can compare it with Slack, and the scale which we are operating in this chat messenger is like any user is receiving like more than 8 to 10 concurrent messages per second. And then we have apps ranging from like a review monitoring system to a listing monitoring system, payment system. Like we have more than 15 micro apps in itself. So, and if I go by the numbers, we are operating at around like more than 1 lakh global locations, and the average session time which we are maintaining is the user uses our app very stickily. So it's like more than 6-7 hours daily on a continuous basis, and that's what I'm going to talk about. That what are the challenges that we faced with this scale. So firstly, before moving forward, let me set the agenda of what we are going to cover in this talk. So we will see that how does a front-end code base falls if there are the system is lacking, and if the code base has scaled to a large, and what bottlenecks it would present. Then we will see that why these bottlenecks are relevant in the current era, why we were not seeing this problem like 6 or 7 years back, and then we will see that why it is difficult to debug these problems. Then like I'll pick one of the problem like a memory problem, and then we'll see that how we can utilize the systems to increase the observability so that we can take the decisions efficiently. Yeah. So how many in this room are familiar with this term like enterprise user interface development or enterprise front-end development? Like what is means? Like can you like show by a raise of hand, quick raise of hands, like how many of us are familiar with the definition? All right. So when we say that a front-end code base is of enterprise level, it is very different from a back-end scale. Like a back-end scale could be like you are handling 1 million connections or a database is like operating at a larger scale, and the front-end never goes down like a back-end does. It would not like never stop like responding, but there are like few problems that will occur, and these problems will slowly occur. You will not realize that initially these problems are there or not, but once the scale is getting large, these problems would occur. So the problem, like examples are like the performance. So whenever, I mean, you are adding some new features, and you will always fear that the performance of your site is going down, the load time is getting increased, and that is a concern. And then since the code base has like increased a lot, the development cycle, let's say that you are having your dev team is having a like small ticket, like a 1 or a 3 story point ticket, but they may say that it would take around like couple of weeks to implement this, because I mean, there is a fear that something might go wrong, or I'm not aware of the complete code base, it would take a significant amount of time. The other characteristics is like whenever your code base or your end application is using like running on end devices like a mobile or like low-end Windows laptop, it may consume a lot of device resources like memory, and devices may like go wrong. You may face some heating problems and all. And then the dev team would realize that we need to refactor, we need to like upgrade the dependencies, that the version of React we want to upgrade from 16 to 18, or we want to replace that moment.js library with some like lightweight dates library, but people fear that should we do, is it the correct time or is it not the correct time? And then finally, the product development, like your business core logic implementation would impact, because again, there's a fear that, I mean, you are doing something and someone else code base or a page may go down. So now the next tempting thing which like any developer would think is that we should go for a rewrite of the application, because we are seeing a lot of problems. We should go for a rewrite, and I can share you by my experience that rewrites never work as we like supposed to. And again, you do a rewrite, it would start creating the similar problems if the systems are not in the place. So now, why these problems are relevant in the current era? Why we were not seeing these problems like a few years back, and what has changed in the current development strategies of web application with respect to front end? So the major change occurred is in the architecture or the code base which we are following. So if you go back to the era of when server-side languages were popular, like in the days of PHP or JSP, what used to happen was the server was responsible for doing a lot of the stuffs, like it would maintain the persistence from routing to data fetching. So server would generate the complete HTML, and it would send across to the browser, and browser would just do the work of the rendering. And even when like user would like navigate, there would be a complete page refresh. But now like we wanted the user experience to be better, so we shifted to a SP era. And so what we did was with the rise of frameworks like React or Vue or Angular, we tried to maintain a lot many things in the browser. Like from everything, it's more complex than maintaining a backend system. Like you are maintaining everything from data fetching to mutations to rendering to providing user feedbacks, and we did this purposefully because we wanted that the end user should be should feel better when he is using our application. And we were quite successful in doing that. But like what ended up happening was as a side effect of the we like got caught into a few other problems, like the bundle size has increased, or the memory leak has been started to occur, and the website complete size has been increased. You are caught up in the waterfalls, and that's what like average internet like survey tells that if you compare the websites that are now, like if you compare any popular web application, it's like the average is like it's like 5 times bigger than it used to be at a decade before. And this has like made even the use of the systems more important, because now we are facing like lot many problems. So we were facing like similar problems that were not very straightforward to debug. So I'll like quickly like run through a few of the problems that we were facing. So our application would slow down in long sessions. So like what users would report that, let's say we are using your app for like continuously for 3-4 hours, and like there is something which is not working, and we are seeing some page janks, and these kind of things are happening. And the other thing which we faced was like related to like how JavaScript single thread works. So as I mentioned before, that we have like extensive chat application, and like the scale was like we were receiving anything between like 6 to 10 messages any user would receive in a particular second. So what was happening was the JavaScript main thread was always busy in getting those messages from the socket, and then do the process, and then to render the incoming message. And in between, if a user would like try to navigate anything in the site, or if he would like click anywhere, he would see that the feedback is not very smooth, and that was another problem. The third challenge we were facing was how we can like secure the chatting application data, because we wanted it to be like compliant, and because people were sharing like whatnot, like their health information, their like diagnostic reports. So how should we transfer that over the wire? So what I will do is I'll like focus on one of the problem. In the interest of the time, I'll go deep into that why the application was getting slowed down, and then we'll see that how it was due to memory leak problems. And if you are like interested in knowing about the other problems or the other solutions which we did, like I'll be around. You can like always reach out to me and discuss with me. So what was happening for us was when we started debugging that, people are complaining that it is getting slowed down. The load time of any page is fine. Like our page would like load in like 1.2 seconds. Even like APIs were responding like very smoothly. Then what is the problem? So we conducted several user interviews, we went on the calls with the users, and then we figured out that there is something wrong on how our app is running in the browser if someone is using it continuously, and that's why it is becoming like unresponsive. And then like even this problem was then when I was like searching, it was like it is relevant to a lot of people, and that like on low-end devices like Windows, like a majority of the crashes happens due to this leak problems, and even like it is impacting business metrics directly, because if someone's your website page is getting crashed, there's like very few chances that someone would come back to the website and see. So it would directly impact the business metrics. Now to understand that how the memory is getting allocated, we need to see that how memory management works, like not just in the JavaScript, but to any language. So there are like three essential things any memory management system would do. It would allocate the memory. So it is allocated by any engine or the operating system, which would allow, like make it available for your program to use. And whenever your program is running, it would do some read and write operation, and that's where it would like utilize the memory. Then once the program is finished executing, it has to release the memory back to the system. And that's where the majority of the problem occurs, because releasing a memory is not a very deterministic task, and even like JavaScript engine cannot figure out that what is the right time to release the memory. Can I release it memory now? And there is always an approximation that takes place, and that's where the problem arises when the scale becomes large. So why releasing is difficult, to that we need to go again to how under the hood a garbage collector works in the browser. So again, a garbage collector again has to do three things, like it will identify which objects are or which variables are live and which are dead. Once it has done the identification, it will start to recycle. Once it has like started to recycle, it would compact like those small bits of memory. You can think of as like old school hardware, like hard disk defragmentation, which you might have done in your college days, and that's what like on the fly a browser is doing. So visually any the memory management works looks like this. So you have your JavaScript call stack, and then you have your global window. So these two things serves as a pointer to the garbage collector. Garbage collector like starts looking from the stack and global window, then it like checks for the references. So let's say there is some object which is in the stack or the window, then what other object it is referring to. Then internally what it does is it will like break down these into the heaps of like 500 kilobytes so that it can do like things parallelly. And then it will start marking the ones, and the ones which it like predicts that these are like maybe they can be used in the future, it would not clean, and it would keep themselves in the main stack. So that's how any GC is doing the it's like, and the algo is called as mark and sweep. It's marking the objects which are connected, and then it's sweeping the objects which are non-connected. And the work of this GC is not a synchronous task. So it's a combination of async and synchronous process. So the marking process would be done like synchronously when your program is running, and the sweeping would be done asynchronously. Like you cannot predict that this is the right time to do the sweep, and that is the challenge to manage the memory. And if you like graphically look it depends on lot many scenarios, like what is the available RAM of any end device, and how many objects are currently in the heap, and that's when the next GC will be collected. And if somewhere in between the memory of the end system is less, you may see the crashes or the website would be slow, and that's what was the problem which we were also facing. So I found a like funny GIF on internet. So it's not exactly like it does not like spills this, but can resemble it the working of the GC. So by seeing all these complexity, like there could be a like common question that yeah, GC is so complex, so can't we like trigger GC programmatically? So a simple answer is no, you cannot trigger GC. There cannot be any API which would trigger GC, and because it's not a part of JavaScript, and like a different browser implementation have like different versions of GC, so there cannot be a global switch. So like what we can do and how we can like start debugging the memory problem. So the number one step and the simplest one would be go to the Chrome Task Manager. It shows the memory. You can like right click and go to the JavaScript footprint. It's a snapshot of our like footprint like a while back, and then when you realize that yeah 1.2 GB or it's large, then you need to go to the next steps. So then then you can go into the performance tab to figure out that what exactly is leaking the memory. So that's what like I was like we were doing the navigations, and then we were checking that how the behavior is working. So video is little blurry. Let me go to the results. Yeah. So for us this was the like so this so the line was like really vertical, and you should always check for these patterns. If these patterns are there, that means there is a memory leak. I mean, using memory is never the bad thing, but it should go down immediately or in a while. And now once you figure out that there is a leak, so what all the objects are there, you can go and do a heap snapshot, and heap snapshot would like give you that what are objects are currently objects or arrays or anything what is currently present, and then it shows the like couple of things like shallow size and retained size and distance. Like you can ignore, it's just the distance from the window object, but these two things like shallow and retained are really important. So a shallow size would like tell you that whatever memory it is consuming, but it would not take care of the references and the like child parent things. But retained will be the most important one, because once that variable is deleted, it will show that how much memory would be free if you delete that memory. Then in the snapshot you can like figure out that, oh, which objects, and now the next step should be to go to like if you see this by a code, like there are like 3 objects, object A, B, and C. The like shallow memory of object A object would be just the like size contained by the object, but the real memory would be the circular references which it is doing. Then next would be to go to exactly the code base which is creating the problem. So for us, when we did the allocation sampling, it is a wonderful tool. It will take you to the like exactly the code base. So for us, the culprit was using immutable JS with Redux. So what was happening was we use immutable JS purposefully because we want like every time the fresh objects, but what end up happening is like the immutable JS in large scale, like it creates very detached objects, and these objects does not get cleaned very easily. And this was the main culprit of, because we were using like immutable JS in map state to props, and every time like there would be a read and there would be a like a memory leak of a large object. Yeah. Then like what should be a standard size of a web page? And there is no like straightforward answer that how slim a web page should be. And to figure out, you need some methodologies, like you can do some debugging or you can do the methodologies which I'll be talking about. And there are like several misconceptions when it comes to like memory or like how JavaScript is working. So it is like very popular saying that yes, JavaScript is a fast language, so these problems should not occur. So let's figure out that does this like holds true in JavaScript. So there was a like bunch of scientists who sat down on the popular languages, and there was a research conducted on this part, and then they ran through like various algorithms like a binary tree or a hash map or a linked list, and how JavaScript is working under the hood. And then they figured out that there is no relation between like how JavaScript is fast and how it is relating to the memory. So they came to a conclusion that it's not always true that language which is fast can never be a memory efficient. There is no correlation, but there is a straightforward correlation that if you want to make a website that is fast, you have to be memory efficient. And then like people may argue that why can't we catch the memory problems in the code reviews? Yeah, I mean code reviews are great, but they from my experience I can tell you that they don't work at large scale, because like people may not have like that attention to the details of these problems, and like everyone gets tired, and they cannot like figure out that yes, this would relate to memory or anything in general, which that cannot be like predictable while reviewing the code. So what should we like do? So you should like always like have some systems in place which would like help you to generate this architecture, and they will help you to like predict these problems, because once these problems are created, it would be like really hard to debug and then to fix problems. So what you can do is there are like several APIs which is available. So there's a recent API, it is currently experimental. It's like user agent memory. It gives you like this user agent memory. It gives you can like add it as a reference in your code on any event listener, or you can like trigger that whenever this user memory is like exceeding a particular threshold, you can like connect a webhook and send an alert. Then you will realize that yes, it is like having a problem to the end user, because while developing or while testing your QA team or on your like pre-prod servers, you will not be able to figure out. The other thing is you can always like write the test cases, and these test cases are really important, not just for the memory problems, but for other problems in general. You can write the assertion, you can have some markers, and every time like someone changes the code, you can have this as a like GitHub action, and these test cases would say that yes, everything is correct or everything is not correct. Then there's a like very good open source software that was released by the guys at Facebook, like memlab. It does the work to some extent to analyze the like JavaScript heap and what is the like leaking in the browser. It like attaches some markers, and once it runs, you can figure out that yes, the code pattern has changed, and then internally you can attach it with some analytic tools to see that how the memory or anything in general is like changing with respect to your builds or with respect to the PRs. And even you can utilize, like, I'm a big fan of Puppeteer, the headless version of Chrome. You can like configure your integration test using Puppeteer, and this Puppeteer can help you to detect memory problems. Either you can use the API performance.memory, or you can use user specific memory, but this will give you a good indication of like how a system is behaving. So overall, like what I'm like trying to tell is these systems should be the base of any architecture when you are developing any front-end application, because people don't realize the importance of test cases or any system, because when you start, the code base is small and it works wonderfully. The bundles are small and it would work wonderfully, but once it reaches a certain level, or once your dev team size has increased. So for us, like our dev team currently is more than like 50 people who are working on a like single repository, because that's the scale now we have reached, and that's where like problems started to occur. And you cannot like blame anyone. You cannot blame that you reviewed his code and why his code is creating the problem. And that's why for any software architecture, the system should be the baseline, and then you should think about once the system's in place, because in this current era, if the systems are not in place, like sooner or later you will realize that problem has occurred, and even like the productivity of the team would like really hamper, and you would be fixing the bugs over like weekends, and you would be arguing that why the website is not performant, and why the bugs are increasing, and why like people are reporting, because maybe internally you would say that the lighthouse time of your page is like couple of milliseconds, but when users are using it for longer time, is it like just the load time you should measure, or there are like several other things which you should measure, and without systems you cannot measure it on the production. And then you should go for the processes like code reviews, architecture blueprints, and these things should be the second to the system. And then on top of it would be the patterns, like the frameworks like React or Next.js or any design patterns that you should use. And that's how you should like structure any front-end application, or even you structure your team. Yeah. So that's all for my talk. I hope you guys enjoyed it, and you guys took some like lessons from this. So if you have any questions about this thing or the other problems which I was referring, you can like, I'll be around, you can reach out to me, and we'll like, I'll be more than happy to discuss the things. Thank you. Thanks everyone.
Wow, wow, that was a super amazing talk. I think also very technical and greatly put, so thanks a lot for this talk. I think now my brain cells are like just have nearly exploded, all listening about heaps and memory leaks, so that's something that I have not been good at since college. But yeah. All right, so time for introducing our next speaker of track 2. I'm sure I think you can guess him while I give the intro. He is an associate software engineer at Red Hat. He's super passionate about stuff at open source and all, and he really loves like coding around like things like monorepos, and that's also what his talk is all about. So we have with us Aditya Krishna, who's going to enlighten us about some interesting usages about monorepos at Red Hat. So please give a huge round of applause to Aditya Krishna. Hey Aditya, how are you? How's it going?
I'm fine, thanks. How about you?
Yeah, doing good. But I think, Aditya, I know like where you're from, but I want these people to guess like which is that exact place that you're from, right? So how about maybe play a small game with our audience? Definitely. Yeah, yeah. Okay. So let's start with a small game, right? You folks have to guess from which place in India he is from. I'll start giving you maybe some small hints to help you out. Okay, let's start with the place is on some southern side in India. Any guesses? What can be the place? Okay, I see Kerala. Okay. Who else? Bangalore. Okay. So Kerala and Bangalore, two options. Okay. I'll give you some more hint. I don't want to. There's very Hyderabad, Chennai. Okay. South mein there are so many options. All right. One more hint that I'll give is that place is known for its traffic. Bangalore. Now it's obvious. So Bangalore. Is it Bangalore, Aditya? Is it? So Bangalore it is. It's open.
Oh, sorry.
That's how
Yeah, it is Bangalore only. And though I would argue that there's not too much traffic like a proper Bangalorean. So,
So I'll maybe start with you. What's the best thing you love about Bangalore?
the street food, I really love street food. And then the filter coffee. Visited a couple of parts in India, but the filter coffee is next level in Bangalore. And then, we have conferences, meetups happening every week. You get to network with a lot of people. And yeah, the weather, obviously.
Oh, nice. Yes. Oh, yeah, definitely. I'm going to ask you for some good references of filter coffee after this talk, by the way. But yeah, I'll not take too much of your time. So without any further ado, let's start with the talk. So Aditya, stage is yours. Give a big round of applause for Aditya.
Am I audible? Okay. Namaskara. My talk is related to monorepos and how we basically use it at Red Hat. Okay. To start off with, I have a small joke. So, why did Monorepo go into therapy? Oh, any guesses? Because basically you merge, you split, and then you give rise to conflicts, and that's real-time commitment issues for you. So, yeah. Okay. So yeah, Nikhil actually introduced me, so I'll just skip this slide. And then this is the agenda. We are going to talk about basically monorepo, polyrepos, and at the last, how we use Lerna at Red Hat. So yeah, monorepo. Okay. Yeah, monorepo. So you basically use one repository for the whole source code management. And let's say you can consider this room to be a monorepo, and you individual people will be the specific projects or various packages inside a monorepo. And another thing is all the code components gather under one roof basically. So basically like a family reunion kind of thing. And coming to polyrepo, you basically have let's say for example, you have 2 or 3 projects like components, you have configs, utilities, etc. And you divide them into multiple things or multiple repositories, and you have a specific repository for each of them, and that is polyrepo. Now, before we move on to the next slide, polyrepo. Another thing. Okay, sorry. Yeah, basically polyrepo. We at Red Hat also we use a lot of polyrepo things, and we use micro frontends as well. And coming to the similarities, both architectures ultimately track the same source code. And for our project at Red Hat, we use Monorepo itself, and a sibling project uses polyrepo. Now, coming to the differences. So these are basically a couple of differences, and then let's say you have a monorepo contains multiple projects, and then a polyrepo contains one single project or product or something similar to that. And in a monorepo, let's say you make some change, and this enables all the workflows unless you have proper ignoring specifications given. And yeah. So the various monorepo managers out there are, we have NX, we have TurboRepo, we have Buzzell, and Lerna. A couple of months back, the stewardship of Lerna was handed over to NRWL, that is the company behind NX, and they have been doing pretty good work, keeping Lerna up to date. Now, yeah, we have local computing caching. Yeah, so what basically you can consider local computing caching? I would say it's the ability to store and replay file and processes or output of task basically. And then you have local task orchestration. So yeah, for this something is like, it's the ability to run tasks in correct order and in parallelly. So let's say most of us are here. We are listening to my talk as well as using phones or probably chatting with the person next to you. So you are basically running multiple tasks parallelly. This is basically like local task orchestration in layman terms. And then you have distributed computing caching. So it's the ability to share cache artifacts across different environments. Basically, you have a dev environment, you have a prod environment and all, and the cache is shared across multiple environments. This can include CI as well. A couple of tools like NX, TurboRepo, and even Lerna also allow for distributed computing caching. Now, distributed task execution. It's the ability to basically distribute command across many machines while we largely preserve the ergonomics of running it on a single one. So in layman terms, I would say, let's say you get multiple tasks or issues or something like that, and then you divide it into your team. You give a front-end person the front-end task, back-end person the back-end task and all. And you basically ensure that all the tasks gets distributed and executed at the same time. Now, determining affected projects or packages. So let's say you do a specific change in one of the package in a monorepo, and then you would not want to have like run build for each and every packages in the monorepo, right? So a very crucial feature of monorepo managers is to determine what changes you have done and only publish those packages. Now, coming to the demo, I'll be showing you a small demo of how we use Lerna, and even we are kind of working on a POC to migrate it into TurboRepo. But due to a couple of constraints, I'm not allowed to show the TurboRepo one. So yeah, Lerna and how we use basically, we use all of the features what comes with Lerna, like we have bootstrapping, publishing, versioning, and running commands concurrently. Bootstrapping is basically, let's say you have multiple packages in a monorepo and you want to run npm install in each of them, and you give Lerna bootstrap and it installs in every other packages. Publishing is something like, you have you have made changes to a specific package in a repository, and you want to publish that specific package using your CI or your CLI itself basically. And you can do the same using Lerna as well. Turborepo actually does not support publishing of packages unless you use some other tools like change sets or npm workspaces. And Lerna can also run commands concurrently. So this is a small diagram of basically how Lerna bootstrap works. So let's say you have the before thing shows one package having you have child A and child B being the packages, and then child B is at one version, and let's say you run Lerna bootstrap. After that, you basically the node modules and the build file of child B gets copied into child A, and you can use the child B inside child A basically. Now let me show you a small demo. Okay. Yeah, so this is basically what our project is. I'm working on the team which is responsible for the customer portal of Red Hat, and then you have these packages like APIs, cases, components, config, utilities, and permissions basically. And then all of these are inside one specific repository. That's the very secret Area 51 app. And now, yeah, so we have Lerna to do most of our tasks like, Lerna can bootstrap, and this is another feature in Lerna basically, hoist. What it does is basically, when you run Lerna bootstrap, the node modules get copied into each and every package. But let's say you don't want to do that and you want to have it globally such that only one folder will have the node modules. So you can do that by using hoist, and then we have the build script which runs build in all the packages, and even for test also we have a thing such that it runs test parallelly. So this is one thing. Now let's say if I do something like so this is like a was created in a very urgent manner. I have perf.js that is responsible for showing the current time, and then we have npm run build, and then again perf.js. Now you may get a question like, why didn't I use performance.now, which is available in Node.js? So for that, we are currently using Node version 14.18, so that does not support performance.now yet. So let's say if I run this run build, and I have the time set at 10:50 to 41 seconds. So this is going to take a couple of time to build the application basically. So until then, I'm so I have a joke for you. So polyrepo. Why did a polyrepo go on a diet? Any answers? Basically, it wanted to become lean and mean, so that's why it basically went on a diet. So yeah, currently what's happening is all the CSS from various packages are getting copied, and then it will be put into a build folder, and it's the same case with the code as well. You have UI components in one, and then utilities and all, and this come together and will be run parallelly to give a build thing. So yeah, if I'm not wrong, we started somewhere at yeah, we started at 10:52:41, and then the current time is somewhere around 54:14. That's 1 minute, some odd seconds. So if there's another one actually. As Lerna stewardship was handed over to NX, so what NX did is they basically added some steroids to Lerna to make it even more buff. No. Okay. And they added a new feature in NX. Like again, this was a couple of months back itself. Using one specific flag, use NX, you can instruct Lerna to send all the commands to NX, and NX will take care of it under the hood. So if I just enable it like true, and then if I run the same command again, the performance difference is not a lot, I would say, as ours is not a very huge monorepo, and the gain is somewhere around 10-15 seconds, but still we are saving some time. And then if it comes to CI, as the performance of my specific computer is a lot higher compared to the CI. So in CI, it actually gives like a benefit of around 30 to 40 seconds, which is like a very huge saving. And even for running tests or running build bootstrap, the CI is pretty fast if we use NX compared to Lerna. Even though we are using Lerna on the surface level and NX works under the hood, but just enabling NX flag, use NX to be true, it can actually give you a very significant improvement in terms of performance. Okay, that's So 10:56 it started, and it's somewhere around 10:57. I would consider it to be. So again, it's not a very huge improvement in terms of the whole thing, but again, 10-15 seconds on your local PC wouldn't matter much, but having like around 40 or 30-40 seconds in CI is gonna save a lot of time. And let's say you create a change, you basically add a new feature, and then you have multiple commits. You send one commit, and then the CI starts running, and it checks for, it tests, it runs the lint check, and then it again runs the build check. Here, for all the three things, you can consider the amount of time saved to be somewhere around a minute to 2 minutes. And then if you again use Lerna, you're gonna have a disadvantage of around 1.5 minutes per each commit. Let's say you send one commit, and then after a couple of minutes you send another commit. If your changes are tested, sometimes we tend to send test changes, if I'm not wrong. So whenever you send these test changes, you basically want to check, okay, if the CI is running or not. And then at that moment, I would say saving a minute or two is a very huge improvement. So yeah, that's basically the whole thing related to my talk. I was supposed to show a small POC of how we use TurboRepo. That's something which I've been working on. But yeah, due to some constraints, I won't be able to show that. Yeah, thank you so much, everyone.
Thank you so much for this wonderful talk. And it's okay, glitches happen, but it was amazing. Do you all agree? Okay, I see there's a little dull energy in the room, and I don't like it. So maybe we'll liven it up a little. I want some volunteers coming in on stage. 4 on my side, 4 on Nikhil's side, please. Come on, come
So
on.
we're gonna play a very
Have a
fun
cup
game.
of coffee maybe and come
Who's
back.
up for something fun?
4 on my side, 4 on Nikhil's side.
Let's see some raise of hands who wanna come. Any people?
Yes, please,
Yeah, we have
please,
some.
directly
Yeah,
come.
please.
You don't
Let's
have to
have them
raise
on
your
stage.
hands.
Who else? Who else? How many people do we have here?
Can we
So
give
2
them
here?
a cheer, please? Okay.
All right.
Team
We
Nikhil or Team Varsha? Okay.
He's on my team now. Okay.
Okay. Come
3
on,
people.
people. Come on. You can
There's still
come on
one
stage.
place. Who else? Okay, we have one. All
Yes.
right. Oh, yeah.
Yes.
Yes. You just got live stream.
And that's the trick part of it. Okay, okay. We have 3 on my side, 2 on Nikhil's side.
Actually, now there is. Okay, so there are 3 now here.
Ah, you got 4. I need
4.
one more, please.
So one more now.
Team
one
Varsha
more
is already
person who
losing.
can.
I don't want to lose.
Come on, guys. Who can join us? Who can join us?
Come on. Yay.
Yay.
Girl power.
Okay,
and
so
a
we have
diversity.
now the teams are balanced. Okay, so now we have some balanced teams.
Okay, a big round of applause for all our volunteers here, please. It's going to be fun. You don't want to miss it. But let me quickly ask your names, please.
I'm Nehal.
Sakar.
Simran. Shweta.
All right.
Okay.
And on this side,
Hi, I'm Juhi.
I'm Nikku Singh.
Utsav.
Hi, I'm Lavish Goel.
okay, awesome. So I think I'll call my team Vada Pav. How's it sound?
Okay. The Dosa team. We have the Dosa team and the Vada Pav team competing with each other. So Nikhil and I are going to give scenarios to each other, right? So I'll give one scenario to Nikhil's team, and Nikhil will give one scenario to my team.
All right.
And the challenge is that you have to sing the first song that comes to your mind when you hear that challenge, right? And you will get on the clock 10 seconds. Nikhil, do you have a stopwatch? Because I left my phone
Oh,
there.
yeah. I have this.
You will get,
We
don't
have some
cheat,
time on it.
don't cheat.
No.
You will
We
get
are fair
10
players, so
seconds
we don't
each,
cheat.
right? To sing the right song or the most apt song in that scenario. Are we cool?
Yeah.
Shall we start?
So, everybody excited? Should we start the challenge?
And the job of all of you people is to judge who's the winner. Okay?
Yeah. So I think I don't rely on you, but I rely on these folks. That
Yes,
they
I don't
will be
rely
fair.
on you either, Vada Pav. Let's
see,
get
let's
it
see who
started.
wins.
Let's have the
Vada
first
Pav.
scenario.
Okay, so I think we'll start from our end and let's give a scenario to them.
Yes.
So one scenario that we can give is, let's say you have so you are planning some party on a Friday night and suddenly an incident pops up. So what should be the song that you should? Yeah. So what will be the song? So a bug on a Friday night and an incident. What will be your song? Let's see which song can be most appropriate.
तड़प तड़प के इस दिल से आह निकलती रही, मुझको सजा दी बग ने, ऐसा क्या गुनाह किया जो लुट गए.
That's a nice one, yeah. All right. Then I think we'll switch turns maybe.
Yes.
And,
And the scenario that I would like to give to your team is that you are happily working from home, but your evil manager calls you 3 days a week to the office
ooh, interesting one. That will be easy.
in Bangalore traffic.
No. Come on, guys. We can think of something. Come on. What can be that song?
8, 7. Okay?
In the end, it doesn't even matter how hard you try. You still have to go to office when your manager calls for it.
Are you trying to sing the Linkin Park song? Can you please sing it better? In the audience, anyone? The Linkin Park song? Okay. I tried so hard and got so far, but in the end, it doesn't even matter.
Right. Nice one. Big claps. All right.
So, audience agrees it's a tie, or are we better?
It's a tie.
Oh, okay.
Maybe let's just maybe vote. Who all are with like this team Dosa? No hands. I don't see hands. Okay, how many hands are there? Seriously.
I see no.
Who all think team Dosa did better?
Yes.
Okay. There are some hands. Okay. Can I have a cheer for team Dosa? Who all cheer for team Dosa? All right, and now for the real team. Who cheers for team Vada Pav? So I think I see like a mix of emotions here.
I see
So there are
too.
some mixes.
Okay, next scenario, please, Nikhil.
Yeah, okay. Does my team have any scenario in mind? Any ideas that you have?
Any ideas?
You are on a weekend trip and production goes down.
That's the same thing as Friday
I think
night
the same
bug,
thing
right?
Yeah, okay. This is like a very, a very different one. So you come to your office off-site and you're struggling to find a PG or like a place to stay. So what will be your song in that case? By the way, like till the time they are like thinking of this, who all like relate to this?
So you were working from home.
Who all
and
relate to,
now-
like, finding
and now
PGs
people
here
have
in
called you
Bangalore?
here, right?
Only one
so
person?
you need to find a place, and you are struggling to find a place to live. That's not even a fun scenario. Come on, you can give us better scenarios.
Yeah, this was a good scenario, no? So like maybe let's try thinking of something different.
Yeah, you're giving
Any
us
other-
sad
any
scenarios.
other
Give us happy scenarios.
Any other
Okay,
thing?
I'll throw a challenge. Okay, maximum number of challenges also wins, by the way. So I'll throw a challenge. You just got calibrated. You were expecting a promotion. You didn't get one.
Oh.
Okay, you were not expecting a promotion, but you got one.
All right, Team Vada Pav.
10,
Do you have any ideas?
9,
Yeah, you have just given the scenario,
8.
no? How? Unfair team.
Okay.
Oh, we got the song.
Okay.
Yes, see?
Yes.
Overpowered team already.
It's a song by Adnan Sami. मेरी भी तो lift करा दे, तो lift करा दे. Something like
No, but awesome, awesome. Such a perfect. Nice, nice.
Yeah, nice. Good suggestions.
Okay, give us a happy scenario back.
Okay, let's think of some happy scenario. So, Team Vada Pav, any scenarios in mind? Let's try to have some happy scenarios for these people. When your manager's off. Oh, heaven.
When the manager is off,
When the manager is on leave.
is on leave. Oh, it's not off. I assume.
उड़ता ही फिरूं इन हवाओं में कहीं या मैं झूल जाऊं इन घटाओं में कहीं एक कर दूं आसमां और ज़मीन yeah.
Awesome, awesome.
Nice,
A big
nice.
round of applause for both these teams. Such fun people.
Yeah.
Can we now say that Team Dosa is winning? I need a yes.
No.
Oh, come
no
on.
cheers. No cheers at all.
Do you have like planted people in the audience?
We have not, like, they are the most, intellectual people here that I can see.
Ah.
And they are the most, best. Yeah, most. So let's go. I think maybe let's help them out a bit. Maybe let's give them one more scenario for them to
Okay.
decide. Let's have a decider round, like the
Okay,
one last
the
scenario.
final. I think
Yeah.
the audience should give the scenario, and the
Yeah.
one who sings the better song wins. How about that? So anyone in the audience wants to give the scenario, I'll come down and give you the mic.
Yeah.
Anyone, please show
Yeah,
of
we have-
hands, please, so that I can come to you.
I can already hear some suggestions, but yeah, let's have a show of hands. Whoever wants to give a scenario.
I hear a
Yeah,
murmur. Yes.
yeah, there are some hands on the back.
Okay.
Changing the product specs after the development is done.
Nice. Changing the product specs after the development.
Okay.
Anyone from the audience wants to sing a song on that? Anyone? Oh, by the way, you'll
Come on,
get a
people.
goodie if you do sing a song. So,
I know they're like very talented people, just like Team Vada Pav here, who can sing good songs.
oh, come on, Team Dosa rocks.
we have a
Let's see if there are like amazing singers here
Anyone?
in the
Anyone
audience.
from the audience wants to take this?
Yeah, I think I see one hand here.
Yes, I see a very reluctant hand going by somebody else. Let's do it.
क्या हुआ तेरा वादा वो इरादा दिल जिस दिन तुम्हें मैच नहीं कर रहा
Nice.
Trishla
Lovely, Trishla. Okay.
different pair of footwear in office
Different pair of footwear in office because you were in a rush or something. Okay. Okay. That's a very quirky scenario. I've never heard of it. Have you ever worn different pair of footwear in office? Okay. Anybody wants to sing a song on that?
Well, I think for this scenario, my team,
Yes.
my awesome
Please.
team has one song.
Please.
So yeah, let's hear it up for them.
so it's a song by Kishore Kumar, I guess.
Okay.
So मेरा जूता है जापानी ये पतलून इंग्लिशतानी
सर पे लाल टोपी होती फिर भी दिल है हिंदुस्तानी
मेरा जूता है जापानी
Awesome. This was really good. Okay, I think Team Vada Pav and Team Dosa can come back. And both of you did great. I wouldn't take audience vote on it because you all are biased. But both of you will get some goodies. Please.
Yeah, give it a big round of applause for all these people and you all in the end.
Volunteers,
Round of
can we
applause.
please note down their names, please? Can we
All
please
right,
note down their names, please?
Yeah, please take your seats. Thanks a lot.
Now, I want another set of people, 4 here, 4 there. This is, again, going to be something amazing. So 4 people this side, 4 people that side. Anyone,
Right,
any
come on, people.
volunteers?
Let's see some new faces this
We
time.
won't ask you to sing, don't worry. This is going to be much more complicated than that. Anyone,
Let's see
any
some-
volunteers here?
Come on, people. Are there some
I
new
see
faces?
a murmur in that area. Yes, 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 go for it.
Yes, nice.
Anyone else? Do you want to come on stage? Please.
Hello, hello, hello. So I think we have 2, okay?
Yes.
Yeah, 3 from this side and 1
Yes.
here. Nice, awesome.
Anyone else? You, sir. Yes, you. No, 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 no. Don't point to someone else, please. Thank you. Thank you for
All right,
cooperating.
nice.
Anyone from that side? I see a group of guys not even looking at me, pretending hard not to be seen. And now you're smiling. So please, please, I'm inviting you to the stage. Please. Come on, you can do it. Be a sport. Come on stage. Or
Oh, I think we have
nominate
one.
someone.
Yeah, that's the spirit.
Okay, nice. I think we do have 4, but I have my eyes on you. I'll get back to you. Okay, so the next challenge round, and this is going to be tough,
Okay.
is that each of these teams, 4 of you, right? 4 of you each, have managers, right? Or are you a freelancer or something? Managers? You all have managers? Okay. I want the most honest 2-word feedback
honest.
for your manager. Most honest. And the audience will decide who's honest. Your managers are not here, right? Okay, good. And the audience will decide who has given us the best or the most honest answers about their managers. Because trust me, I don't like mine either. So, shall we start?
Oh.
I am a manager, but my reportees still don't love me.
If you ask that, na, you will say
No,
that
no,
I
you
love
don't
my
have to give me good boy answers, okay? Give
Only
me the dirt.
honest feedbacks.
Honest feedbacks. Let's start.
I have a positive feedback. Hi, my name is Lippy. I'm from Zeta. So I actually have a positive feedback about my manager because he's pretty cool. He gets blackout drunk with us on the offsites. So I'm not going to deny
Nice.
that he's not cool.
Okay, thank you for that honesty. Blackout drunk on offsites. Okay, thanks.
Yeah, hi, I'm Nitin. I'm also from Zeta. So about my manager, he gives me some tickets. Yeah, so he gives me some tickets to work on the sprint, and then all email or anything he gets, like he forwards to me, and I work on those. And after 2 weeks, I say, ki, I didn't work on this, I worked on this. No, it's not changing the requirement. Like the thing I do is not the thing that is decided in this.
So you're saying that his expectations and your work do not match. But whose problem is it? It's the managers or your problem? Definitely the managers. Definitely the manager's problem. Okay, good. Thank you for that honesty.
Yeah. Hi, this is Trishla from Zeta. So, yes.
Oh, so this is team. Yeah, there's actually team Zeta here. Oh, nice.
I'll say my manager is somewhat diplomatic at the time of review.
If Zeta managers are hearing this, you can find us on track 2 and you can find the relevant people.
but he's really supportive as well.
Ah. It's it's the prime time to say, okay.
That's very necessary in this culture now.
Nice. Okay.
But I like
You're
the
not from
honesty.
Zeta, right? Okay.
Hey all, I am Anamika and I work at Philips. So my manager is very chill until I fix the bug that I have created.
Otherwise, we want to know the other side of the story.
No, he will come with serious face and tell me to fix it as soon as possible.
Okay,
Alright.
we had some good managerial
Yeah.
feedback here.
So I
Let's see
think-
what you got here.
Yeah, let's see what the team here has to say. All right.
Hi all, my name is Praveen. So there are a lot I can say in, yeah, so there are a lot I can say in plus point, but I don't want to do that. So there are some negatives, why I don't like my manager. So they give you some timelines, or they want to finish your task within the timelines, but they want you, in same time, you will be calling in all the meetings. So if you are in meetings, I don't work. Or if you want me in meeting, like either give me meetings or work. I can't handle both at same time.
God.
So yeah, it's a developer perspective according to me.
I think this was an eye opener for me because I do the same. I expect my people to attend meetings and also work. So, sorry.
That's okay. That's okay. I don't mind. Like, she's also a manager.
Yeah. We'll find one for you. You and me and your manager should chat.
Yeah. And you are? All right. So let's go to the next one. Okay.
So I'm from Bloomberg, and my manager is pretty chill. I think we give him more trouble. So most of the time, it's like a team of 11 people, and sometime or the other, someone is saying कि मजा नहीं आ रहा काम में. So like that's I think his main problem, and because there's a lot of like retention in our team, so सब लोग leave कर जाते हैं, तो that's a big issue. So he's kind of scared कि अगर मजा नहीं आ रहा, then that's a big issue.
Oh, so you scare your manager.
So this is that code word of a manager. Like whenever things are not right, he'll just use "maza nahi aa raha hai," and you're like, "Now he's
So
isko
to
maza nahi aa
everyone
raha
who's
hai."
troubled by their managers, you can just say "maza nahi aa raha hai," and
Yeah.
just leave.
Now, this can become a secret code word of managers, no?
Yeah.
And whenever they are like pissed off or like they're not happy, "maza nahi aa raha," and everybody will like, now we are going to be in big trouble. All right, let's go to the next one.
Hi, this is Nafis from Waymo. My
Sorry,
manager.
can you repeat that and can you hold that closer?
Okay, I'm Nafis from Waymo Software, and my manager is very supportive. But when a critical issue comes, yeah,
He's like the
Yeah.
devil with the horns,
That's
huh?
what.
all right.
That is the main problem.
How do you handle that devil?
That time I don't say anything.
I
I just listen.
Nice strategy.
That's nice. I like the honesty. All right, time for the last one.
Yeah, I'm Abhinav, and actually mine's a little different because I come from a non-profit organization, and so basically we are actually a research organization turning into a venture-based organization. So the problem I think I have with my manager is like she's too soft-spoken, like very much soft-spoken. So because of the non-profit
Oh, so she
culture,
cannot be tough. She
Yeah.
cannot be the tough girl.
Yeah,
and
so I feel at times that she requires to be that the tough person around.
Interesting. Anybody in the audience, now that you know what we are asking, any insights, any innovative insights on your manager that you want to share here? The dirtier, the better. You stand to win goodies. So it's goodies versus, buttering your managers. So decide.
I think they might also have a lot, Varsha, to discuss. But I think now let's also like get back to the main event to like.
Is it
listen.
11:20 yet?
Oh yeah, definitely.
Okay.
I
But
think these
since I
people are
already
waiting.
asked the audience, can someone quickly?
Okay, let's have some quick thing. Anybody who wants to discuss something about their managers, don't worry. We'll cut this live stream. No worries. Okay. Do we have some? Okay.
Yes, we do
There is
have
one.
one.
I see a very strong raise of hands, so I think you have something very interesting to say.
I'm actually kind of scared.
Is your manager here?
Not really, but then my colleagues are here, so it might go to office.
Who
But
are,
then,
who are his colleagues who are present in the room?
okay, you need not dig deeper. So what happens is, although he's really cool as a person, right, also might be an empathetic being, but then there is one thing that kind of pokes me a lot, that he's from backend domain.
and I'm a full-fledged core front-end, developer.
Okay. So you
And
know more than him.
I mean, if you ask front-end, maybe yes.
That's what it is, right?
So then, what I feel many of the times, I get a little vibe from him that he consider front-ends to be like not as significant or not as, like a heavy lifting as could be a backend.
Boo!
And there are many people who are like, okay, we are the mainstream developers. That's the backend. But
okay.
then
I
I'm
didn't know.
like very much, you might be true maybe 10 years back, but the industry has evolved a lot and the
I
things and
agree with
situations
you.
are different now.
I agree with you, dude. I don't care if your colleagues are here. Front end rocks. Can we say that out loud, please? All you front end developers, we rock, right?
And to some people, not my manager maybe, to some people it might be like, hey, they just play with colors and some HTML template.
Yeah,
markup,
yeah, yeah.
that's it.
Say
Is it?
that's what we
No,
do.
no. It's not that simplistic, simple actually.
You're from which company actually? So I
Why
got
are you
this
on
one
a call, Nikhil?
Yeah,
Are you
sir.
done?
Yeah, sir. He's with me. You can find him on track too. Yeah. But yeah, no worries. Just
No,
kidding.
no,
yeah.
but I'll take class of your manager because front end definitely rocks and our next lineup will prove to you. I mean, you don't need any proving because you all are belong to the same group. But let's welcome our next speaker.
All right.
Yes, we'll say goodbye to you all. Thank you for being a sport. Thank you for helping us out, figure out what we do collectively bad as managers. I have some notes to take.
All right. Over to you, Varsha then.
Right. So our next talk is by Siddharth Dayalwal. Siddharth, can we have you on stage, please? A very good morning, Siddharth, and thank you for joining us.
Boss.
Yes, that's the energy we need.
Yay!
Siddharth will be talking about creating scalable and flexible web applications in a headless approach. I think maybe you should tell your manager that, right? Okay, over to you, Siddharth. Have a good talk. Thank you, everyone.
Hello. Just bear with me while I'm connecting this. Oh, it is actually connected. But I do not need to show everything to you all, so I'll just hide a couple of things because, of course, secrets, there should be secrets everywhere. So just bear with me quickly. Cool. All right. I guess this is good. Sorry for that. Cool. So, hello everyone. Can I get a quick hooting or something? Just like a wave, a hand raise, quickly. Hey everyone. Yeah, that's what I like. So this is what we're gonna do actually. This is a lightning talk. I'm not gonna take much of your time. Quickly, let's say 7-10 minutes hardly. That's even more I'm saying. But welcome to my talk. Thank you so much for being present at track 2. I know there are 2 tracks and you sitting here skipping that track means a lot to me actually. So thanks a lot for staying here. Of course, this is me first time speaking at Jsconf India. So I was quite looking forward to it. And I'm quite happy to be here, interacting with a lot of folks, a lot of people I actually know, and I'm knowing more about many others today. So yeah, excited for that. But as you can see, Headless CMS creating scalable and flexible web application, that's what we're gonna talk about. But is it that actually? We'll get to know while we are proceeding with the talk. I'll say Nama, you'll say Bangalore. Sounds good? Nama? A little louder, Nama? Yes, that's what we wanted. So thank you so much for being here. Talking more about me, I am Siddharth Dayalwal, as mentioned by the host.
I am working as a developer community specialist at Storyblock, which means I look out for all things community, programs, and events there. I'm also a GitHub field expert from the India region. I'm a major league hacking coach, organizer for Hack This Fall, and of course, speaker for today. But before even jumping, I really want to share this special thing that we are giving away a couple of things on our booth, which you can find in the community lounge, so make sure you check that out. And don't forget to take some good pictures while I'm talking so that you can tweet about it and get some cool swag from our booth. And also you can take a quick photo of this because we are giving I get .our subscription worth $200. So I guess I would not miss as a developer. I can get any front-end course for me using this one. So why not? Let's give it a try. Cool. But moving on, let's talk about this term which you see, Swiss Army knife of the web. Now, if you might have attended my talks from previous conferences, I've used this term over there as well. So how many of you all know what Swiss Army knife is? Quick raise of hands, just that. Couple of them. If you have watched Men vs. Wild, you might have seen Bear Grylls using that on a daily basis, and I am very fond of this tool because this is multi-purpose. I can use it anywhere for anything, right? And Headless CMS is kind of a Swiss Army knife, but for web. How? We'll talk about it. Yeah, that is Swiss Army knife for all of those who didn't raise their hand. And this is the web, but you see an exclamation with a red icon over there. Of course, there is something which is missing, and which is Headless CMS. So can anyone, like, even before jumping on that, how many of you all know what Headless CMS is? Quick raise of hands, once again. Only a few, but I am hoping that after my talk, you would know more about it actually, and even if you can't know, we already have our own booth at Storyblock here in the community lounge. So when I talk about Headless CMS, CMS stands for Content Management System. Now you might be knowing about something like WordPress, right? Wix, all of these are like more of monolithic or traditional CMS. But while I'm talking about Storyblock, it's a headless CMS, which means you can work independently irrespective of your front end or back end. Means they both are decoupled in a way. So let's say if you want to do some changes, you necessarily do not affect what's live. You can actually see what's happening in the back end. The back end CMS is totally different than that. But yeah, it's a solution. So using the same body to support any number of different heads. So it's like headless, right? So here you obviously see the answer why front end and back end is separated, and it is a decoupled way. But what does Headless CMS does, or how is that helpful? What are the features of it? Let's talk more about it. Faster implementation and flexible. Now here's the thing, when I say faster implementation, I do not necessarily need to code all the sections or components of my website, let's say, right? I can just define my own blocks, I can define my own components, and use it anywhere. So it's just like super fast implementation in multiple ways. And it becomes super flexible as well at the same time, because I necessarily do not need to see what page I'm working on or what component I need to find out. I can just create the structure of it and then directly start using and just call it out, maybe fetching an API from my own code base and just work around it. Future-proof, of course, because I have defined my own blocks, define Sigma, or let's say components for that matter, I can keep it using for all the future website I'm gonna build. I just need to work on my UX, maybe do some tweaks around how it looks, and I guess I do not need to actually code it out all because I already have things defined beforehand. Omnichannel architecture. Now, it's not necessary that we are only gonna use our website, let's say, for a single platform. Many times we use it for web, mobile, let's say our smart watches or anything. Now, because Headless is an omnichannel architecture, it allows us to see our content on each and every platform while we are actually building it. So no matter whatever platforms you are having for yourself, you can see how that experience will be for your users or for anyone who are gonna use your website or something. Cost effective, why not? Like, I do not necessarily need to go around here and there, find out different services which can help me manage my content. I do not need to depend on what kind of front-end frameworks I'm using. Good thing, a very interesting one which I love about Headless CMS is that you can use it with any of your favorite front-end frameworks. You name it and you can use it with that. So that is quite easy for us to manage as well. Scalable, of course, the above 4 points, I guess, obviously define how scalable it can be. Speed and ease, I am sure once we start defining more components around CMS space or while we are working with the backend only platforms, this comes in handy because This again goes with the flexible feature of it. Software architecture. Now, let's say we have different content blocks. There may be nestable or not, but when it comes to many more sub-branches or more of it, we can actually put it under each and every other, and we can create a good hierarchy. And that makes it even more structured. It helps you with your SEO of your website and multiple other things as well. But now, of course, while I'm talking about headless CMS, I cannot miss talking about Storyblock. I'm working there, right? And it's not something which I have been forced to do, but because I love what Storyblock does around the space, right? So Storyblock is a backend-only headless CMS, which essentially helps developers and content editors to make their content experience across all digital platforms even more better. This is how it actually looks like. So if you see, this is like a live preview. On the very right, you see our own visual editor. One super unique thing about Storyblock, which makes it different from other CMSs out there, is its visual editor. So anything which you're working on with, you can actually see it happening right in front of you, even before you go ahead and publish your content. So what to watch out for in a headless CMS? You might be thinking that, okay, I know what a headless CMS is, but what things should I consider while I'm maybe choosing a headless CMS? So I would just like to summarize it in 4 options. First is visual editor, which I recommend you all to go and check out on storyblock.com, because it's not just about me pitching about what storyblock.com is, or it is about how better the experience can be. Once you start building on the starter templates, fetching your code base, using your own APIs, I think that can be a game changer for you, how you see the digital content experiences, growing from one platform to other. Second is component approach. I guess, mentioned it multiple times. Component approach is basically something which helps you a lot while you're working on your website, and also when it's omni-channel, I guess the next point, and the advanced technology, which I said, it works with all your front-end frameworks. So you can take it forward from there. So I guess if you try going around and seeing these particular things while you are choosing a headless CMS, more than enough, I feel. And if there's anything you are looking out for, please let me know. I can help you with that. But whom is it for? Okay, we got to know what headless CMS is, what to watch out for. But is it for you? Is it actually for me? How to know that? Or whom is it for? Actually, it is for everyone. And when I say headless CMS, I would also mean Storyblock works for everyone, right? Starting with developers, of course, just like you all people, right? I know you all love coding, maybe in your favorite technologies. React, Vue, Nux, Gatsby, anything, right? So works with everything. Content editors. I feel in today's world, content editors need a lot of scalability and flexibility with the kind of content they're working on. Scheduling things on websites, adding a lot of collaborations, and so much more. Marketers, I guess they have a lot of initiatives, a lot of campaigns running out. This can be wonders for them. And enterprises, of course, at the end of the day, there are many enterprises who are looking for fast solution, more flexible and more reliable solution. So this is the thing for them, actually. So they do not necessarily need to run behind live coding or just coding their websites, bugging their developers again and again. This can just make it simple for everyone. I would have loved to do some demo and show you the Storyblock, but what we're going to do is we are actually live showcasing the visual editor and all the demos. You can come with us with your technologies or anything, and we're actually doing it in our booth. So this is my time to introduce you even more about Storyblock and welcome you all to our booth. So feel free to reach out to us with any questions and anything. And by end of this conference, we are there. We are not going anywhere, so you can always find us over there. But yeah, your headless CMS Storyblock it is. And thank you so much. Means a lot to me that you listened and were with me so far. And yeah, appreciate everyone. Thank you so much. I hope I was on time. Awesome.
Yeah. All right.
Hooray.
Thanks, Siddharth. I think I'm sure everybody loved your talk. Thanks for taking us through these insights about headless CMS. So yeah. All right. So we We have with us our diversity sponsors, Publicis Sapient, who are actually conducting express interviews. So feel free to find them at our community lounge, and who knows, you might be walking out with an offer. So don't forget to check them out. Also, I know that with all these talks and like this ceremony going in, we might have, I know we might have bored you a bit. Not the speakers, like we MCs, I think, we might have like bored you a little. So it's time for us to, I think, take a quick short coffee break of around 10 minutes. Feel free to find people at the area and network with them, chat with the speakers, and we'll be back in around 10 minutes. So see you back.
Please be back in about 10 minutes so that our next talk can start on time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion, It's not data for show. It's data that shows because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-Magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops,
Welcome back, everyone. Maybe you can quickly text and reach out to your friends and ask them to be back, because we'll be starting shortly. Can we all please settle down? All right, how was coffee? Not good? I thought people would be more energetic after the coffee break. Okay, thank you. Are you all excited for the next lineup? Awesome. So without further delay, because I think we were supposed to start at 11:45, I would like to welcome Kartikeya Sharma on stage. Kartikeya is a software architect at EPAM Systems, and he will be talking about unlocking dynamic visual experiences and unleashing the power of WebAssembly. Hello, Kartikeya. Just a couple of questions. Is WebAssembly a field of interest for you?
Yeah, where we are trying to explore new dimensions of the web, where we are more focusing on the more performant applications, where the WebAssembly plays a very crucial role in terms of visualizations, where you need to do compute intensive. You have 3.js, you have WebGL coming into the picture. You need compute intensive. JavaScript, as it is, like, we have a single threaded thing, but WebAssembly provides us a lot of binary code in the browser, where we can execute a lot of binary code in the browser itself, and it helps us to create more faster applications.
Awesome. That sounds amazing. I think we all, including me, have a lot to learn from this talk. Over to you, Kartikeya, and all the best.
Thank you.
Please, a round of applause for Kartikeya.
Am I audible? Okay. Thank you so much for the introduction. As I have been introduced as Kartikeya Sharma, so let me tell you a little bit about myself. I am a hardcore coder. So I started my journey as a PL SQL. I graduated to be a full stack. I'm working as a software architect, as introduced. So now I'm here, like, I tend to explore more and more things about the web, new things coming into the web. And one of the fields of interest which you are seeing on the screen is unleashing the power of WebAssembly and WebGL. Now, these are the two technologies where we'll be talking about in this in today's agenda, where I'll be going through you what is WebAssembly, what are the advantages of WebAssembly, how does the WebAssembly work, WebGL, benefits of WebGL. Sure, what just happened? I'm sorry. It's connected, but the laptop got switched off.
Your power is there.
To your JavaScript application. And this is a field of interest for me too. So I hope all of you are interested as well. Please welcome on stage Shivai. Karthika, it's okay. Thank you.
Let me know when to start. Let me know when to start. The time for 30 minutes. Okay. So, of course, first of all, welcome everyone to my talk. I'm super excited to be presenting at my first ever Jsconf, and interestingly, it's also my first ever Jsconf that I'm attending as a attendee. So, super excited to be presenting. And before we start, I'd like to ask everyone to just take a minute and scan this QR code. It's from Slido. And before I start my talk, I just want to kind of get a glimpse of what the audience knows or what are they aware of the term WebML, which of course I'll be introducing in today's session. So would love to just see what everyone thinks about this particular term and what do you infer from this term. Of course, I'll be giving a lot more clarity of what I'm going to be talking about, but just want to start off. So we see machine learning in the browser, then we have WebML, machine learning, TensorFlow in the browser. Okay, perfect. Integrating ML with a web app. So looks good. And I think seeing so many different amazing answers, we can actually get started with today's talk officially. So hi, I'm Shivai. I'm a TensorFlow.js SIG and working group lead from India, and also I'm part of the TensorFlow user group India. And my talk is about bringing machine learning capabilities for your web applications with the help of different open source tools that you can leverage in your JavaScript applications. Now, we are in a very interesting era right now. Of course, we see the terms of OpenAI, DALL-E, ChatGPT everywhere, right? And I am, of course, confident that at least you might have interacted with machine learning in some or the other form, whether it is trying to find answers on ChatGPT, or it is to probably try to make your code better with the help of ChatGPT, or drawing some amazing AI-based images that you can generate with the help of different tools like DALL-E. And that brings us a fundamental question that as a JavaScript developer, can we leverage these tools and can we actually learn machine learning? Because typically machine learning is generally considered to be a thing that you'll require PhD, you might have to use different other languages like Python or R. So what is in store for a JavaScript developer to be able to interact with machine learning so that you don't have to leverage another tool or another language stack? And of course, I mean, we know that JavaScript itself is so complex, right? That we don't want to learn some other language or some other tool set. So as a JavaScript developer, you don't want to learn another language, right? So let's see how we can actually implement or tackle machine learning problems with the help of JavaScript. And what you can actually do is that, of course, Another thing that you might have also heard is that machine learning models, they require a lot of compute power. You require like thousands of GPUs to be able to power a simple machine learning model. But what if I told you that you can actually do that now on your browser itself without having to need any dedicated server and save up all of the costs related to the servers and also have a lot less latency because you can actually do everything from the powers of your browser itself. So that's what my talk is going to be all about, how all of you can get started with machine learning in the web and how everyone can, without having any knowledge of machine learning whatsoever, can very quickly and bootstrap applications with the help of machine learning. And we also know that JavaScript is by far the most popular programming language, right? How many of you will agree? Because of course we are at a JavaScript conference. It's usually a tussle between Python and JavaScript, but I am from the JavaScript team. So yeah, it's the most popular language. And also the fact that JavaScript is truly inspirational because it can run not just on the browser, it can also run on edge devices, on server with Node.js, and even for desktop applications using tools like Electron.js that can leverage the use of JavaScript on the desktop. And that, of course, makes it just, like, without a doubt, that if we are able to leverage machine learning in JavaScript, you're truly unlocking the capabilities of being able to leverage machine learning capabilities for different tech stacks and for different types of devices as well. So whether it's being able to run machine learning inference on the browser itself or outside the browser as well. And that kind of brings today introducing a lot of different open source tooling that exists today that allows you to be able to run machine learning models, not just in the browser, but also on things like Node.js. So we have different open source toolings, open source libraries, including MediaPipe, Transformers.js, TensorFlow.js, Onyx, that you can leverage in your web applications and build end-to-end machine learning capable applications that you can serve to thousands of people. And if we specifically look at one of the most popular machine learning libraries, that's TensorFlow.js, it has seen an incredible and unfounded growth, especially in the past 5 years. And especially in the last 1 year, it has seen more than 20 million downloads on NPM, and a lot of companies, both in startups and a lot of large MNCs are actually today using these libraries to be able to bring machine learning capability in the browser. So I'll, of course, take this time now to officially introduce the library TensorFlow.js. So TensorFlow.js is an open source machine learning library that is developed by Google as a way to be able to leverage machine learning capabilities inside of JavaScript. So earlier, of course, a lot of us used to probably write Django-based models and then serve them up with JavaScript instead of a web application. But we saw that capability of being able to actually run end-to-end machine learning models directly with the help of JavaScript. So that basically gave rise to TensorFlow.js. It's essentially an embedding of how TensorFlow, which is basically a very popular machine learning library written in C++, so just an implementation for that in JavaScript. And it does provide you capability of being able to run it directly on the client side, on the browser. And we'll see that how you can actually do that throughout the course of today's session. And again, the biggest point is, you might have actually heard this term, write once, use anywhere. This is used for a lot of different languages, especially like with Java and how JVM kind of brought into the picture. But it's essentially the similar for TensorFlow.js as well, that you write one piece of machine learning logic with the help of TensorFlow.js, and you can truly serve it on web, on browser, on your Electron-based desktop app, or even on Raspberry Pi for that matter. And there are primarily 3 different ways in which you can actually interact with this library. So starting off with running existing models. So this is, I would say, the best or the easiest way for you to get started with machine learning for JavaScript, where you don't have to even know about what that particular machine learning model does or have to build that particular machine learning model from scratch. All of the logic has already been pre-configured for you with these pre-built models. It's simply just making simple JavaScript calls to be able to load this model and use some ready-to-use functions such as .predict that will essentially take any data that you might have and make the machine learning model do the predictions on top of it, and then have something like .showcase that will, of course, demonstrate the results for you. And we'll be seeing that how you can just leverage simple, easy-to-use functions with these pre-built models. Apart from that, you can also use some more advanced training mechanisms such as transfer learning, which essentially takes a pre-built model, an existing model, and you can retrain it over your own data. So whether you have text-based data, you might have image-based data, video-based data, so you can retrain the model and leverage it. And of course, if you are a machine learning aficionado and you want to leverage machine learning and write machine learning models from scratch, you can actually do that with the help of JavaScript itself. No need to use Python or R for that matter. And of course, talking more about the pre-trained models, because this will, I assume, will be of most use for all of you. So there are a number of different use cases that I can actually leverage. So including vision-based models that allow you for doing computer vision tasks. Then you have text-based models that allow you to determine, like, let's say, text toxicity. If you're using some kind of a vulgar language, you can automatically detect that. And all of these are, again, just to remind, are being run exclusively on the browser itself, on the client side. So here are some examples. So this one is one of the most popular machine learning models, which is the CocoSSD, that is primarily used for object detection. So here you can see that how we can leverage the use of object detection to be able to detect different types of objects. For example, in this case, we are doing it for dogs. Then this is another very popular machine learning model, which is the face mesh. And it's actually being used right now live by L'Oreal to be able to do things like makeup on your face. So it uses a bunch of different facial detection points that are being tracked on top of your face. And again, this is being run on the browser itself. Similarly, there's, I mean, of course, we know that with the current landscape of JavaScript being such a popular language, there are so many different NPM modules that you can actually use. So here's one example where one of these developer relation engineers at Google for the WebML project were able to basically do teleportation by a combination of WebRTC. There's a talk for WebRTC by Christie today, and they used A-Frame, which is essentially for augmented reality in JavaScript, and using TensorFlow.js, they were able to build this really cool teleportation demonstration. And here's like one sample code that should give you a very quick idea of how quickly we can get started. So at the top, in the first two lines, we just import the necessary NPM libraries for JavaScript. So this one includes TF.js, which is the TensorFlow.js core, and also the AutoML that will be used for like detecting items within a particular image. And then we simply just introduce a new image with an image tag. And inside of our script function, we first wait for our model to load on the browser, and then we just pass that particular image through our load image classification function to basically use the model.classify function, and that will take the image, classify it based on what is detecting in the image, and it will give the results to you. So no need for understanding what's the mathematics behind that particular model, and simply in the being able to use like just 3 to 4 lines of machine learning of TensorFlow.js code, you're able to create very easy to use machine learning models and applications with the help of TensorFlow.js. And of course, if you are probably not a very novice JavaScript developer, there's also the capabilities of using low-code tools, something like Visual Blocks, which is an ML-powered tool, especially for like new developers, to understand that how you can actually build entire end-to-end machine learning pipelines. So here's one example where I wanted to build like a sample AR filter and a custom video background, where you can see over here I basically took a background image of Jsconf India, and I had a very small AR filter, if you can actually see it, on top of my face. And this again is being leveraged with the help of WebML with a lot of different machine learning libraries that are provided by TensorFlow.js, for which I'll not go too deep into that right now. But the idea is that you can try out this Visual Blocks for ML yourself as well, and just play around and see how you can build end-to-end machine learning pipelines. So in this case, we are leveraging a couple of different machine learning models. One is segmentation that allows you to uniquely identify human bodies in an entire web frame, like in the canvas, so that you can actually put on that particular background. And I'll be actually demonstrating that in a code demonstration later in today's session. And then we are using, like, for AR filters, we are again using Face API that will uniquely detect your face. And you can very easily then add a canvas on top of it to have like a very cool AR filter. And just to also, like, share some real world use cases, right? Because that's, of course, one of the most important things to keep in mind, that if you are working in your companies and you have
very interesting use case for machine learning. I just wanted to demonstrate with the help of a couple of slides where that today WebML and especially like open source tooling such as TensorFlow.js and MediaPipe are also being used by companies, right? So here's Include Health, which is a very famous AI-based health startup that uses TensorFlow.js to be able to track and to be able to like track your rep counts and the exercises that you're doing. And similarly, there is Adobe, which of course a lot of you might be knowing. They recently introduced Adobe Photoshop for web, and they are able to use WebML for being able to do things such as object detection within the entire Adobe Photoshop application itself. And LinkedIn itself also uses WebML, but that's not really for the client side. They use for Node.js and to be able to optimize the images that they serve. As you know that LinkedIn is being used by millions of people, so they want to optimize their server cost by displaying the images that they showcase on their platform. So they use machine learning on the node on the server side with the help of Node.js to calibrate and improve their performance. So these are just some of the very small examples where both large MNCs and startups are actually using WebML for their use cases as well in production. So it's completely production ready. It's very simple to use and get started with. So that's just the main motive to showcase some of these examples. And this kind of brings us to probably the most technical aspect of today's talk. And that's essentially what is powering all of this WebML, right? We have been talking about WebML in all this while, but let's probably break this down into, for the next couple of minutes, let's break this down into understanding that what is the secret sauce behind being able to get that much amount of performance. Because of course, we typically assume that machine learning models are very heavy, right? They are very compute intensive, and that's true, right? JavaScript itself as a language is not very well suited for being able to run very compute intensive tasks. So the first question comes that how then we are able to leverage and use these machine learning models on the browser and still get very performant applications. So the reasoning and the way that we are able to achieve that is, and I'll be exploring this particular diagram, right? So of course, you can directly run your machine learning models natively in JavaScript, but the performance that you'll get is not that great. So because the browser APIs are able to actually leverage both your system hardware resources, so whether you're running a CPU or your GPU, so with the help of browser-based APIs and different backend tooling such as WebGL, WebAssembly, and WebGPU, you're able to actually leverage those particular toolings to be able to accelerate your machine learning in browser, both the training and both the inference. So coupled with the JavaScript functions and the applications that you write and the machine learning models that you use, you can leverage these backend technologies. And when I say backend, that doesn't mean that it's on the server. These are just, essentially, these are toolings that you can run inside of your Chrome browser or any other browser for that matter, and be able to actually accelerate your applications. They're also typically used for a lot of 3D rendering. I think like we already had a talk about 3JS that actually leverages the use of WebGL for that matter. So by using these technologies, they actually help you to accelerate your entire machine learning inference, and the compute time that it actually takes to do that inference or the training directly in the browser is a lot faster, right? So you can leverage these tools. Now, apart from the second layer that you see, you have all these particular functions such as like TensorFlow.js, you have MediaPipe, and if you are coming from a Python background, there's also support for being able to directly transfer or change the machine learning models that you might be typically writing in, let's say, core TensorFlow or using TensorFlow Hub or TensorFlow Lite to be directly converted into TensorFlow.js and then serve them on the browser. So in-browser implementation is very simple, and there are tons of different ways in which you can actually leverage. So of course, we spoke about the in-browser implementation with the ready-to-use models, and also of course being able to convert some existing models that you might have in Python or in TF-Lite and then convert them into a model.json file that you can then just serve with your JavaScript application to be able to leverage them inside your JavaScript-based web application. And of course, this is just a bit more information about how you can leverage these particular different types of backends that are capable for being able to serve these applications on the browser. So of course, we were supposed to have a talk about WebAssembly. WebAssembly is essentially a universal bytecode that it's a universal target, compilation target that performs very near to native speed, and you can leverage that as well to be able to run these models. So just think of this way, that your core JavaScript function will just take care of running the web application, whereas the compute-intensive tasks, such as the inference, is being taken care of by these backends. So you can very easily just use any of these backends and switch between the one that you want to use. And it's very simple to use. You just have to do npm install TensorFlow.js with the particular backend. So it's like tf.js, WebGL, tf.js, WebGPU, tf.js, WASM. And just compare which particular type of backend performs the best for the particular machine learning model that you want to use, and you'll be able to compare between them. There's also some tools in which you can actually compare the performance between the different toolings. So that's about the hardware acceleration that you can use to be able to make the compute a lot more faster as compared to standard compute. And of course, some of the biggest benefits, right, that you get by leveraging machine learning on the browser is that you don't need a dedicated server. Because historically, the way that you would use to actually run these machine learning models is that you would need a dedicated server. Now, your front-end API will make an API call where it will either send some data to that dedicated server, and then your server will take that input data, it will take some time to do the inference, and then send back the response. So you're dealing with a lot of dedicated server costs, you're dealing with latency, right, because of having a server. So just imagine that if we are able to remove that particular server itself, you're having privacy because now you're no longer sending any data to a dedicated server. So all of your data that you're dealing with is residing inside your own browser. So it's a lot more secure. Then you're also saving up costs for the server, right? You don't have to have a dedicated server, so you're saving up costs over there. And you're also dealing with saving a lot of latency because the browser is responsible for being able to do the inference, and you're getting the results right there at the same time. So that's the impact that we get by having a serverless approach and not having a dedicated server. And trust me that a lot of the popular machine learning models today have been optimized so that you can run them directly in the browser itself. And of course, not to forget about Node.js as well, because a lot of the people over here at Jsconf will be backend developers. So you can also actually leverage the use of these models directly in Node. So there is a dedicated TF.js Node NP model that you can use. And if you want to get started again, you can use with either GPU, with CPU, or with WASM. All these are dedicated these are dedicated JavaScript NPM modules that you can leverage. And of course, there's a lot of performance benefits that you actually get with using something like Node.js, because a lot of us might be aware that Node.js basically uses just-in-time compilation, right? And by using and leveraging just-in-time compilation, the performance that you get by running these models with Node.js is a lot of times faster as compared to even with something like Python. So here's one example where Distilbert is one of the most popular NLP, which is natural language processing. It's one of the most popular machine learning models for NLP. And you can see that it actually performs twice as faster as compared to the standard Python implementation for which it is originally designed, as compared to when you're using it with Node.js. So this should give you an idea that how performant JavaScript is and how well optimized some of the features for JavaScript are that allow you to actually leverage these machine learning capability for your web applications, whether you're using it on the client side or on the backend. And here are some like the benefits that you get. So of course, if you have a very large model, right? So sometimes your model sizes, typically if you talk about like machine learning model sizes, they are usually between like, let's say, starting off with 1 to 10 megabytes in size, or they could even be like 10, 15 gigabytes in size. So let's say if you are dealing with a very large model, and especially given the fact that today you might have heard of the term large language models, right? LLMs that are essentially powering these tools such as OpenAI, ChatGPT. So if you have those kind of large language models, you could serve them with the help of Node.js and have the dedicated server support as well, that of course you will get in case you are having a use case dealing with larger machine learning models. So you get access to, of course, JavaScript, the just-in-time compilation with Node.js. So you get very performant applications running on the server side as well with the help of Node.js. Or of course, you can also leverage the use of external APIs. So of course, OpenAI provides a lot of different APIs like the Whisper API, text completion API that you can leverage in your web applications because there are JavaScript SDKs. So you can leverage those. Of course, these are not really open source, but just some of the other toolings that you can explore because we are talking about WebML. So we are essentially looking at a lot of the different existing tooling that exists today for getting started with machine learning on the browser. And you can also use tools like Replicate that allow you to do things such as stable diffusion, DALI-like image generation. So here's one example of this Room GPT. How many of you have actually heard of the Room GPT? Probably it actually grew in a lot of attention. It was also covered in different magazines and news publication sites like Business Insider, and it has like more than hundreds and thousands of downloads at this point in time. And it uses OpenAI, one of the OpenAI models that takes one image and it will help generate a very artistic room for you. So it again leverages the OpenAI tooling, OpenAI models that you can actually use. And again, these often are just often these are just side projects that get a lot of different traction. So when you're leveraging these tools, you can very easily create web applications that are powered by machine learning in a matter of a few seconds, not seconds, but in a matter of a few hours, and get them up and running and in production use for thousands of people to actually leverage and use. And of course, if you're interested from this particular talk, to get started, here's a really amazing course for the TensorFlow.js, which of course is kind of the biggest open source machine learning library for WebML. So you can take a look at this particular tool, this particular course. It's also live on YouTube, and you can just enroll for it by going to this particular link. So if you're interested, feel free to actually do that. And now, of course, before I kind of conclude my talk, I just want to showcase a quick demonstration. So I'll just increase my size. So here I have a very simple index.html file where I'll be creating a virtual background with the help of MediaPipe. So I spoke about like different types of open source libraries, right? So one of the ones that I'll be showing is an example of selfie segmentation. So I spoke about the segmentation. So what segmentation allows you to do is that you take, let's say, a canvas and you have a web frame, right? So you're using, let's say, your webcam and you get your frame. So it will be able to uniquely detect the humans, so the entire human body, and as, let's say, you interact with it, it will be able to keep a track of where that particular human body is going inside of that entire frame. So the segmentation allows you to uniquely identify human bodies and, like, in fact, multiple human bodies in just one single frame. And then you can just do whatever you want. In this case, a lot of us might have used virtual backgrounds with Google Chrome, Google Meet for that instance. And Google Meet actually uses TensorFlow.js and MediaPipe to be able to power up that virtual background. And that's what I just wanted to quickly demonstrate. So what I'll be doing is that over here, I have included two different scripts. So one is MediaPipe. So that's an NPM package for MediaPipe. And the one that I'll be specifically using is the selfie segmentation model. Now, in a matter of just 40 to 50 lines of code, if I look at my index.js, so first what I've done is I've just taken a video element that I'm fetching from my webcam. And I have my canvas element where I'll be displaying the virtual background. So essentially, whatever webcam footage is being showcased, you're just putting it on top of your HTML canvas and running the inference on top of it. So here on this particular function, if you see, which is the const camera. So first we're just taking the webcam footage. And this is primarily the machine learning code that we are writing. This is just so in like less than 4 lines of code, that's the only machine learning part. Apart from that, it's all the standard JavaScript where I'm taking the webcam footage, adding it on top of the canvas element. So over here, we are using the selfie segmentation model where we are, of course, using the NPM model for that. And we just simply take our camera footage and using the onResults function, we are basically finding that particular human body inside of that particular canvas element, and then using the virtual background. So if you take a look at this on results function, so first we will draw that image based on the results that we get from the selfie segmentation model, and then we will simply just go ahead and also we can, of course, download that particular image once we have created it. So let me go ahead and make this live and showcase that how it kind of looks like. So in this case, as you're able to see that I'm able to get like a virtual background, which is like WebML at Jsconf India. And I can also, of course, download this particular image. So the only thing that is happening over here is that we are using the selfie segmentation model, which is able to detect me uniquely. And the background that you see is the virtual background that we have put. So this is exactly how the web, when you put a virtual background on something like Google Meet or for that matter on Zoom, that's how they are actually able to leverage it. I've also deployed this application, and what I love for everyone to kind of do is just go to this link called jsconf.versal.app, and all of you can also take your own images and share on Twitter using the hashtag WebML, and just tag me as well if you want. And just, of course, you can change the code as well if you want to use some other image. But of course, I'll recommend everyone to just go to jsconf.versal.app and create your own selfie at Jsconf and share it with in the entire world. So that's a quick demonstration that I wanted to showcase. And I'll go back to my slides. Of course, we're just running out of time. So these are some of the resources. If you want to get started with WebML, with TensorFlow.js, there are some books. There are some courses, as I showcased, this particular Zero to Hero TensorFlow.js course. And there are some code samples if you want to get inspired. In fact, like since these libraries are open source, so there is a particular GitHub repository for TensorFlow/TFJS examples where you can see a lot of these particular pre-trained models that I showcased and just play around with them, try to see which one might be fitting your use case, and then start implementing them, right? That's the major use case. And of course, the entire WebML community is a really fun one because you can leverage these machine learning models for doing a lot of like good social work as well, but also you can leverage them for making a lot of different fun side projects, right? You can see some of them over here. And if you want to get more inspiration, just go on to Twitter and look at the hashtag made with TFJS or hashtag WebML if you want to see some really cool, interesting ideas that you can actually leverage to make these side projects or make your next machine learning powered startup idea. Because these tools are there for you to leverage and make very easy to use machine learning models and machine learning based JavaScript applications, whether it's on the browser or it's on the node. In fact, like there is another talk by Jamal today who will be talking about TensorFlow.js specifically with a use case for Node.js. So if you're interested from this talk, definitely do attend that. I'm not sure which particular track it is, but you can take a look at the schedule. He'll be using time series data to do some data analysis, which of course, probably 5-6 years back, you might have thought that it's only possible with Python, but today you can actually use JavaScript for that matter. But yeah, with that, I would like to officially announce at Jsconf India, let the WebML era start. And I hope that everyone today will be able to leverage these toolings and leverage these open source libraries to build really interesting machine learning based use cases and integrate machine learning in your workflows. So whether it's like, engineering managers over here, you can see the power of these tools, or if it's engineers, go ahead to tell your engineering managers, if you're a student, tell your teachers or build projects, build hackathon projects with machine learning. You don't have to be scared now as a JavaScript developer to use machine learning. So with that, I'll conclude my talk. Thank you so much. And I'll be around if you have any questions. Yep, thank you so much.
ML era begin. Very
Yes.
well said. Thanks for this amazing talk, Karthike. Oh, sorry, right. Not Karthike. It's Shivai. I'm sorry, I think I've like messed up my script a little. So a tech glitch for my side as well. But yeah, this was a super amazing talk, very well put. So yeah, I think, but like that's the story of us developers and like us JavaScript developers, right? Technical glitches, bugs. It's our everyday story that we tackle with, right?
Yeah.
But yeah, again, a super amazing talk again. And with that, I would like to start with our previous or next. I think, yeah, anything next. Like previous or next. The upcoming speaker on the stage. So please welcome with a huge round of applause, Karthike.
Okay, so I guess we can start it. Apologies for the last hiccup. As the Murphy law says, anything will go wrong, can go wrong, and will go wrong. So yeah. So welcome back to the WebAssembly and WebGL session. In continuation for the last, from my previous, I'll continue from that point itself. So today we'll be talking about WebAssembly. What is WebAssembly? What are the advantages of WebAssembly? What is WebGL? How these two technologies amalgam with each other? And what are the particular use cases for it? How do we get started on it? So before we start, let's get into the introduction about what is WebAssembly. So now WebAssembly is nothing but a binary instruction format which you can run on your browser. Now, what is binary instruction format? So whatever we code, like JavaScript, Java, anything, so at the end of the day, it transpiles or it compiles into the binary code. Now, how can we do that binary code with JavaScript? Now, there are few mechanisms. Here comes the concept of WebAssembly. Now, in WebAssembly, we can actually compile our code into the binary language and we can run it on the browser. Now, what is the point of having that WebAssembly? We have JavaScript. Yeah, that's a very valid question. Basically, the WebAssembly is just, it is used within conjunction with JavaScript. So it actually not directly interacts with the DOM or browser model, but in order to interact with the browser, it needs JavaScript to interact. But in order to use WebAssembly, when we need to have very great and powerful applications, compute-intensive applications. In the last talk, we were hearing a lot of ML things. When you have ML languages, ML models coming into the browser, then your application need to be compute-intensive. And in order to do the compute-intensive work, you need a WebAssembly. It stores your code into the binary. Now, what are the advantages of WebAssembly? As I said, it improves the performance of an application. It is language agnostic. So you can actually create WebAssembly in any of the languages. You can use JavaScript. So there is a binding with JavaScript known as assembly script. So if you are very familiar with TypeScript, you can go ahead and use assembly script to convert to produce your WebAssembly modules and use it in the browser. There is a new programming language called Rust, Python. There are many Java. So there are plugins available to create your binary modules into the WebAssembly modules, and you can use it on the browser. Portability, WebAssembly runs on different platforms across different web browsers. It's just a binary piece of code which can run on it can run on any environment. Security, it's a sandbox it's a piece of binary code. It's very sandboxed environment, so you don't have to worry much about the security aspect of it. You cannot, nobody can, put malicious code in your sandbox environment, so it's pretty much secure environment. Now, how does this WebAssembly works? As I was suggesting earlier, WebAssembly is nothing but a binary piece of format, and you can convert your WebAssembly modules into .wasm file. It is known as generally WASM file, and you can use languages like Rust or assembly script or JavaScript languages, and you can easily fetch these modules through fetch. You can actually get these modules through fetch, and just run your programs as it is. The browser compiles the WebAssembly into the just-in-time compiler, so it's known as the just-in-time compiler. So it's just it downloads it into your browser, compiles it, and it's known as just-in-time compiler, and it runs. And as I was mentioning earlier, WebAssembly doesn't interact with the object model directly in order to browser DOM model. So in order to interact with such modules, you need to have a JavaScript interfaces. So it's very good amalgamation of an WebAssembly module, binary language with the JavaScript, in order to interface with the DOM browser module. Now, coming to the next is what is WebGL? Now, how these two technologies are related? Probably, as I was saying, like, as I was giving an introduction before about the WebAssembly, now WebGL. Now, WebGL is nothing but a web graphics library of the JavaScript API. So now you are seeing the new visualizations are coming up, new 3.js, if you have heard of 3.js, there are a set of new visualizations, 3D dynamics are going on, 3D games are coming on the browser. Now this is all because of the WebGL. Now rendering to the 3D graphics. Now these, when we render these graphics, you need immense amount of calculations, or it's a compute-intensive job. Now, in order to do this compute-intensive job, we can leverage the WebAssembly over here. So that's how these technologies amalgam with each other. Now, what are the benefits of WebGL? You can get a hardware acceleration, cross-platform compatibility, real-time rendering, and these are some of the benefits you can get of the WebGL. And again. Okay, yeah, I'm good. Okay. So these are some of the benefits of the WebGL, as I was saying. And how these two technologies interact, I just told you like a minute ago. These technologies, WebGL needs a lot of compute-intensive work. And in order to do those compute-intensive work, we need to include WebAssembly modules. Now, WebAssembly and WebGL integration, it's pretty easy to use both of them together. As I was saying earlier, if my laptop had been in a good condition, then I would have showed you the demo where I've just created a small application on React where I've integrated the WebAssembly module with the WebGL with a lot of compute-intensive tasks. So we are just amalgamating these three new technologies coming together on the front end and creating a beautiful rendering patterns, visualization patterns. It's just starting off the unlocking a lot of potential of creating a dynamic visualizations, a dynamic rendering. So these are some of the things which WebAssembly and WebGL can do with each other. WebAssembly modules can leverage WebGL to render and display compute results, like as I was mentioning earlier. Now, about the use cases of these technologies. There's, as I was saying, like game development. WebAssembly and WebGL are together can be used for the game development. There are a lot of 3D effects, 2D effects can come into the browser. ML, data visualization, virtual reality are some of the use cases. There are other use cases like ML, image morphation, image processing on the browser itself. And nowadays, it's been a saying, browser is the new server. Browser capabilities are now going day by day, is coming more. Now we can leverage a lot of browser utilities, and that's what we are trying to achieve by leveraging the browser capabilities, by introducing the WebAssembly modules together with the WebGL. And that's some of the use cases. That's just the beginning of an era. Now, how do we get started with these technologies? As I was saying earlier, it's pretty simple to use with your React application. Just do npx react, create React app, install WebAssembly, have a WebAssembly script in your modules, and fetch it. It's just pretty simple to use. I would love to show you in the next 1 minute, but unfortunately my laptop is broke. So, if you do have any questions, I'm at the EPAM booth. Please feel free to reach out to me. My name is Kartikeya Sharma, and as my favorite author says, Mark Twain, getting ahead is just getting started. So just get started on the WebAssembly and WebGL. Thank you so much.
Thank you so much, Kartikeya. And we are also happy that you were finally able to deliver the talk. And it was really great. As he mentioned, you can connect with Kartikeya further at the EPAM booth and get to know more. Next, we have Philip. He's the co-founder and CTO at Vue Storefront. and he will be talking about turning a product for Vue developers into framework agnostic architecture, a case study from the Vue storefront. A round of applause for Philippe. Hi, before you can get started, I have a question for you. You can please put your laptop there and somebody can help him connect in the meantime.
Okay.
Hey, please say hi, everyone. Okay, so you have been the co-founder and CTO for how long?
For 3 years, and actually I'm no longer a CTO, so I hired a CTO a few months ago, which is quite a luxury if you're a founder to find a successor. Right now I'm focusing more on developer experience, which is absolutely something I love and which is something you will hear a lot about during my talk, so yeah.
Okay. So can you tell us one thing or one funny incident in your tenure as the CTO for Vue storefront? Maybe you can think about it and talk about it post your talk.
If you will see my presentation, you will see that basically we are running in circles a lot of times. And during this talk, I want to kind of demystify some things, like a lot of companies appeal as extremely successful from the outside. But in the inside, the reality is like no one knows what they're doing. And well, my talk is more or less about this.
Thank you. That made me feel better. All the best, Philip. Let's cheer for Philip, everyone.
I have speaker notes in here and slides. Oh, wait. In here? Yeah. Wait for it. It's worth it. Okay. Then which one is the main one? Where would I see this? Okay, yes, I see this. It's close. Yes. Oh my God. Yes. Okay, now the only thing that I have to do, wait for this, is window. Nope. Yep. Okay. Yes, it works. Yeah, congrats for me, right? Yeah, so today I'm going to talk about building the perfect toolkit for e-commerce developers, and basically it is a history of how we created Vue Storefront 6 years ago. I won't tell you what Vue Storefront is because the whole talk is basically about that. So I'm Filip Rakowski. I'm a co-founder, a chief developer experience officer at Vue Storefront. If you never ever met anyone with this title, it's because I invented it. Because I thought, well, how cool is that, right? I'm also a member of Technology Council in Mach Alliance. Mach Alliance is an organization that is basically focusing on bringing much better enterprise software to the e-commerce space. And I'm really proud to represent that. And I live in a beautiful city of Wrocław in Poland. Anyone recalls Wrocław? Anyone been there? Raise your hand. No one. I highly recommend that, really. It's also called a city of 100 bridges, and I'm really, really excited about being here. It's my first time in India, first time on Indian event. But I'm a foodie, so as you could imagine, it's kind of like a paradise for me. And I have a question for you. Please raise your hand if you ever built or contributed to a library or a framework. Yes, nice. There's a lot of you, actually. Nice. So if you plan to build tools for developers, you will hear about real struggles that we had to overcome to build this perfect toolkit. And it took us 6 years, and we learned a lot. and hope that after hearing this talk, you won't repeat our mistakes. And this knowledge is universal, so it doesn't only apply to building libraries or building talks, but for those use cases, I think it is most transferable. So I want to share with you how we solve certain problems that I think are quite universal for most of the developer tools, big and small. So sit comfortable, hear about the problems we encountered while building this storefront and how we solve them. So let's start with the catalyst, like the problem zero, because every project ever built has to solve a problem, right? At least in theory, because of course we are building dozen projects just to test some technologies, right? So it was no different in our case, really. So what problem did we encounter and what led us to the creation of this storefront? At that time, I was working at Devante. It was a software house that was focusing on building e-commerce shops, and it was mostly using Magento. How many of you heard about Magento here? A lot of people. How many of you like it? Really? No one? Yeah. So Magento was one of the most popular e-commerce platforms at that time, and it was really well known in the open source community. But unfortunately, it was not catching up well with the changing market and mobile-first approach. So honestly, not that much has changed since the Adobe acquisition, though some things were improved. And the problem that we faced when we were using Magento were mostly around flexibility of the stack, developer experience, and performance. A lot of you raised your hands, so I'm pretty sure you can relate to that. So we're trying to fix those things within Magento itself, but it was a dead end, really. And when we realized that, we started looking for alternatives. And this is where we heard about the term headless. How many of you heard about headless? Good. If you're a front-end developer, you're probably doing headless without even realizing this. So while it sounds weird, it's actually pretty self-descriptive, and you'll see why in a moment. And to understand headless, first let's understand the opposite of headless, which is the monolith. So when we build applications, they usually contain 3 layers, and each of them has a different responsibility. Presentation layer is what the user interacts with, and it has to be fast, intuitive, delightful. Then we have a business logic layer, and this one is responsible for manipulating the data and sending it to the presentation layer. And both data and business logic has to be fast, reliable, under heavy load. And in short, a monolith is an application that has all of those 3 layers baked into a single framework on a single application. There is no logical separation. It is deployed as one app. And because of that, each of the layers has high influence on each other. For example, if your backend business logic executes slowly, then everything is slow. Your front end is slow. While headless is all about separating the front end layer from the backend. And if we treat the front end as a head of our application, then we can say that we are just detaching the head and changing this with a better one, and hence the name headless. I don't know who came up with this, but I think it's pretty genius. So the front end communicates with the backend only through an API. And actually, the API is the only element of the backend service that impacts the front end. So we can also call headless API first. So in August 2017, we pushed our first commit to our open source repository, and this is where everything started. Like, this storefront was open source from the day one, and I think that was the main catalyst of our success. So by detaching the front end, we're already able to completely separate, build completely separate application on the front end using modern JavaScript framework, which was Vue.js at that time. And by doing that, we already fixed 3 of the problems that we had, but unfortunately, we didn't solve the most important one, the slowness of Magento. Why? The reason behind that was quite simple. Even when we detached Magento completely, the database was super slow. Therefore, the API responses were also slow, and the front end was slow. So especially complex and large queries, they were taking a lot of time. And again, like, if you ever work with Magento, and a lot of you raised your hands, I think you know what I'm talking about. And I said that the first problem, poor performance, was the most important one. And I really mean that, because speed equals money. And I'm sure you can relate to that from your own experience. Like, imagine that you're entering a shop and it is slow, you're getting frustrated, you don't want to buy there, and even if you buy there, next time you're looking for some alternatives. And the only thing that you'll remember is basically the frustration. Raise your hand if you ever witnessed that. Oh, not that many people. So actually, Amazon conducted a study. It was long ago, in 2006, but what they found out is that every 100 milliseconds of additional loading time of the application is costing them 1% in revenue. And of course, it's not that much for a small shop, but for Amazon, it is insanely a lot. So only in the first quarter of 2023, they earned $127 billion. And major part of that revenue comes from the Amazon e-commerce. So I'm leaving math to you, but you could imagine that it's quite worth optimizing it. And if you need a good source of arguments, this is the screenshot time for your boss to take care of performance, check out Web Performance Optimization Stats. This is a wonderful website, and it will give you a great insight on how actually optimizing performance helped other companies to grow their revenue. Because this is a quite common problem. Like, we developers, we understand the importance of performance, right? Then we are coming to the business saying, hey, you have to invest this amount of money to actually improve that. And they are saying, asking why? Why would I do this? So here are the arguments. So the way how we overcame the slowness of Magento APIs was unfortunately quite complex. We had to find a faster database. Then we had to mirror the Magento data there and keep both in sync. So we used Elasticsearch for that, as it was a proven solution to work effectively with quite large and complicated data sets. So our initial headless architecture got a little bit more complicated than on the previous diagram. So what happens here exactly? So in the left-hand side, we have, microphones, right. So in the left-hand side, we have Magento, and Magento was actually pumping the data to Elasticsearch for data pump. So how it worked, basically it was a cron job that was syncing those two data sources between each other. And then we had something called vStorefront API. And vStorefront API was actually a middleware that was calling the Elasticsearch, but also for some dynamic calls like user sessions, for example, it was calling Magento directly. Then the front-end that we built in Vue.js, it was also a progressive web application. And the beauty of that is that the front-end was completely unaware of the complexity at the backend. It was only calling vStorefront API, and vStorefront API was actually taking care of resolving everything. And if you ever work with Vue.js, by the way, I should have asked this at the beginning. How many of you work with Vue.js? Yes, more than a half. Good. I was a little bit afraid, but now I know. So if you ever work with Vue.js, you will see that the project structure was no different from a regular Vue.js application, really. Like, vStorefront at that time was just a headless front-end boilerplate. So you clone the repo, and from there, it's your project to take care of. Zero responsibility from our side. And the only meaningful addition there that we made were Elasticsearch configuration file and event bus. If you don't know what event bus is, it's quite simple pattern that allows you to create a separate Vue instance that will notify all of your components about certain things happening in your application. So it can expose events, it can react to the events. You just import this in different files and throw those events. And it's quite useful, but if you have too much of those events, your application quickly becomes very hard to debug. And this also happened in our case. So from the time perspective, honestly, I wouldn't recommend using event bus. Mostly because it opens a lot of possibilities for writing bad code, and we don't want that, right? So as soon as vStorefront became more widely adopted, and believe me, it got adopted very fast, users started asking us about things that we could provide with just, we couldn't provide with just this copy-pastable boilerplate, like upgradability or extensibility of default functionalities without actually losing this upgradability. So it was kind of clear to us that our user needs something else, not just a boilerplate, but more like a framework with a path to upgrade, a framework with a powerful extensibility system, and a rich ecosystem of extensions with different third-party providers, but also just extending the default functionality of vStorefront. And you will actually see this slide a few times today, because when you're building a tool for developers, there are two key things you have to focus on to make sure it's good. Really, only two things. First of all, you need to ensure that your users are able to benefit from new features you add to it in the simplest possible way. So a good upgradability. In addition, they should be able to modify the default behavior of your application without losing this ability to upgrade. So finding a good solution to both problems and keeping good balance between extensibility and upgradability are kind of keys to building a good library or a framework. This is what I learned in the last 6 years. And to achieve that, you have to split your boilerplate into different parts. To achieve that balance, your app needs layers. And it's very important to make the distinction between the parts that are a core functionality of your application, the ones that your users will be able to update and extend only in a very controlled way from the extension point, for example. And this is the framework itself. So the orange part is the framework itself. But there is also a boilerplate code that they are free to modify and is basically a custom part of the project. So at the moment when they bootstrap the project, it is their code, it's not upgradable, they can modify literally everything in there, they can just throw everything to trash, and the application should still work because the framework is not there. So according to this distinction, we divided our application into 3 layers. The core was the framework itself, and it contained essential functionalities required for the application to work, like e-commerce business logic, Vue.js setup, but also things like server-side rendering. At that time, it was quite hard to achieve that with Vue.js, believe me. I mean, the baseline setup was quite easy, but then the amount of corner cases, it was just beyond our imagination, really. So extensions were functions with access to some of the core functionalities like Vue Store that they could override or extend. And teams were the actual custom applications. So they consumed both core and extensions, and they provided a UI layer for the application. And teams were just a custom code. So it was not upgradable, and again, as soon as you clone the repo, it was your code to maintain, and you had absolute freedom to change anything there. So the high-level structure of the project changed, and it looked like this. So the src directory, it was basically the custom application, and the core directory shouldn't be updated as long as you want to receive updates. Now, keeping the core in the repository instead of shipping it as an NPM package allowed our users to consciously decide if they want to receive updates or maybe treat the whole project as the boilerplate and start from there. Was it a good decision? I will tell, I think, in like 15 minutes. So in general, it turned out to be a good decision because it allowed our framework to be more flexible, but it also had some downsides. Now, if you look deeper at the internals of each part, you quickly notice that a lot of things were spread across all of the layers, for example, components. So similar structure of the core, similar structure of the team, similar structure of the extensions, they made learning curves slicker. And once you understood one of them, it was quite straightforward to understand the rest. And in general, if you can use the same patterns or structures across your application, do it. Look for similarities, try to solve the same problems the same way. This will contribute to much better developer experience. So yeah, we split our application into layers. We had quite nice extensibility system that allows users to alter core functionality without losing this extensibility. So on paper, it all looked very good. But then the reality check came in. So if someone wanted to change the behavior of a certain feature, let's say a card, they needed to change many aspects of the application. For example, changing the card vendor to something else, it will require you to look through all the whole project to see what components you want to alter, what source you want to alter, what helpers you want to alter. And you know, JavaScript files related to the certain features, they were everywhere. So this is a lot of work, and it's also quite easy to overlook something. So we'll alter this card, and after half a year, you will discover that there's a lot of code related to the previous card that was still running, ruining your performance. It's not contributing to the good maintainable code base. So we had to find a way to make it easier. We started to look for a solution. And you know, again, when people want to alter some default behavior, they usually don't think about altering a specific Vue store component or route. In some small cases, yes, but this is not a good extensibility mechanism. It is too granular. So they want to change a certain feature as a whole and do it quite easily without searching the whole application. So each feature, like again, a card, product catalog, CMS integration, It could add their own view stores, routes, components, pages, or helpers. So the solution to that problem was domain-driven design. Anyone knows domain-driven design? It's absolutely wonderful concept. And once you dig into this, I can guarantee that you will love it. So what is the domain-driven design? Domain-driven design, also called DDD, is the concept that prioritizes business concepts over types of classification of your code base, like, for example, grouping by file type. So what does it mean exactly? So it means that you should structure and group your code based on the main business domain, which is the problem, and its subdomains. So categorize parts of the problem, which we see here. The problem here is e-commerce domain, and you can have a lot of subdomains, such as product catalog, customers, orders, inventory. So the image that we see on the screen illustrates the standard view folder structure. So if you want to replace some features, we have to change files in all of those folders. We have to look for them in all of those folders. DDD embraces writing code with this actual business logic in mind, which means that we organize our code and folder structures on the business features, such as customers, instead of technical terms like components, stores, services. And honestly, this way of managing code makes it much easier to maintain it, and honestly, I think that should be the default. So if everything related to a certain feature is in one place, it's quite easy to understand how it works, because there's no risk of overlooking some parts. It's equally easy to just fully remove a feature, because its code is not distributed across the whole application, right? So another benefit would be the fact that we can very easily reason about the business part of our application and its features just by looking at the folder structure. This is a really good developer experience. Okay, enough theory. Let's see the actual implementation. So in View Storefront 1, we split the whole application into domain modules. So on the left side, you can see some of them. And to add a feature, you are simply importing its entry point and passing to the register module function. So it was equally easy to remove them. One line to add, one line to remove a feature. Quite cool, right? So from the inside, each module was just a single function that had access to vital parts of the application. So the function was taking care of registering view stores, adding new routes, hooking into events of other modules, etc. And our hook system was also extremely cool, but it would take too long to explain, so maybe another time. So View Storefront modules were one of the concepts I'm extremely proud of. We use them for internal features, third-party dependencies, local extensions, one API to rule them all. Remember when I said, like, try to solve the same problems in the same way, try to have the same patterns consistently across the whole application? That was the holy grail of this. How cool is that? And if you want to dig deeper into this topic, I wrote an article about this concept on View School blog a few years ago. And it's based on Vue 2, but it's quite universal still. So while the first version of View Storefront was full of great ideas, it was also something we were learning on, and we're learning as we go. When I started View Storefront, I was a junior developer, so imagine how many mistakes I made. So it's impossible to do everything right for the first time. And in addition, at this stage, View Storefront became quite popular, really. Our users brought a lot of different use cases, and we also learned much more about how the software is used and how it should work. Like, it was 2017. Like, remember, no one had an idea about headless commerce. No one knew how to do this. We also had no idea how to do this, but we're, stupid or brave enough to just put things on GitHub and learn as we go. So after 3 years of View Storefront existence, new problems emerged. Some of them were caused by our decisions. Some of them were simply a result of user feedback and new cases they brought. Some of them were caused by external factors. First of all, we built View Storefront from scratch. This means that we not only had to come up with the mechanism that I mentioned, but also maintain the whole SSR logic. Like, I think the best comparison would be to Nuxt. Like, we've built our own Nuxt, really. And in addition, we needed to maintain ecosystem of integrations, extensions that were going far beyond just e-commerce. It was a virgin territory, really. Like, we needed extensions for stuff like SSR caching, SSG, this sort of things, very basic. Also, Vue 3 was already announced in 2019, I think. And we knew that composition API is the future. It was just a much better way of reusing code, and we knew that to keep good developer experience, we would have to adapt it. Another problem was the fact that overall architecture was quite complex. You've seen this, right? You agree it was complex, right? You agree. And at that time, Magento also learned from their mistakes, and they actually had their own Elasticsearch, so we didn't need it anymore. And we knew that fixing all of those problems will introduce so many breaking changes, so many iterations that everyone would hate us. So it will take so much time that probably it's better to do a full rewrite. So make people hate us once instead of making them hate us for a very long period of time with many breaking changes. And this is how we started building Vue Storefront 2. And I want to emphasize one thing. Full rewrites are rarely a good idea, and they come with a cost of resetting your ecosystem, pissing off a lot of people, and you can usually do this once, really. And even if you do this once, you still do a lot of harm to your ecosystem, so it's a trade-off, and sometimes you just have to do this trade-off. And at the same time, we simply didn't have enough people to maintain everything, and we also learned that we're recreating Next from scratch. So next, Chopin brothers, they were reaching out to us at the very early days of Vue Storefront, but Next was quite immature at that time. So we decided to do this in our own way. So we started a full rewrite, and we started it with those goals in mind. First of all, of course, we didn't want to maintain the whole framework with its extensibility mechanism, ecosystem. We just wanted to focus on e-commerce. That was our domain of expertise. That was the value that we were providing, and everything else was already out there with Next. And it was quite well established. This is why we adopted Next for Vue Storefront 2. Also, we wanted to simplify the architecture, make deployments simpler, and make hosting Vue Storefront cheaper. So no Elasticsearch, no data pumps and cron jobs, just a simple Node.js hosting that should be enough to use Vue Storefront. And also the problem that we are solving, headless, just not only a problem of Magento, and we wanted to make Vue Storefront available for all e-commerce platforms. And of course, it has to be built with Vue-free APIs in mind and migration in mind. Wait, someone is asking me to log into Wi-Fi. I don't want this. Okay. So on the high level, the new architecture looked much simpler. Instead of 4 applications and Elasticsearch database like before, it contained just 2 applications, really. So there was Frontend itself, and then the API middleware, everything below our third-party services that we're hooking into. So the goal of API middleware was actually to orchestrate those different third-party APIs. So imagine you have a CMS API, payment API, e-commerce API, search API, and a lot of other APIs. And instead of installing dozens of different SDKs in the front end, probably with different protocols, we can just call one API, the middleware, and the middleware will take care of resolving everything for us. So let's dig a little bit deeper into this middleware. Each integration with the third-party API was implemented in the form of API client. API client was just a set of functions, really, calling different APIs of a certain service, like e-commerce platform or CMS. We'll actually dig into the details soon. And from the user's perspective, and I'm quite proud of this, the middleware was just a single configuration file. That's it. So when you wanted to add a new API client, you were just simply adding it to the integrations object by providing the path and the necessary configuration, for example, for your e-commerce or whatever. And you are also able to extend each API client. So we'll get back to this in a moment. Under the hood, each API client was just a set of functions. And the way how middleware worked was that it was automatically transforming each of the functions into an API route. So if you wanted to run a certain function from a certain integration, you were just using the URL built from the name of the integration and the name of the function. And if this sounds familiar to you, and I hope it does, at least to some of you, it means that you have heard about RPC protocol, which works quite in a similar way, and which we actually took as an inspiration. And this concept got a second life recently. So anyone here heard about tRPC? Nice. I love it, really. It's a really nice concept from the developer experience perspective. So I won't lie. Using the single configuration file to control the middleware, it was really a good choice. Because it was just one client-facing file, and the configuration structure was rather high level, not tied to implementation detail, which, by the way, is quite important when designing APIs to have them abstract enough to not be tied to implementation detail. We would be able to even rewrite all the internals of the middleware without introducing breaking changes. This is how good it was. So at the same time, this simple configuration was enough to give our users all the necessary features. So in addition, because the API client itself was quite simple, the extensibility was also straightforward. So let's take a look. Each extension allows to create new API client methods or override existing ones by creating a new method with the same name. So one API that allows for both overriding default functionality and creating new APIs. Cool, right? So in some cases, extensions also wanted to create custom API routes. This is why we also exposed Express instance. We also provided some hooks that allowed extension to modify, for example, the configuration or parameters of certain API calls, or also the after call hook. On the other hand, it was quite useful for logging. So it was heard every time we run a certain function. And did I mention that we also built a UI library? I probably didn't. So one thing our customers were struggling with was quality of the UI. And for some reason, it's still super hard to make it right for most of the developers. And I mean, I probably know why. I won't dig into this during this talk. It has a lot to do with bootcamps, by the way. So this is why we've built Storefront UI, our component library. And I love to talk more about this, but it would take ages, and I see I have only a few minutes and I will exceed the time anyway. So for now, just remember that it exists, and if you want to learn more about this, check the documentation. It's completely free, it's open source, you can use it in your projects if you like it, you can contribute to this, which I really encourage you to do. So we already understand how the API middleware worked, and now let's take a deeper dive into the front-end part. So just like the previous version of Storefront, it had two types of layers. First one that cannot be modified and is upgradable, and this time we shipped elements of this layer as NPM packages to simplify this upgrade process, so no longer git pull. Second one was a boilerplate, and in that case, just like in the previous version, it was a theme. So you probably noticed lack of extensibility mechanisms for the framework itself. Well, this came out of the box with Next. So the theme itself, again, was just a regular Next.js application. There was absolutely nothing special about it except the middleware config.js file that we already talked about. So on the right-hand side, you see a standard Next.js project structure. Composables, they were taking care of fetching the data from the API middleware and binding it with the state and view reactivity system. So if you are a Vue developer, you probably already know what composables are. If you're not a Vue developer, think about them as hooks, but for Vue. And each composable was tied to a specific domain. So you can think about them as evolution of modules. And here you have a real-world example of composables usage. So each composable was exposing different objects and functions related to specific domain, again, like cart reviews. You don't see all of those functions, but you could imagine that use cart, for example, is also exposing a clear cart, add to cart, remove from cart, etc. And when it comes to the Vue Storefront Next module, it was really simple and contained basic configuration. It's boring. I will just skip that. And so what we can say right now about upgradability of the front-end setup here? Do you think it was good or bad? Raise if you think it was good. Okay. Raise if you think it was bad. You're too polite. But actually, after 2 years, it turned out to be quite resistant to the break-in changes. And I think the reason behind that was the fact that APIs were declarative and not tied to implementation details. So therefore, we're able to make a lot of changes internally in the packages without impacting the public API layer. So I cannot stress enough, again, how important it is to not tie your APIs too much to the implementation details if you don't need to. So when it comes to extensibility of composables, where the situation was a little bit more complicated. So we learned that our users wanted to use the composables in a completely different ways. Often they were consuming GraphQL APIs and wanted to make one request per page instead of separate network calls for product data, reviews, recommendations, etc. So this is where this domain-driven model kind of failed, because shipping composables from the NPM package was very limiting and often led to more network requests than it was necessary. So this is why we ultimately decided, okay, let's ship those composables as part of the boilerplate and let users modify them in any way they want. So the final architecture of Vue Storefront frontend looked like this. Theme and composables exposed to the user, while components and configuration shipped as NPM package. It seemed that every problem was solved. Finally, we have the perfect developer tool. And it was great, until it wasn't. Because remember when I was talking about making Vue Storefront Vue 3 ready? So Vue 3 became stable in September 2020. And from this date, Vue 2 was considered kind of like old technology. And Next 2 that we're using was using Vue 2. So Next 3 that was still in beta was still using Vue 3. The only problem is that it became stable 2 years later. So Vue Storefront is an open source project, but it's also a business. As you could imagine, it was very hard to sell a product that was using an old version of our framework. In addition, our clients, they wanted to migrate to Vue 3, but they couldn't. So next release, it was delayed so many times that it was so unreliable. We can only say to our customers that we are waiting. That's all. And don't get me wrong, I have a lot of respect for the Next.js team's work. Next 3 turned out to be a wonderful framework, and I'm a huge fan of it, highly recommend it. But software projects are getting delayed, and actually it was our fault that we made ourselves dependent on Next so much that we couldn't do anything. So obviously we didn't want to repeat that mistake in the future, and we're coming to an end soon because we wanted to become more independent. This is why we made a decision to make Vue Storefront independent from any front-end framework and Meta framework and become framework agnostic. So you can support not only Vue, but also React and Angular frameworks. And I know, we need to change the name of the company. It's another problem that we weren't expecting. But becoming framework agnostic requires much less changes than you might think. So let's see how the new architecture looks like. And yeah, like this is definitely not my best diagram, but until I learn how to make a better one, let me explain what happened here. So at the bottom, we see the middleware diagram from the previous architecture. Nothing changed here. It was already a pure JavaScript server-side project without any connection to the front end. What changed is the front-end layer. So instead of a Next module, we created a universal JavaScript SDK in TypeScript that was responsible for establishing connection with the middleware. And it had a lot of features under the hood that were aiming to optimize the network requests and make them more reliable. And the concept was quite simple. Each API client on the middleware needs SDK module. So the front end that is responsible for fetching the data and you trying that if something goes wrong. And from the code perspective, this is everything you have to add to your front end to establish a connection with the middleware. So after running this code, you can consume all middleware APIs. Just add modules when you add new API clients. That's it. Quite cool, right? So we wanted to keep the same simplicity as before with Next module, but make it framework agnostic. And this is why it was purely just a TypeScript library. The new final perfect front-end layer after 6 years of iterations look like this. HTML composable or React hooks, they are part of the boilerplate. And this way, our users achieve the best customizability. SDK, which binds the front end and the middleware, is shipped as an NPM package, and same with Storefront UI. So after so many years, I'm quite confident that this approach has the best balance between flexibility and upgradability. And this is, my friends, after exceeding my time, is how we build the perfect toolkit for e-commerce development. But we'll see in a year from now if it is really perfect. So thank you so much for listening to my talk. I hope you learned something valuable. Thank you. And I hope this talk will help you to actually build better libraries or a better software in general. I'll post my slides on Twitter, enjoy the rest of the event, and enjoy the break, because the lunch is there. Thank you.
Okay. Awesome. Thanks for that super amazing and insightful talk, Philip. And I'm definitely going to plan in the future coming to Poland. And maybe I'll get some food ideas from you, like where to go and where to eat. But yeah, definitely that's on my plan list. So yeah, definitely.
Thank you, Philip.
Awesome.
I know you all are hungry. We all are hungry. So let's go eat. We have the foyer for the conference tickets that you have that have the paid food option. You can go to the foyer. The lunch is already placed there, and few of your peers will be already there. And for those of you who do not have the food coupon, we still have the food court, and the food court has a lot of options. You have idli, you have vada, you have everything there. So please go on to the food court and have some good lunch and come back with the same energy as you were there.
And also one more last thing before we all leave. So as you folks already know, there's a community lounge section. And if you had watched the opening ceremony of the conference and you are interested about how Abhinay jammed music and JavaScript together in our opening. So in the community lounge, there is going to be a talk where Abhinay is going to be talking about partying with algorithms. He's from Algorithm India. So feel free to check that talk out in the community lounge. So yeah, and see you after the lunch break.
Thank you. Thank you, everyone.
I think, Varsha, I got to know that there are some momos and chole
let's
bhature
go.
stuff is there. Let's go. All right, see you guys.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with PreMagic's real-time photo distribution. PreMagic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort, Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-Magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem when dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is Data for Engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk. separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with Pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with Pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with Pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with Pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
chit chat because so team says like the instructions from the team have been that I should talk to you for 2 more minutes and then we can start. So and how many are out? I'm guessing most other people are from other cities. Who's from Delhi? Nice. How many of you have had ghee puri idli from Bangalore? Oh, so if you're visiting Bangalore and if this is your first time, you definitely have to have at least ghee puri idli or the dosa, and make sure you do not go outside Bangalore unless you have ghee puri idli or dosa. And yeah, most of my fillers normally are talking about food because I'm a big fan of food. But with this, we will get started with our first talk after lunch. And we have with us our next speaker, Vivek Pal, who is going to talk about a lot of things, including about WebAssembly. So let's get started, Vivek. Please, we'll be happy to have you on stage. Let's give him a round of applause. This is his first talk in public. So let's make sure he feels special and he feels energized for his first talk. Let's give him a round of applause. How are you feeling, Vivek, for your first talk?
Last night I am with 1 hour sleep. So actually, if I fall asleep here, so don't mind, please. So
Don't worry,
was
we have
good.
first aid and we're all set.
Yeah.
All set, Vivek? Till Vivek is setting up his laptop, does anybody have any special anecdotes from their first public speaking session or first talk that they give, something very funny, weird, awkward, if somebody fell down on the stage, like he was mentioning? Does anyone have anything to share? I think most of them are, oh, we have someone. Yeah, I'm coming to you with my mic. Let me run.
Hi, my name is Faizan. So I did one of the React meetups once, right? And I prepared a topic on how to, let's say, do some state management Redux, but for certain particular niche use cases. So before I went to talk, there are other speakers obviously in the list, right? And this one guy comes, and the topic title is "Don't use Redux," right? And he goes on like a half-an-hour rant on why Redux is the worst thing in the world, and you should be using some other technology other than Redux. And so then I walk up to the stage, I'm like, so this is why you should be using Redux. So yeah, so that was a quite fun talk.
Thank you so much. And yeah, Vivek, please go ahead.
Yeah. So hey all, I am Vivek. I am building Sastra OS. It's a decentralized desktop operating system. So it's based on Linux. So it's a Linux distro. So I am just using my own custom-made Linux distro here. So today I am going to talk about WebAssembly system interface. So today we are going to talk about WebAssembly, WebAssembly system interface, which is a system interface for WebAssembly to run WebAssembly outside of browser. And we will also talk about integration of JS and WebAssembly. So like you can make your custom WebAssembly JavaScript modules to run your code on WebAssembly. We will also talk a little about assembly script, which is a TypeScript for WebAssembly. So let's talk about WebAssembly. So like we have heard a lot about WebAssembly. So it's a binary instruction. So it's a binary format code that runs in your browser. So which means you can run a near native performance code on your browser. So it's a binary instruction for stack-based virtual machine. So what's stack-based virtual machine actually? So stack machine is based on last in first out basis. So like you have data element put in and you have data element put out of the stack. So this is how WebAssembly code executes. So like we have other programming languages, we can compile C code, C++ code, Rust code, and Go code to and this Python LLVM code to WebAssembly. So WebAssembly virtual machine runs that code on our native machine that is your x86 or ARM. So what are virtual machines? So virtual machines are you can say a machine that is virtually running on your real hardware. So these machines are like you have given sort of resources to these machines. So there are two types of virtual machines, stack-based and register-based. We talked about stack-based, so WebAssembly runs on this stack-based virtual machine. So why WebAssembly? Performance, obviously. WebAssembly runs on near native performance due to its structure, like your code is compiled directly to a binary format that runs in your browser. Cross-chain compatibility, cross-platform compatibility. So you can run a single WebAssembly code in your any sort of device, whether it's x86 or ARM. So language agnostic, you can run any language possible on your browser using WebAssembly. Security, it runs in a sandbox environment. Like we all have heard of Docker. Docker runs in a sandbox environment. Suppose if you get a code and you want to run in different different machines without breaking your code, or without you want to just give a compatibility layer to that code for all machines. So you have sandboxed environments. So it's also a sandbox, and WebAssembly is also a sandboxed environment. So it provides security so that your code will only take resources that are being executed to it. So interoperability. So basically your code is so WebAssembly is interoperable. So board industry support. So like we have WebAssembly there are lots of communities. There is also WebAssembly, W3C community. So we have top level support like very famous companies, Google, Apple are working on WebAssembly. Community and ecosystem, like I have talked about, it has lots of communities and ecosystem is developing rapidly fast. WebAssembly in browsers. So almost majority of browsers support WebAssembly. So your browsers, before WebAssembly, your browsers had a V8 engine, so that get your code run and your JavaScript code run into the browser. But in for WebAssembly, we have Servo. Even V8 and SpiderMonkey are also working on WebAssembly, so that your WebAssembly code is compatible with that that V8 and SpiderMonkey engine. So like we have Firefox, which support WebAssembly, Chromium-based browsers, and Safari and Edge. WebAssembly modules. These are the, you can say, very important part of WebAssembly. So WebAssembly modules are the modules that takes your code to the binary format. So these are building blocks of WebAssembly applications. So WebAssembly modules are compiled from source code into binary format that can be executed by WebAssembly virtual machine. That's in our case, like if we are running our code in browser, in our case it's Servo engine. So WebAssembly modules in JavaScript. So here we can fetch our WASM module in JavaScript and run our JavaScript code in WebAssembly. So here, like we are adding two numbers, 5 and 3. If we want to execute in binary format, we can create this WASM module and run our code in WebAssembly. So now let's talk about WASI. WASI is a secret source that can put your web application to the next level. Like you can now run WebAssembly to servers. So your servers become more faster, more performant and secured than ever. WASI stands for WebAssembly System Interface. So it's a standardized set of APIs that allows WASM modules to interact with the host operating system and its resources in platform agnostic manner. This means that now those WebAssembly modules can interact with your hardware level functionalities such as let's say files or your memory and your internal architecture. So let's talk about portability. So you can here see the C code that is converted to WASM bytecode, and now that WASM bytecode can run on any user that is x86 or ARM. So on any platform like Linux or Windows or Mac. So key features of WASI. So first of all, sandbox environment, of course. Like there's a tweet by one of Docker co-founder. He talked about like if at that time if WASM and WASI was built, they didn't have to create Docker. So they talked about this thing, sandbox environment. So WASI runs outside of your browser in a sandbox environment, so that you can initiate all files and in a particular manner that you want. So standardized API, So WASI is a standardized API, means that you have a set of API that can run on any sort of virtual machine. So minimalistic interface. So WASM code is very lightweight. So that provide WebAssembly system interface, very minimalistic interface. Isolation and safety. So due to this sandbox environment, so we have a highly secured interface. It's a platform agnostic, like WebAssembly, interoperability like WebAssembly, and it's feature proof also. Building web applications with WASI. So you can build file system operations like, if I show you, this is IPVM. If you have heard of IPFS, it's a interplanetary file system. So basically your several nodes are running globally, so you can store your files on those nodes in a distributed manner. So IPVM is a virtual machine implemented on IPFS. So actually it is giving computation power to IPFS. So it's a good kind of implementation of WebAssembly system interface for file system operations. So actually we at SastaOS are also working on IPVM to provide distributed package management system on any Linux distro. Networking, so you can build networking applications, you can build system integration applications, database access, secure cryptography. There are lots of like blockchains developing on WebAssembly system interface. Command line tools, we can build command line tools with WASI. So it gives those command line tools platform agnostic manner. So let's talk about assembly script. Assembly script is a TypeScript that is built for WebAssembly. So now you can run your TypeScript code to WebAssembly directly, like without creating WebAssembly modules. So TypeScript to WebAssembly compiler. It's a TypeScript to WebAssembly compiler. So here is a assembly script code that calculates a factorial of a given number. So here is a factorial function. So here it returns its result. Using WebAssembly, using assembly script module in JavaScript. So if we want to run assembly script, if we want to run assembly script code in JavaScript, we can use these kind of modules that I have talked you about it before. Some cool use cases of WebAssembly. So now I am going to show you some cool projects that are being built on WebAssembly. So TensorFlow.js running on WebAssembly backend. So TensorFlow are implementing WebAssembly. So like earlier machine learning codes were like a little bit difficult to run on TensorFlow.js. So Google Earth is an application like most of us have used. It's also rendering 3D representations on WebAssembly. WebAssembly package manager. So it's a package manager of WebAssembly. So if you want to build applications on WebAssembly, you can have lots of inbuilt packages for WebAssembly. Qt is like if you have used Linux, you have heard of KDE. KDE is a desktop environment that's used in various Linux distros. So it's a web. So Qt is a widget toolkit for your KDE. So KDE applications are built on Qt. So Qt is also implementing WebAssembly system interface. So WASMR is a runtime for WebAssembly system interface. So WASMR is also made with WebAssembly. And IPVM that I have talked to you before. Another cool case that I found recently is SWC compiler. If you have used Next.js 13, they are using SWC compiler. Using it, like you are having a huge performance improvement in Next.js projects because of this SWC compiler. It's written in Rust. Limitations and future of WASI. WASI is in production, like they are having very good community and team. One of them is Lynn Clark. They are having monthly and weekly meetings over WebAssembly. So it's in development, and it has lots of limitations, internal limitations. Conclusion, like we all wanted to like run our code on browser at a very performant manner. So WebAssembly is key to that thing. Resources, if you want to find the resources, you can scan this QR code. It will get you to my slides repository. So here you can find resources. I will update this. I will also keep updating this repository in upcoming future time. Also, you can head over to me at Twitter. So this is my Twitter. You can just head over to me to my Twitter and give a follow back, and my DMs are always open. So thank you everyone. So this was my talk. So
Hello, sir. Yeah, thank you. Thank you so much, Vivek. It was an amazing talk, and it was your first talk. We're honored to be the conference where you gave your first talk.
I think we need to have a huge round of applause for him for having the courage to be on a stage, such big of a stage for the first time. So before you leave, we have one question for you.
Is that okay if we ask you a question?
So what is it that made you interested into engineering? What is it that excites you the most about it? You can use the mic.
So actually, engineering is a sort of experiments that you can do every day. So that's excited me about engineering. Like I was in about 3rd or 4th class when I got my first laptop.
Whoa.
So I started from there. But I was indulged in studies and school manner. I prepared for JEE. Now after getting over my class 12th, I started learning about these things. And now I am in 2nd year college.
Oh,
my
wow.
God.
I think that deserves a round of applause,
Yeah, he's
please.
in 2nd year of his college. Wow, you're doing amazing.
Thank you so much. That reminds me of a question. When did you get your first laptop? What was your first experience with a desktop or a laptop?
My first experience with a desktop which belonged to my dad in the office, and me and my brother, both of us used to wait until he used to go out for his work so that we could play Pocket Tank. Does anybody remember that desktop game Pocket Tank? Yeah, that is still, I don't know, I don't play Xbox, I don't like games, but my heart is still stuck on Pocket Tank, and the way those, you throw those machines over each other and you break each other's mountains. It's amazing. That was my first time with a desktop. What about you?
So I think I'd had a exposure to laptop much later. So the first experience was definitely to a desktop, a big computer, big monitor with a big CPU and all that system. And my first game is, I think, pinball, who all have played it. Almost all of us, right? And then I think Mario was my second game that I played. So quite amazing childhood memories.
I think Mario, we used to play on that sad console. And we had to hit that console so that it worked, because it never worked for me.
Definitely, definitely. So I think now let's get to our next talk.
Yes.
So we have our next speaker with us. You can join us on the stage. So we have a talk on a practical guide to implementing CSP to secure client side by Lava Kumar. He's the founder of domdog.io. Let's welcome him with a huge round of applause. Yeah, all yours.
Stage is yours.
So can I get started? Okay. Hi, everyone. Can you hear me? Yeah, perfect. Okay. Hello, I'm Lava Kumar, and my talk is on practical guide to implementing CSP. Before I get started, I want to thank you all for attending my talk, because the other speaker in track 1, she's been trying to poach people from yesterday. She even asked me to come and attend her talk. So I'm glad you guys are here. And in a developer conference, it's good to see so many people interested in security. Before I get started, I want to know how many of you are already familiar with CSP. Can we have like a raise of hands? Okay, awesome. Okay, cool. So for the rest of you, CSP, it's a new concept. So what I'll do is I'll talk about the rise of client-side attacks, because before we talk about CSP, CSP is a protection mechanism. We'll first try and understand why client-side security is important, and then we'll talk about what we can actually do, in terms of protecting it, and then I'll talk about some practical steps in terms of implementing it. Because the ones who are familiar with CSP, or if you have tried to implement CSP, it's always difficult. It's kind of like, trying to get six packs. It looks good in theory. Everybody goes to the gym, very excited. The first week they're all dieting very well and everything, and afterwards you're like, what, fine. I'm okay with having a bigger belly, but I cannot go through this. So there are some techniques and tips. If you follow that, it actually becomes easy for you to deploy CSP in a very practical way. And that's what I'm going to cover. And along with that, what I'm also going to do is I'm releasing a free scanner. This scanner is for analyzing your client-side code and identifying security-related stuff, right? And you can also use it for debugging and other things as well. So that's also something I'll show you where you can download from and how you can use, right? So that's, in a nutshell, what the agenda of the talk is. All right, so when we think about security, most of the time, you normally think your server-side, which is your firewall. You never have a web application facing the internet without a WAF, right? So that's a bare minimum. And then you have other things as well, secure coding, pen testing, a lot of things happen for the backend. But for front end, when we talk about security, people are sometimes confused. It's like, what? We do security on the front end as well, right? But if you think about it, all of the sensitive stuff you have on your backend, everything is accessible from your front end, right? If your backend is like a vault, instead of the attacker trying to break the vault and get in, like they show in the movies, they just have to steal the key, right? And your client side is the key. So if they manage to inject a few lines of JavaScript code into your client side, they can access all your backend code, just riding on a user's session. And there have been, so this kind of, because there's lack of focus on client-side security, it creates a low-hanging fruit. And attackers are, very lazy people, believe it or not, hackers. It's not like how they show in the movies. That's why they do all the bad things, because they can work for 1 or 2 months, make a lot of money, and they can, relax for the rest of the year. So they typically tend to go behind easy targets, low-hanging fruit. And because the client-side aspect of your infrastructure is more weaker, we've been seeing a lot of rise in attacks on client-side. So there is a specific attack called as Mage-cart. So if any of you have anything remotely to do with e-commerce or payment processing and so on, then this is very relevant for you. This is an attack which has been going on for the last 3-4 years. And there have been hundreds of millions of credit card deals which have been stolen, all by injecting a few lines of JavaScript code, right? So this kind of forces us now to look at security of the client side, because this is being actively exploited. And if you're thinking about whether I should try and put emphasis on client-side security, so this should probably help you decide, which is if your company or your organization is related to e-commerce, if it's doing any kind of flight booking, hotel booking, any kind of transaction online, if it's dealing with sensitive information like, say, healthcare data or fintech information, then you might want to think about client-side security. And again, you don't have to look at client-side security throughout your app, because you might have a very big application, right? And it might get overwhelming to try and lock down everything. You can pick up the most sensitive sections of your site, which could be your checkout pages, registration pages, login pages, and any other pages where you are collecting sensitive information from users, right? All right, so when we look at security on the client side, these are some things which you can think of as your high-level goals of what you can achieve, which is your web page is loading a lot of resources, images, iframe, CSS, JavaScript from different places, right? So you need to have some kind of a control of what you're loading from where, right? So that is one thing, which is what kind of content you're loading from third parties. And then the big one is your JavaScript. What JavaScript you're loading and from where, right? So you need to have some kind of control over that. And then you need to have control over the JavaScript behavior itself. So I'll give you an example where in a Mage-cart attack, what the attackers did was they went and scanned the internet. I'm sure all of you are familiar with S3 buckets, right? And you know that there are S3 buckets. If they're not configured properly, then anybody can write to an S3 bucket, right? So what they did was they went and scanned the internet to find publicly writable S3 buckets. And once they found those S3 buckets, they scanned those buckets to look for JS files. And once they found those files, they injected their malicious web skimming code into those files, right? They didn't know if those files will be loaded by a website or not, and if that website would be a payment page processing website. They didn't know all of that. They just went and, it's kind of like putting a landmine. They just, threw it everywhere. And surprising, a lot of scripts were being loaded from S3 buckets into checkout pages. And that attack was very successful, right? So even if the file is the same, right? It's your own file, it's being loaded from the same place. The content of the file can change, due to some attack which is completely outside the developer's control, right? Because in this case, this was, because somebody compromised S3 buckets, right? Which is not something the developer has any control over. So you'll have to have some way to control your JavaScript's behavior as well as content. And then the data flow on the client side, because this is very important. You accept a lot of sensitive data from the users in your forms. You need to kind of see where this data is going. I've seen examples of fintech companies where they collect PAN card information and then they send it to Google Analytics or somewhere else, all because they had misconfigured it when they were setting up the third-party code, right? So this is also something you will have to keep track of. All right, so now that we have established those as the high-level goals that you can aspire towards, right, when we're looking at client-side security, where do you get started? So I would say client-side security is a journey. There are a lot of things you can actually do. But the first step you can focus on is having a content security policy. And content security policy is a client-side web standard. It's part of your browser, right? And in terms of the amount of time you would spend on implementing a CSP policy, you would get the maximum return on investment. So if you were to start somewhere, then this is probably the best place to start from. All right, so this is a little bit about CSP. Like I said, CSP is a standard, web standard. So you create a policy which is like a firewall. It will essentially say what resources your page can load and from what places, right? In a nutshell, that's what a CSP policy is. And you add it as an HTTP response header, and it is sent to your browser, right? So when the browser loads your page, it will first look at the CSP policy, and it will use it as a reference before it loads any resources. Let's say your web page says, I have to load JavaScript from xyz.com. So before your browser loads the script, it will look at the CSP policy, and if the CSP policy says xyz.com can load JavaScript, only then it will allow it, right? So that's how it does its filtering, and it's all built into the browser, so you don't have to worry about performance. It's extremely fast, extremely efficient, and the browsers do a lot of things internally to make sure that it does not affect your regular load speed and other things. All right, so CSP is great. I'll not talk about the what the CSP policy looks like, because you can do a Google search and you can find all of that. But I'll speak about, like I said, how you can actually implement a CSP policy, right? What are the actual steps you can follow to implement it in an easy way? So typically people find this difficult, but it does not have to be if you follow the right way. All right, so we can break down our CSP policy journey into 2 steps or 2 stages. I'll say stage 1 is having a monitoring mode policy. So with monitoring mode, you get into a position where you have visibility into what is happening on your client side. I'll give you an example. Let's say tomorrow your site starts loading JavaScript from abc.ru, for example, right? Would you even get to know about it today, right? Probably not. So our first step is to actually get visibility, which is if we are loading some resource which looks suspicious or it looks a little weird, as a site owner, at the very least, you should be informed about it, right? So that's our monitoring mode policy. And once you get there, and if you're comfortable, you can actually go to the next stage where you can actually block these things from being loaded itself. So the first step is detecting an attack. The second step is to see if you can actually go and block the attacks as well. Okay, so to get started, as a step 1, you will have to create an initial policy for your site, and you will have to deploy it. And for doing this, so like I said, there's a free scanner that we are putting out. You'll be able to download it from this URL. We also have some pamphlets which we'll distribute. It'll have the download URL for you. And this is kind of what it looks like. I think this should play, yeah. So you start the scan, and then you can go and visit your website. And you can go and go through all the workflow that you have on your site, authentication, whatever, because all the data is kept locally, nothing is sent to our servers. And after you do that, if you stop the scan, then automatically a CSP policy is generated for you. So here you see an auto-generated CSP policy. So this is the policy, and it also explains to you as to what kind of capabilities the policy provides for you. Like for example, loading unauthorized JavaScript files is allowed by this policy, but it will trigger a violation, which means if an unauthorized JavaScript is loaded, it will not break your site's functionality, it will load, but you will be alerted about it, right? So there are other capabilities of the scanner as well. I'll probably talk about it a little later, but this is one thing you can use to actually create a policy in like a matter of few minutes. Okay, so once you create the policy, then comes the other part, which is, okay, I've defined some things in the policy saying I can only load JavaScript from a.com, and now my site is loading JavaScript from b.com, right? So there is a policy violation, but I'll have to consume this violation somewhere, right? I need to have some kind of a monitoring system where I get to know that, hey, there was a policy violation taking place. And for that, you typically use what is called as a CSP report violation monitoring systems, report monitoring systems. There are a lot of them. You can set up some system of your own. You just have to open a REST API and you can start consuming them. It's just in JSON format, these violations. Or you can use any of the commercial solutions available, which do this for you. And the best systems, what they do is, you would get a lot of violations from the browsers. A lot of them would be noise as well. And it can get confusing to actually make sense of all this stuff you get. So a good report monitoring system, what they'll do is they'll consume all this data, they'll clean it up, and they'll give you very clear information as to, hey, this is a new behavior that, something that you will have to look at. So, for example, this is, like a listing from our dashboard, like where we show you what are the, new kinds of violations that you're getting. And we also try and categorize these behaviors into malicious or, benign or unknown, right? If it looks bad, then we say it's a malicious one. If it's a very well-known behavior, it says it's good, you don't have to worry. And if you're not able to make a determination, we'll tell you that, okay, there is a new behavior for which we don't have much data, maybe you can go and evaluate it, right? Okay, so you set up your CSP. So first thing is you put your policy, and after that you set your report monitoring system. And after you do both of that, you look at your reports that come, kind of like this. And based on that, you keep updating your policy, which is to say, you put your policy, and now you see that your site is loading scripts from b.com, right? You're getting a lot of violations for it. Now, if b.com is a trusted domain, and you're legitimately loading it, you can update your CSP policy to also say, okay, I want to load scripts from b.com as well, right? So you keep doing it, and in a short period of time, you should typically have a stable policy. For monitoring mode, this is our estimation in terms of working with a lot of customers. So we process about, last month we processed 3 billion CSP violations. So, from our observation, the initial policy will take you 10 minutes for a static site and 20 minutes for a dynamic site. And the stable policy is when it's gotten to a stage where you don't really have to update it too much, right? Maybe you update it once a month or once in 2 months at most, when you are doing some major changes to your app. So typically for a static site, you can get to that stage in 1 week. And for a dynamic site, you can get to that stage in about 2 weeks, right? And so if you're planning to plan some effort estimation, this should give you some rough idea, right? It's kind of like, okay, you want to go get 6 packs. This is saying that at least it will take you 6 months. So in your head, you are clear that, okay, that's the minimum amount of time I'll have to spend. So your enthusiasm is not lost after the second week, nothing is showing up. Okay. So now that we have covered the monitoring mode, we can get to the second stage. Before getting to the second stage, if you stop with just the monitoring mode, you are still in a very good position because you have attack detection capabilities. If there is a compromise on your client side, at the very least, you would get alerted about it, which is a very good place to be at compared to where you were earlier, where you had complete lack of visibility into what is happening on the client side of your infrastructure. But after having done that, you want to go further, then we can actually try to go for a blocking mode policy. And blocking mode policy is where it starts getting tricky. And most people struggle here, and this is where they give up. So it is like, if I were to go back to the same 6-pack analogy, for full disclosure, I don't have a 6-pack. I don't know why I'm using that example, but anyway. So it's easy for you to build the muscle inside. What is hard is to actually cut the fat, so it's visible, okay? So this is the fat cutting part. So this is the most difficult part of getting your this thing, 6-pack. So blocking mode policy is hard to do, and the reason is, what people do is they get a monitoring mode policy, and they try to convert that policy into a blocking mode policy. And that usually doesn't go very well because there is a risk of your site's functionality breaking, right? So because of which there is either they are too nervous and they never move it to blocking mode. It's like that email, very angry email you wrote, but you never clicked on send. It's kind of like that. They have the perfect policy ready, but they never put it in blocking mode. And or they wait for either the management says, for one of our customers, the management said, it does not matter if we have business loss for a few months, we want this policy because the attacks, mage cut attacks that were happening was a very real threat for them, right? So if you have a business buy-in like that, then you can go and say, okay, fine, I'll deploy it. But otherwise, what you can do is you can actually keep your monitoring mode policy because the browser supports multiple CSP policies at the same time, okay? Which is you can have a monitoring mode policy and at the same time you can have a blocking mode policy. So your monitoring mode policy can be very comprehensive, and your blocking mode policy, you can keep adding things one by one, right? Whichever you think is safe to add, you're not seeing too many violations, you're not seeing too many behavioral changes. Like for example, JavaScript. You have, you have said, okay, I can load JavaScript from a.com, b.com, c.com, d.com, and your site has not loaded JavaScript from any new domain for like a month or two, right? then you can confidently go and put just your script section of the policy in blocking mode, right? Because there's not a whole lot of changes taking place. But for images, maybe there are new domains which are loading images all the time. So images, maybe you'll never put it in blocking mode, right? You'll always keep it in monitoring mode only. So that's an approach you can actually take. And right, so if any type has too much dynamic content, like I said, images usually, you never have to put it in blocking mode. And if the script, for example, JavaScript is changing too often, right? You're loading JavaScript from a lot of different domains and all that, then you would want to put it in blocking mode because script is a very sensitive kind of item. But you cannot put it just by giving a host list, by giving a list of hosts. So what you can instead look at is an option called as using nonce. So with nonce, you can actually whitelist a section of scripts, and you say, okay, these scripts I'm okay with loading on my site, and I authorize these scripts to go and load any other scripts on my site, right? So if, for example, you're loading an ad provider's JavaScript, and they go and load 5 other scripts on their site, you don't have to mention those domains in your CSP policy, because you're saying, okay, the primary script I'm authorizing, and I'm also saying it can load further scripts. So this way you can actually put your script SRC, your JavaScript in a blocking mode without having to have like a very big list of domains that you're maintaining and constantly updating, right? All right, so we can first move the items which have the highest importance. Like I said, script with nonce and strict dynamic. One of the easier things to move is like your form submissions, because form submissions usually are to a limited set of domains. You don't add new domains so much. But form submission is a very sensitive thing, right? You don't want your form submissions going to random websites, so that is something you can add to the blocking mode policy. So you can see which ones are very sensitive. At the same time, they're not changing much, and you can keep moving them one by one. Right, and other ones, maybe some of them you never move to blocking mode, right? So they remain in the monitoring mode, which is completely okay. You have some in blocking, some in monitoring. And with that, you will get to like, not the best security, but like what is good for you, right? So, and this is a bit of a effort estimation of how much time it would take for the different kinds of resources that you have on your site. For scripts, if the site is not very dynamic, you could go to blocking mode in about a week. For scripts that are dynamic, you could it could take you like 2 weeks, sometimes even never. You could go with nonce and strict dynamic, but sometimes the development effort for doing that is so high that you never get to do that. So you can just keep it in monitoring mode. Form submission is very easy to do, like I said, because it does not change so much. So anyway, this is available in the slide, so you can use it as reference. So if you're making a plan, you can use it as a reference, and then you can say, hey, you know what, this is how much time I'll have to essentially spend, right? So that should give you some idea. All right, so with that, I've kind of covered the most of the points which I wanted to talk about. So now what I can actually do is I can show you a bit of the scanner that we wanted to launch here. So the scanner is available as an extension to this tool called WebSuite. WebSuite is a free tool. If you have done anything related to security, then you would definitely know this tool. So it's free. You can download, install it. There's a lot of documentation available as to how you can do it, and you can add an extension to it in Web, and then you can open your browser. You can configure your browser to use WebSuite, and then you go to scanner.domdoc.io. Okay. And this will actually load our scanning engine. Our scanning engine is like a WebAssembly module, right? So that will download it locally onto the page. And this WebAssembly engine and the Web extension, they work together to do the analysis. So all of the data remains locally. Nothing gets sent to your server. Although it says scanner.domdoc.io, nothing is going to my server, right? And you can confirm that also. So, and with this, what you get is, and it's a passive scan. If you browse, it will tell you what CSP policies you have, how good those CSP policies are. For example, I just scanned Amazon.com. It will tell you what security is provided by the existing policies. You can look at all the JavaScript that the site is loading. So you can look at all the third-party code you're loading, and you can see what each of those third-party code is doing on your site, right? Because your own script's behavior is something that's known to you, but when you load an external script, you do not know what it is doing. Is it accessing your storage? Is it sending Ajax calls? Is it using insecure APIs like eval, for example, right? All of that information will be listed here. So like, for example, here it says that this script is using 2 dangerous APIs. And I can see what those APIs are. It's using the inner HTML property. And it says that this script is making Ajax calls to these domains and so on. So yeah, so you can see the individual behaviors of all the scripts that you have. And you can also go and see category-wise, like for example, data security. So here it says that whatever data I enter into the field, for example, I went to Amazon and I searched for Jsconf India, and it says that the data from this field, which is my keywords field, was being sent to Amazon.com, and I can click on it, and it'll actually tell me the actual URL in which the data is being sent. So here the data is being sent in a post request. So for example, if you have a registration form, right, where you're accepting user data, you can actually use this tool. You can fill in the form, and you can see if any of your sensitive data is going to some third parties that you don't want to send it to, right? Right, and it'll tell you what are the keyloggers, which scripts are reading which input fields, and so on. So that's in a gist what it does. So you can go try it out. And if you have any feedback, you have suggestions, ideas, whatever it is, you can let me know. I'll be more than happy to incorporate it. Again, I'm not a developer. I mean, I write a lot of code, but I wouldn't call myself a developer. So so this is a security tool, but being shown to developers. So whatever you guys think, hey Lava, what, this way you're doing it is completely stupid. Can you do it like this instead? Please feel free to send it. Yeah. Okay, that's it, guys. So if you have any questions, whatever, you can come talk to me. Yeah.
That was an amazing session.
Sure, sure. Yeah.
Multiple mics working at the same time. I know in college I used to sit behind so that I never had to show my assignments. But come on, here no one's going to check your
Who
assignments.
all are the last, like backbenchers here? We can see some of them. So the seats in the front are unoccupied. If you want to come, you can come here in the front. We also have some bean bags if you want to spread your legs and relax for a bit.
Yeah, because we're already talking to a lot of AI, and at least here we would like to talk to some actual people and not feel like we're talking to black chairs, empty chairs. Please come and sit in the forward if it's fine. If it's not, it's completely okay.
Cool, cool. So I think we are a little low on energy here. So what we are going to do is that we are going to give some FOMO to people who are outside or people who are in the other track. So we are going to give a huge cheer so that all of them feel that something exciting is happening here, because that is going to happen. All the upcoming talks are very interesting. So let's do it, okay? On the count of 3, 2, 1, you have to give me a huge shout out or a cheer or woohoo, anything, okay?
1 minute, Khushbu, but please make sure you don't cheer, because if you cheer, all
Everyone
our ears
cheers.
will.
Okay, let's do it, okay? 3, 2, 1, please. Who was that?
That seemed like an engineering college cheer, pretty much.
Cool, cool. Let's play a quick game. What do you say?
Sure, I'm always up for games.
Okay, so for that, what we have like 4 actions. So when I say stand up, you have to sit down. When I say sit down, you have to stand up. Okay, that is just as simple as that. And let's see how many defaulters we have. Do you want to moderate it?
I think I'll give it to you. You know the game better.
Cool, cool. So sit down. And you have to be quick, okay? Let's be quick. Stand. 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 We have some defaulters. Sit down. Oh my God, it's so hard for people sitting on beanbags to stand up.
Yeah, it is.
Please don't fall, guys. It's okay if you don't want to stand up. Stand up. Cool. I think that's good enough, right? So I'll leave it to you to introduce the next speaker.
Yes, our next speaker is going to talk about something that a lot of people is basically around most of the conference that's happening, that's in the front-end domain. And I did take some time to ask how the talk was, what it was revolving around, and I personally found it to be very interesting. So yeah, we have Sarvana Srinivasan talking about building a better micro front-end application that offers platform freedom. Let's give a round of applause for him.
Louder, please. Let's cheer him up. Thank you.
Sure. Just a second. Okay. So, hello and welcome everyone to the talk, Build a Better Micro Frontend Application that Offers Platform Freedom. I'm Saravana Balaji Srinivasan. I work as a senior software engineer at Red Hat, mainly on JavaScript technologies. I've been contributing towards business automation products and serverless workflow specifications, etc. So yeah, that's about me. Well, we are in JavaScript conference, right? So let's talk about JavaScript. JavaScript is here for almost 28 years, right? It has passed silver jubilee years marks of 25 years already. Even the growth of JavaScript over the years has been tremendous. Even the frameworks that was built on top of JavaScript are here for quite some time. React recently has celebrated its 10th year. Angular and Node.js are here for almost 14 years. And Vue.js is here for 9 years, and the list goes on, right? It means the applications that are built on JavaScript are quite getting a bit old. When I mean old, it has been so long the applications are being developed or maintained, right? Eventually, the applications are growing, and it is growing on an exponential rate, right? So when an application is going bigger, I tend to have a lot of issues with it. Scaling a bigger application will be quite complex, and to maintain bigger application also will be a tedious task, I guess. I mean, eventually we cannot say that it is just because of JavaScript or the JavaScript frameworks. There are a lot of reasons associated with it. It is altogether a separate discussion to have. But one thing that I can emphasize is that to have a bigger application or you have a smaller applications, that depends on the organization decision or the plans that they take on how they want to design their application. We at Red Hat had similar situation. That takes me to the next slide, the Red Hat story. We at Red Hat had a product called JBPM, which is a business automation product. At some point, it is a legacy one. At some point, we decided to enhance it by accommodating some of the latest tech stacks, and also we wanted to ship that particular product as a service with cloud technologies. At that point of time, we already had microservice running on the back end, but the front end was one huge chunk of monolithic application. We were in a situation to find a solution to break that. That's when we started exploring various architectures that were available. One thing I can closely give you more detailed context about the architecture here, starting with an evolutionary architecture, which evolves incrementally over a period of time based on the business needs or customers' feedback or end users, reports or something, again, the feedbacks. Then we have this microservices, which is there at the back end where collectively multiple services are combining together to perform specific tasks. Also, we have the buzzing word here, that is serverless, where we have backend as a service that include custom code runs as a function. And then we have micro frontends on the front-end world. I would like to quote I point a quote from the renowned software developer, who is Cam Jackson. He mentions an architectural style where independently deliverable front-end applications are composed into a greater whole. Now let's get into micro front-end. We'll get to know the context why I mean the quote there. What are micro front-ends? Okay, I'll just hold on here. I don't want to give you the definition of micro front-end. I'm sure that you would have already got this definition on a number of talks or the other conferences. So I don't want to bore you again with that definition. But still, if you want to know the definition, I would strongly recommend you to go through those talks so that you'll get an idea about it. But I would like to keep it simple, and I wanted to directly jump into the main motto or the objective of micro front-end. It is this. The main objective of micro front-end is decoupling. If you want to break a bigger chunk of monolithic application into smaller chunks, or to decouple a bigger application into smaller chunks, smaller applications, or consider as the main motto of micro front-end, there is a saying, don't put all your eggs in one basket, right? So it is obviously very difficult to manage, as shown in this picture. This applies to your technology as well. If you put everything on one particular chunk, then it will be definitely hard to maintain. You can always diversify your technology. Diversification is just not about the wealth or money that you have. You can always diversify your technology, and you can keep it simple. So far we have seen the objectives of micro front-end. I would also emphasize that micro front-ends is not just the only solution you have. As I mentioned in my previous slide, it purely depends on the organization, or the team decision. I'm sorry. Or the team's decision whether they really want to choose a micro front-end, or they want to go with another approach. So as an alternative, there are other approaches as well, which I'm going to mention in this slide. One is the first one, the monolith. Again, you can still go with monolithic-based applications, consider while you have a simpler application that performs one particular task or something. So then you can just go with monolithic application where you have just your front-end and your back-end, that they just communicate between them in order to perform a particular task. Also, in case if you want monolithic application and still you want to have some features of micro front-end, you can always go with modular monolith application, where the front-end chunk is broken down into smaller modules, which are not totally independent, but they are slightly coupled, loosely coupled between them. Also, it makes replacing of module will be made easy. You can, whenever if you want to change a module with another one, you can obviously do with modular-based monolithic application. And there is another one which is called as integrated application, where you can have various applications, smaller applications, which communicate between them on the build time composition. And finally, we have micro front-ends. Again, we have smaller pieces of code. Smaller pieces of micro front-end applications. They all communicate between them on the runtime composition. So micro front-end has its own advantages, which I can list so many, but the main things that I can point here is the scaling of an application or maintaining your code will be made easy. Each team can have, the application have autonomous teams. They can work on individually on their product, independently on their product, without depending on other teams for any particular task or something. They can have their own release cycles in order to deploy something. So it makes the work easier of our developers. So I just want to hold back here again, and we'll have to go back to the title, Build a Better Micro-Frontend Application that Offers Platform Freedom. And I would like to emphasize what I mean by the term platform here. As I mentioned, I'm working with a team where we build toolings for serverless workflow specifications and business automation products. So at the end of the day, these tools are used by the developers and the communities with whom we are working. So we wanted to target the tools or the platforms which developers and communities mostly use. Those could be, we all know that, some IDEs or Visual Studios. As a developer, we also have been using that. And we wanted to target VS Code. And we have the toolings, which are, again, web tools, built on web components, to be running on VS Code as an extension. And the same set of code has to be running on GitHub as an extension, and browser as an extension. It could be Chrome browser or a Firefox browser. And finally, we should also have web-based application, which is built on top of React. So we were targeting these platforms. Also, we were targeting other platforms as well, but these are the more focused targets that we had at the point. The reason, the motivation that we got, how we can deploy our make our components to be running on those weird platforms, is that because of the web technology. Web technology has a complete dominance over the software industry at this point. It is considered as the go-to choice for most of the people who wants to build an application for their use case. This is because web technology has stronger foundation, stronger standards, techniques, and patterns. It also has rich in ecosystem. After the introduction of JavaScript, the ecosystem has vastly grown after the introduction of, a lot of exciting frameworks. It enables it more, actually. And later, after the introduction of the TypeScript, people like me who started with a Java developer started liking web technology after the introduction of TypeScript, because I personally feel that my code is totally type safe while using TypeScript, right? So I would still say that introduction of TypeScript is considered as one of the path breaker on the web technology world. Also, I would like to emphasize, now you can see browser everywhere. You can see browser on the desktop, mobile, or tablets, or you can see on the server. Also, you can find browsers on the platforms that I mentioned. You can see it on VS Code extension or GitHub extension or the browser extensions. So this gave us the motivation that we can make our components to be running on those spaces so that it will be accessed by the developers easily. So these are some screenshots that we took. Our toolings are running on VS Code like this, GitHub and browser as an extension, and finally we have the React-based web app. The toolings that you see here are the BPM and DM tools that we use for the business automation products, and the other tool that we have is serverless workflow editor that we have, which is also based out of the tool that we build. One such example of this micro frontend approach that we wanted to come to get it. So here, this tool, maybe this picture, this screenshot looks simple. You may think why we went to micro frontend for simple UI, but our toolings are actually far more bigger than this. This screenshot is very small, but we have a lot of components, almost like 600, 700 components, and we have various modules as well. So just for example, this container application contains various micro frontends in it, and each micro frontends are maintained by an individual team, and they all work autonomously. So getting into the features of micro frontends. So one of the core patents that micro frontend offers is BFF. It is not abbreviated as best friend forever, but it is a best friend for both micro frontend and the microservice at the backend or the backend. So if you closely look at this diagram here, there's no communication happening between the micro frontends. All the communications are happening inside the container, and container takes a major decision here. So, and also, if you see, there is no communication from the frontend and to the backend microservice. It happens via BFF. So here BFF takes the decision, receives the request from the micro frontend and tweaks it in such a way that a microservice can handle it. Also, even whatever response that comes from the microservice is passed on to the micro frontend via BFF. Here again, BFF interrupts and then it just tweaks that response in such a way that a micro frontend can understand it. So it basically enables a seamless communication between the micro frontend and the microservice. So while implementing micro frontend, type of integration is considered as one of the most important thing we need to keep in mind because this strategy is more important. There are two types of integration that we can discuss here. That is, one is runtime integration, which is considered as a go-to choice for most of the teams who want to implement micro frontend. Let's see what it is. So let's consider the scenario. We have a team A and team B. In case if your team A builds a component C, they just deploy it. It is available in the URL where you have the URL name and slash and the particular component name.js. It is directly available there. If the other team wants to see that particular component, they just have to hit the URL. It is readily available there. Okay. So deploying is made easier with this runtime integration. It is very fast as well, but it has its own downside. The tooling and setup of this approach is quite complex. As I mentioned, there is another approach, which is build-time integration. Again, I'm taking the same scenario where we have team A and team B working on an application, where a team A builds a component C, they deploy it in NPM registry or any other registry they can. The other team who wants to use that particular component, they can just include that in their package JSON as a dependency so that they can directly use it. In case they have that already as a dependency, they can just bump the version to pull out the latest changes made or the latest code that has been pushed on the NPM registry. So in this way, they can, the deployment and all this, and since it is provided by NPM, the team A's work is easy here. But the other team, the team B, has to rebuild their entire application if they want to use the latest code provided by the team A. So again, the build time may be long, depends on the application again. Also, there are styling concerns associated with the micro frontends. Say, for example, if you have multiple micro frontends and you have written class names along with certain properties, CSS properties, there could be chances if there are class names, similar class names associated with other micro frontend, there could be chances that one property can overwrite on other one. So to avoid that, you can better go with CSS and JS. There are a lot of available frameworks. The major one is styled components. Then also you can use namespace for the CSS files. And also there is a traditional approach of using iframes. Most of the teams, they still go with iframes while working with micro frontends. They wrap their micro frontend application in a iframe and they just render it so that they can completely isolate their micro frontend from the outside world so that it does not affect on any other external, external requests. So how this is made? If you see closely, look at this code here. A script tag containing various routes here, and each route points to an micro frontend. Okay. So with this iframe, as I mentioned, it is not a new or fancy thing. It is age-old approach, kind of an egg, right? So it has its own pros and cons. The pro is mainly it could be it provides a complete isolation, but as a downside, it makes your application look a bit old. As I mentioned, and it is less flexible, and you cannot make any communication from the other micro frontends. So after thinking about all these features that micro frontends offers, we decided to go with a framework. We decided to overcome these complexities that we had. So we started thinking of a new architecture. Why we needed a new architecture? We had these requirements. We wanted to have our web tools running on various platforms that I mentioned, like VS Code as an extension, browser as an extension. Would be Chrome browser or Chrome extension or Firefox extension. And we also wanted that to be running on GitHub. And finally, we also wanted to have it in as a web app. So these were the distributions we were targeting. And also, we had to do that with very minimal code changes. And finally, we also wanted to create a bridge for the two future tech stacks as well. Yeah, before getting into that framework, I just wanted to show a quote from Ralph Jansen about software architecture. So architecture is about the important stuff, whatever that is. Architecture mainly focus on the important stuff of an application. That's what he's trying to say about with this quote. Let's get into multiplying architecture. So this is the framework that we built on top of micro front-end strategies in order to accomplish the requirements that we had and that I just showed in the previous slide. The main motto or the objective of multiplying architecture is to have abstraction. Okay. Let's see what I mean by abstraction. What sort of layer we have for abstraction here. So these are the core components of multiplying architecture, where we have channel, envelope, view, and editor. Starting with channel. So channel is here, the host environment or the platform where we wanted to run our tooling. Here, in our case, it could be VS Code or GitHub or the browsers. So these are considered as channel here. And on the extreme right, you see editor. So here in our use case, we had editor, so I just mentioned here editor. In case someone wants to try the multiplying architecture, they can just place your application here. It still works perfectly fine. And then there's a view which wraps this editor. This view is built on as a React component, so it just wraps the editor. And there is a layer between the channel and the view, which is envelope. It acts as an intermediate layer between the channel and the view and enables a communication between them. It completely abstracts one another. For instance, view or editor will not know on what channel it is running. It is totally abstracted by envelope. And also, channel will not know what sort of communication happening inside the editor. It just knows nothing. So whatever that is provided by the envelope, it just runs on the channel. So these are the few screenshots where we wanted our tooling to be running on the online channel like this. The outer layer is the channel. Again, inside we have the editor, and the envelope facilitates the communication between them. We wanted to have the tool to be run on desktop as a channel like this, GitHub extension like this. I'll be showing a quick demo about all these things in at the last. And we wanted to have the editor to be running on VS Code extension like this. So again, this slide, I can show you how the communication happens between the editor and the channel. If you closely look at this diagram, here no iframes are used. It is just div. The editor is just rendered as a web component. So still, we were able to achieve, or we were able to isolate the micro frontend without any external effects by the use of envelope. We'll see what are the advantages we get through envelopes, because we spoke a lot about envelope. It provides us the context isolation. We were able to isolate the micro frontends with the outside world. It enabled us to work on an autonomous team. We could able to have our own releases, our own pipeline, and finally, it provides us the type-safe communication. What I mean by the type-safe communication here, we all know that iframe provides, communicates with the outside world using post messages, right? So this post message is just a string. So we always don't want to have a string for any of the messages that we pass outside, right? So we wanted to have, we thought we must have some sort of type-safe communication to the outside world in the sense of the other micro frontends. This envelope offers that type-safe communication, with something we have called shared values that enables us to have type-safe communication. Let's see my multiplying architecture in practice. For which I have some of the toolings here. So I can share this repository. Maybe if you want to see how this looks, maybe if this tooling is boring to you, maybe you can just see this as a reference. But if you want to try that, I'll show you the code. I'll show you the code base at the last, where you can go and try yourself about this multiplying architecture, and you can build an application on top of it. So yeah, this BPMN tool, again, this represents the business process of, as I mentioned, since we are building toolings for business automation products. So this BPMN represents business process notation. So yeah, this editor that you see here is built with this multiplying architecture. We were just able to accommodate this editor here on the VS Code with a very minimal set of code changes. Of course, we had to write codes to build this extension, VS Code extensions, but the core component of this editor are just reused. Let's see how this looks on the browser extension. So for which I have Chrome Market Store. I can go here and can search for BPMN. Yeah, it gives me the editor here. I already have installed here, so it works with me. And if I go bpmn.new, it opens me this editor. If you see here, this editor is same as what you see on the VS Code extension. I can upload some file here. Maybe I'll upload the same file. See, so it is the same editor is used both on two different platforms. We'll see another editor that we built, which is serverless workflow. So this editor, again, it is built on multiplying architecture. So on the left, it shows the serverless workflow specifications. Whatever it is shown on the left, it is like edited by the editor here and provides a diagrammatical representation of that particular workflow. So these editors are built on top of multiplying architecture. How this multiplying architecture works. So in case if you want to try that, I'll pass you this URL. Maybe I'll just have a slide at the last where you can note that. And we have a separate folder called examples that provides you some classic examples of ping pong or to-do list. These examples are built on top of micro frontend. These are separate channels, and you can run the same ping pong applications on VS Code or on browser or GitHub everywhere. The same approach is followed here as well. We have an web app, which is the container application or the channel the container application, which contains all this individual micro frontends, and maybe you can just run this application to see how it individually works. So getting back to the slide here. So even after having the multiplying architecture in place, we had the final .to connect. We still had the problem with choosing the integration strategy. As I mentioned, it is one of the most important choice that we have to make. So if you closely look at this drawbacks that I mentioned here with the build time issues and the runtime issues, one common thing will be the duplication of library loading. Right? What I mean by the term library loading here. So if you have, closely look at this diagram. If you have multiple micro frontends, say for example, micro frontend A and B and C has React as a dependency to it, 3 different instances of React is created here. If all these things goes to a container, the entire application would be huge in size. Just for one, dependency it's fine, but if you just imagine if you have a lot of dependencies that are replicating across multiple micro frontends, and if you have n number of micro frontends, definitely it is going to affect your application a lot, right? So eventually I also don't have to do this. You can just share the dependency. How we can do that? Federated module came to our rescue. Maybe you might have heard about this federated modules. It is introduced with Webpack 5. It gave us a solution to implement runtime integration in our multiplying architecture. How did it work? So yeah, this is our Webpack configuration. We are just like module federation is just imported, and then at the line number 18, you have remotes, which specifies various routes. Each route is assigned to particular micro frontend. So when this particular route is called, and the corresponding micro frontend will be loaded. And if you see the line number 23, the dependencies are shared with the property called shared. So these dependencies are shared. I mean, the certain dependencies which we point here will be shared across these 3 micro frontends that we have. Also, by using the lazy loading concept that we have in React, you can do lazy imports, and you can just, with the routes, you can just, render those micro frontends whenever it is needed or when that particular URL is hit. Finally, with all this multiplying architecture and federated modules, we were able to achieve our goal of multiple distributions with the minimal code changes, and we also were able to create bridge to the future tech stacks. So these are the points that we were able to achieve. We finally able to implement micro frontend strategy using multiplying architecture, and we also took the advantage of runtime integration via federated modules. And we also created autonomous teams, and there was no duplication of library loading and so on. As I mentioned, so the code is available at this repository, which is an open source one. Anybody can have a look at it if you want to try this. Definitely, I would recommend it. It's worth giving a try. If you want to snap a pic, I'll just wait for a minute. Cool. So yeah, that's about my talk. Thanks. In case if you have any questions, I'm available, so you can reach me with any questions that you have. Thanks.
Thank you. Oh, that was an amazing talk. I personally learned a lot about micro frontends. So let's give him a huge round of applause.
I'm happy to see the audience back in the
Track 2. I think our FOMO that we did a huge cheer that helped.
Can I please get my mic back?
Yeah, please turn on her mic's wall. It's not on, I guess. I can help you. There you go.
Hello, check. Yes.
Great. So, how many engineering managers do we have in-house today? Here. Raise of hands, engineering managers.
Even leads, managers, leads.
Team leads, managers who have people reporting to them. Can we have one of you or two of you as volunteers on the stage, please?
Nobody's going to ask you to live code, don't worry. We just wanted to make this space a bit more open and have a small rant session if you want to. So we want one engineering manager or lead to come up on stage, and we want one developer or anyone who's had a good experience or a bad
Thank you
experience.
so much for volunteering to come. So I'll ask you to be on the podium and tell us where you work currently. Oh, you could have given your mic.
Yeah, I can give you
Yeah,
mic.
you can use her mic.
And it's fine if you don't tell where you work.
Oh. Yeah, it's no longer a secret.
So this is Soumya here. So I work as a senior principal manager at Rocketium. So one of my teammates said, like, we don't build rockets, but we are a rocket company.
Ooh, okay. Now, is there any frustrated engineer in the house who wants to rant about their manager? Anyone, who has some complaints and wants to take it out? Keeping in mind that you have to follow the code of conduct and not say anything inappropriate. Anyone who would want to volunteer? Why would anyone? Oh, that's a good question. Why would anyone on a public stage, rant about their manager?
So you're fine. You can not take names. You can just give a basic rant if you want. Or else we can start with our next talk.
Or we can ask him, like, what is it that you think that your team members do that they could have done better? Something that annoys you about it.
I've heard a rant called, like, there are too many meetings. Like,
That's the story in every company, who all agree that there are a lot of meetings every day and it takes productivity away. Can you give us a cheer who all agree to this point? So I think we have a unison here. So I think thank you so much, sir. We do not have any ranting engineers in-house today.
Yeah, I'm seeing the audience is very, very politically correct. They do not want to anger anyone in the current market. So that's really good. Cool. We have our next speaker then. Oh.
My phone got locked.
Yes. So before we go to the next talk, as we first talked about, if there's any ranting, we try to ask your folks to rant about what you don't like. But talking about the good things, is there anything that you want to share in terms of how you started your journey into the whole world of tech, engineering, development? If there's a story, there's one of the speakers who's going to come up, and his story is something that I really, really enjoy.
I think we can start with the introduction
Yes.
in that case.
Yes.
And in the next set of fillers, we can do it.
Just give me a minute. Yes. Next, we have Amir Jan with us, who will be talking about building large-scale stateful JS applications. So let's give him a round of applause.
The stage is yours.
Hey, hello everyone. I hope, is the mic working?
Okay.
The mic working? I guess it's working,
It's working. I just have one quick announcement. So someone here has lost their phone. So if it is yours, yeah. All right.
Hey, hello everyone. How are you folks? I see a lot of dull faces. So you know what I'm going to do? Let's do some sit-ups. Yeah, let's stand up.
Sit-ups?
Yeah, let's do some sit-ups. Come on folks. Yeah, let's stand up. Yeah, please. No, I was just joking. You can sit down. You can relax. Okay. I think the thought process of doing a sit-up already brightened you up. So I think so. If not, we'll do sit-ups. Okay. So if I feel anywhere I'm losing you, we'll do sit-ups. Deal? So stay with me for the talk. Sure. So with this, I guess you would be a little more curious to know me. So this is Amir, and I lead the IDE team. Okay. Okay, good. So this is Amir. I lead the IDE team at HackerRank. So all the IDEs that you see in our platform is mostly managed by us. And if you see anything going wrong, hit me. Okay. So yeah, when I'm bored with IDEs, I really love building small tools that bring a lot of developer productivity. When I'm bored with building those small tools, I play a lot of Valorant. I mean, by that I mean a lot in the Mumbai server. So any Valorant fans in the home? Anyone play Valorant? Oh, nice. Anyone play the agent Gecko? Nice. So yeah, you will be able to relate a little bit more to the talk. So yeah, so I am a full-time cat dad. You know how tough that is. So people often ask me, I mean, how do you deal with people, right? My answer is simple. I have a cat. He teaches me a lot. You can deal with the people by just ignoring them all day with no reasons, right? So get a cat. You'll get to learn a lot of people skills. And this is from experience, okay? To brighten you up more, this is my cat, Amlu. Look at him, how cute he is. 30 seconds, I'm going to leave this on the screen so that you all get soak that energy. Look, he's looking at you and asking, are you up for the talk? Yes. Are you up? Yes. Oh, nice. Look, he's very curious about, you know, what you're going to think about it, but yeah. Bonus, this is small Amlu. He just became a dad, you know. He's like 1 week old. Yeah, another 20 seconds, I'm going to leave it for you to get pumped up for the talk. Yeah, I'm going to create one after this, okay? He was supposed to be my +1 for the conference, but his dad didn't allow it like every other dad. He wants to do more parenting, so I left him at home. Yeah, with that said, today I'm here to share a bit about how we can build scalable JS applications, right? By this, I want to leave you folks with a set of thoughts that may feel like we are rethinking some best practices, right? That's why there's a question mark. Some may think this is the right way to do. Some may think this is not the best practice, so it's up to you folks to decide. Most of this is a set of reflection from my learnings of working on IDs at HackerRank. So yeah, I want to start with a question that think about this. What is the most complex front-end application that you would have ever used or created, right? Everyone have their own opinions, so think about it, right? For a good few seconds, think about it, get something on your mind. And if you ask me, like at least for the past year, my answer has been VS Code, right? We never address VS Code as a web application, right? We address VS Code as a desktop application. Do you folks agree? You folks all use VS Code, I guess? Yeah. Anyone use JetBrains? There is the door. Just joking, okay? Just joking. But think about it. VS Code is a web application running inside Electron, and it's running as a desktop application. Do you think its performance is like just absolutely amazing, right? Even JetBrains couldn't catch up. It's a native application, right? So VS Code is so performant. So my opinion has always been for the past year that it's one of the most complex front-end application that has been ever built, right? At least it's very JavaScript heavy. You may say, okay, Amir, like, what's so special about it, right? It's just another front-end application. When we had a look at its source code, we maintained a fork of VS Code at HackerRank. There were some surprises, right? First of all, they don't use React. For that sake, they don't use any UI library itself. They don't use Vue, they don't use Svelte, nothing. They have their own hand-rolled JavaScript UI library. For most part, it's imperative, right? Our mindset for the past decade has been declarative UI is the best way to write it. Can you imagine how complex VS Code is, and their entire UI is imperative? They are not using declarative, right? And we think using declarative is the best practice. And the code that they have written is very scalable, maintainable, and it still grows, right? Every month we get updates for VS Code. Second, there is no traditional REST endpoints in VS Code. I guess most of you would have used code sandbox projects or code spaces from GitHub, right? In which you get VS Code in the browser, and you're connected to a remote VM or a container, and you're doing your work from the browser, but it's saved on the VM, right? So in that case, the VS Code in your browser is the front end, and the back end is the remote container, right? So how does the back end and front end communication happen, right? It should be very complex, because VS Code in itself is very complex. Lot of interaction, it's very, very reactive, right? How does that happen, right? And they don't use traditional REST endpoints. That was very surprising. And they make heavy use of dependency injection. So you might know that there is a version of VS Code that runs entirely in the browser, which is vscode.dev. There's a version of VS Code that I was talking about runs in code spaces where you connect to a remote machine and you do your work from the browser. There's a version of VS Code that runs in your local machine, right? There are so many versions of it, right? Using dependency injection, they have made it to adapt to different environments without much code changes. It's the same code base that can run in multiple environments using dependency injection. And I've not seen many of our front ends using dependency injections, right? And it has desktop class layout, right? It has a very, very excellent layout engine, right? It has so many complex views. You can dock views, undock views, make them work with each other, right? So many great stuff. But we don't reuse any of the layout engine. We built hand-roll all our layout engine, right? Nothing comes close to the layout engine of VS Code has. Even there are so many great things about VS Code that I can talk for an hour in the talk, but since there is 23 minutes left, I want to specifically talk about one thing, which is front-end to back-end communication that happens in VS Code. By this, we're going to talk about the second point, which is there is no traditional REST endpoints in VS Code. How does it do front-end to back-end communication, right? Rather than me taking you through a slide, let's take a demo app, right? And let's walk us through it. Let's take an app that is built on a traditional approach, and then let's rebuild it how VS Code would do it, right? So can you all pray for the demo god? It's gonna be demo after this. So hopefully pray that the demo doesn't break, okay? I hope the code is legible. Let me know if you want me to zoom further, right? So it's a simple and sober app. Nothing much going here. We have a backend folder, we have a front-end folder, okay? The front-end is a V tab, which has just single file, okay? What the file is trying to do, it's trying to hit an endpoint, which is in 8000 port, and it's hitting the endpoint read file, right? And it's getting back the file content, and I'm displaying the file content in the div tag, which I have in the index.html, which also imports the index.ts file, right? And I have a backend folder, which is a very basic Express server, which has an endpoint which we just saw, read file. And what it's doing, it's using the FS module of Node, and it's reading the file and just returning back the file content, right? And it's reading sample.txt, which is just a bunch of lorem ipsum that I put together, right? So let's see the output, right? So let me start the server. Okay, cool. As simple as that. We got the file content and we are seeing it in the front end, right? If you just look at it, there are a bunch of issues with it. First of all, in the front end, I have no idea what the backend is returning, right? If I look at what's the file content, it's just any. I have no idea what is the response format from my backend, right? And it can change any day. For example, my backend developer goes things like, I'm going to screw my front-end developer's life today. Screw him, I'm going to change it to content. No more file content. This is how I like it, right? He goes to sleep, and you get called that your application is broken, right? What can you do? Now you have to debug and figure out, like, it was backend developer, let's screw him again, right? So that happens all the time, right? It happened to me a lot of times, right? Let's just say you want to, let's just say imagine this is an ID, right? Now I want to implement a new functionality. Let's just say I want to implement delete file, right? Now I have to go ahead, create a new endpoint, say delete, then change this to unlink, do a whole bunch of stuff. Now make another API hit from the front end whenever I want to delete the file, right? It just easily gets unmaintainable, right? What if there is a better way to do it? What's a different way to do it, right? So let's have a look at it, right? This is the traditional way of doing it, and it works, and it has been working for decades for us. So I did little cheating, so don't care about it. I did a bunch of restructuring here to save your time. The backend folder is gone because no one wants to do or write API endpoints. Okay, the backend folder is gone. I just deleted it. In the front-end folder, there is a new file here called fs.server.ts. Okay, and in the fs.server.ts file, I have a read file, which is using the Node fs package, fs built-in module to read any file based on the file path that you are giving to the function, and it's returning the file content, right? As simple as that, and I'm exporting the read file. Okay, and there's an index.ts file, which is our front-end entry point, and it's directly importing that fs from the fs server and calling fs.read file. I'm getting full type intelligence here that there is a function called read file. It takes string and it returns a file content. I'm just showing it the front end. How many of you think that this would work? How many of you think this is legal? Okay. I guess you already have a fair sense of idea why this is illegal, right? But what if this is possible, right? Why is it not possible? This has a lot of benefits. Let's just say tomorrow my backend developer decides, let's screw my front-end developer. I'm going to remove the argument. No more argument for read file. I give you a random file whenever you read it, right? That's not possible. My front-end breaks. I can say, what did you do? My front-end build is breaking, right? That would be great. But it doesn't happen today, right? Too good to be true. But still, let's try it. Nothing wrong in trying, right? So let's just try it. Doesn't work. Let's see, have a look at the console log. I hope the console log is legible to you. It says that it cannot bundle fs/promises because that is not compatible, right? That was not a surprise for us. You cannot use Node built-in modules, or you cannot use a database connection. Nothing you can use it because browser doesn't support it. Either you polyfill the fs module, or you either don't use it, right? Okay, so we know that doesn't work. What if we can make it work, right? What if we can do some form of black magic, right, and make this work? Let's explore that black magic. To make that black magic work, I have a aptly named folder called magic. So let's explore some magic in it. So there are two files in it. The first magic that we'll be looking at is a Vite plugin. For now, I'm just calling it Gecko plugin. The folks who are playing Valorant will get the reference, but yeah, if not, you should play Valorant, okay? We are calling it as Vite Gecko plugin. So don't get scared that we are trying to write some plugin for Vite, or this can be done as a Webpack plugin also. It's a very simple plugin, okay? So Vite plugin is a piece of code that you can give Vite, which is our bundler, to tell it to do things differently. Right now, Vite is being a little stupid. He's trying to bundle our backend code also with frontend, which obviously doesn't work. Right? I need to tell him that this is how you need to do. For that, I'm creating a Vite plugin. A Vite plugin is a function that returns an object. Right? The object is the plugin that we want to build. And the object has a bunch of property. The first property name, as it says, it's the name of the plugin, which is Vite Gecko plugin. Then the second property called enforce tells Vite when to run this plugin. Right? Pre means it needs to run this plugin before it does pre-bundling. Right? Without that, this doesn't work. So there are a bunch of options. I'm not going to explore those options, but enforce does tell Vite when to run this plugin. Right? And then you can provide a bunch of functions, which we call it as hooks in Vite. What this hooks does is it tells Vite, whenever you're doing a certain operation, let me know. I will provide you with more information, or I will tell you to do things differently. This resolve ID hook is called whenever Vite is trying to resolve a file path that you're importing. Let's just say you imported fs.server.ts, right? It needs to be resolved into an absolute path, which would look like frontend/fs/server.ts. We know that if it tries to bundle that file, it's not going to work because it's a backend file, right? What I'm going to tell Vite is, okay, if you find any file which has server in its file name, don't bundle it. Rather, I'm going to provide you a stub. Use this stub called backendproxy.ts, which is the second magic which we have in our magic folder, backendproxy.ts. Okay, so quickly summarizing, we are building a Vite plugin which is telling Vite, don't bundle any file with server in its file name. Just use this stub that I'm providing, which is backend proxy. Make sense? Now we have a backendproxy.ts, and it's also not that complicated. We're just creating a new JavaScript proxy. JavaScript proxy is nothing but a special object that provides you trapdoor so that you can know whenever a property was accessed on that proxy object, right? For example, if I create a new proxy object, let's just say fs that I'm importing, right? If I do fs.read file, I will get to know that the read file was accessed on that particular proxy object, right? To create a new proxy, you just say new proxy, provide the object on which you want to place the trapdoor. For now, I don't have any specific object in mind, so I'm just giving an empty object. And then you provide the trapdoor, which would be called whenever a property is accessed on this proxy object. And this trapdoor has a bunch of functions that you can define. The function that we are interested in is the get function, right? The get function is called whenever a property is accessed on the proxy, and it gives you a set of arguments like property. What was the property that was accessed on the proxy object, right? Now what is happening is when you are importing fs.server, we are telling Vite, don't bundle the server file, rather bundle this proxy, right? Now fs is actually not your backend file, but it is rather a proxy. When you do fs.read file, in the proxy, you are accessing that read file property, so this get function would be called, and we will be getting this property, which is read file, right? So when you import fs.server, fs becomes the proxy, and when you do .read file on proxy, we will have this get function executed, which will tell us, okay, the property read file was accessed in the proxy object, right? For all the property accessed, I'm going to always return a function, which is going to take a set of arguments, and then I'm going to just for now just console log it, right? Console log accessing property from proxy with a set of argument, right? So summarizing it, we are just, rather than bundling the server file, we are saying that I'm going to give you a default proxy. Using the proxy, I'm going to get information on what was the function that you were trying to call on the backend, and what were the parameters that we were trying to pass to the backend, right? So let's try it out if it works. I'm going to go to my front end, go to the Vite config, and import this plugin. Okay, let's go back and see if it worked. Okay, the old error is gone, but we do get our console log, right? You see in our console that Vite is no more trying to bundle the backend file. Rather, it is telling me that you are trying to access the read file property on the proxy with these set of parameters. We have another error which we'll fix soon, but now we have this information on the front end that what was the backend file you were trying to import, and what was the property that you were accessing on the backend file, and what were the parameters that you were trying to pass, right? With this, I think we can achieve what we wanted to do, right? What if I can make a fetch call with this information to the backend and execute the function actually in the backend, right? Let's explore that. That is possible, right? So for that, again, to avoid too much typing, I'm going to do a little bit more cheating. I have created a scaffolded express server, which has a single endpoint, right? I'm going to call this endpoint gecko, okay? Does this bring back any memory of GraphQL? So similar to GraphQL, we're going to have only one endpoint in our server, which is going to be called gecko, okay? Now in the backend proxy, I'm going to just hit the backend with the information that I have, right? I'm going to make a fetch call to So I'm going to always use the post method, just like GraphQL, and I'm going to say headers, content type is application/JSON. I'm going to send the body, which is going to, I need to JSON stringify the body, and the body I'm going to set information about what was the function name that was being called, which is property, and what was the function params that were passed to my front end, right? I'm going to say it's going to be params, right? Let me get back the response from my fetch call and then get back the result. I'm going to assume that in the JSON response I'm getting, the result is where the result of the function is going to be, right? And I'm going to just return the result. Okay, now I'm making a front-end call, which is an API call to my backend. Now let's handle the API call in my server again, right? So I'm going to be hitting gecko. So I'm going to get back the parameters that was passed in the request.body. What are the parameters that we passed? It is nothing but function name and function params. Now it is super easy for me. I can just require my backend file, which is in frontend fserver.ts, get the default export from it, get the function that I'm trying to call, and call it with the function params I just got, right? I need to just await it so that since it's an async function, and I'm going to get back the result. And I'm going to just say response.json, the result. Just let's quickly check what we did. In the backend proxy, with the information that we just got from the front end that the user was trying to call a function on the backend, which is read file with a set of parameters. I'm making a fetch request to the backend with the function name is this and the parameters are this. And we created a simple express server with a single endpoint, which is gecko. And I'm getting this information from the front end, and I'm just executing the function in the backend, right? I'm hard coding this server file here, but this information can also be passed from the front end, and I can execute this function in the backend itself, right? In theory, this should work, so let's check if it worked. But before that, I have to restart my server because we did a bunch of stuff which needs a restart. So let's check. Pray the demo god, and it worked. And it worked. In theory, you imported a function from backend, just like a file import, and you call that function. That's it, you're done. You didn't create any API endpoints. Backend developer cannot screw you, right? And tomorrow, let's just say I want to have a new function, right? Let's just say I want to say async log info, and it's going to take a message, which is string. You know, it's tough typing in the stage. Function, yeah. And I'm going to console log the message, and I need to not forget to export it, right? Just say log info hello from Jsconf, not config, yeah. So, quick question. Where do you think this console log would come up? Guesses? Yeah. But just, you broke my surprise, but let's still open up the console and reload. There's no console log in the browser. We have the console log in the backend, which actually means you're executing your functions in the backend, but you're calling them as if they existed in the same file or the same project from the front end, right? I hope that clears things up. I guess it is time now. I need to give this magic some name. I can't call it black magic forever. So let's rename it the folder to the rightful name RPC. So what we did is nothing but a poor man's version of remote procedure call. Okay? So there's a procedure in a remote machine, and you're trying to call that procedure from another remote machine, which is your browser, and both of them feel like the function that you're trying to call feels like it is in the same machine or in the same browser, but it is not. It is in a remote machine, but you have strong contracts because your contract here is not an API endpoint. Your contract here is a function. Functions have very strong contracts, and with the ID intelligence and type checking, we can ensure that your backend developer can never screw you, right? So, cool. So, okay, do you think this is new? I would say it's not new. It's not novel. For example, Java RPC has been there before I born, right? I just checked in the internet. There is something called Java RPC. It's no more supported, but this concept of remote procedure call has been existing for a very long time, right? And there is gRPC, which I know that if there are some backend developers here, they might be thinking, yeah, ye to chura liya. He has stolen this from the backend. We already use gRPC. We already use protobuf. And if you ask any backend developer how do they communicate between two services in backend, they use gRPC. They don't use HTTP. Because gRPC provides them strong contracts. It's a very similar concept. You use functions as contracts, and you don't use endpoints as contracts, right? I guess most of you would be aware of Bling, Stanstack Bling. It kind of works on the similar concept. They just say there's an RPC magic inside it. It's not really a magic. It's as simple as this. Behind the scene, this is what it is doing, right? And I guess you folks would be aware of this Next.js action that came in, right? You just give an action in the front end, but it feels like it exists in the front end, but it's being called in the server, right? Behind the scene, React server component actions in Next 13, I guess, also uses RPC behind the scenes, right? And then Quick was the first one who tried to introduce this into the front end. And I was planning the talk around the same time, and like Quick already, broke the silence on the RPCs, right? So there's more. I would say that this is not just limited to your day-to-day API endpoints. You can use this in many other places, right? I guess there was a previous speaker who was talking about we want to ensure type-safe communication between micro frontends. We can use RPCs for it, right? And micro frontend to micro frontend communication is nothing but an iframe communication, right? Or it could be a communication from one web worker to another web worker, right? It could be an inter-process communication. So in VS Code, whenever you're running an extension, right, the extension is run as a separate node process so that it doesn't hamper the performance of VS Code, right? When you create a child process, you need some form of communication between them, and that communication should be in a type-safe way. Otherwise, it cannot be maintained or scaled over a long period of time. And VS Code uses the same RPC for those communications, right? To term it right, this RPC is called JSON RPC because you are serializing your method calls into JSON, sending over to another process and executing in that and sending back the result, right? And you can also use this for WebSocket communications, right? I know we have a lot of WebSocket communications where we put arbitrary messages saying that connected, message sent, message received. Those can get very, very, very fast, right? You can put this RPC into WebSocket communications, and using little bit more plumbing work, you can have something like you're just calling a method on the WebSocket channel and you're getting response in real time, right? So I want to leave you folks with a thought that, Next.js revolutionized this idea of, routes as file system. Why can't REST be based on file system, right? Why can't I just go today, create another file called, process.server.ts, and I'm just importing it, right? Here, the file system can always allow unique file names, and the functions names can be always unique. So why should we keep on creating unique API endpoints, right? When we know that, it is not fun to do, right? Why can't the file system be your API endpoints, right? That's what I want you to think about, challenging the best practices today. And that's it. Thank you, folks.
That was an amazing talk. And we all, I think, love your cat a lot now.
Yeah, we are waiting for Amlu's fan account.
So can we have a huge round of applause for him? He had a wonderful talk. And let me also tell you a fun fact about him. So he told me that he once had a fist fight with someone who said that something can't be built with JavaScript. So if you're someone who is anti-JavaScript, steer clear of him.
Yeah, you know whom to stay away from. That is how I think the code of conduct was built.
Right, right. So we have a bunch of talks here as well, but I see that a lot of people are standing. So I do see a lot of empty seats in the front this side. So if you want to grab a seat, feel free to come this side in the front. And we have a bunch of exciting talks coming up. But before that, we'll take a quick music break. So I'll ask the audio team to play some music, and then we'll get started with the next talk.
What are we playing? What's your favorite song?
I think I would like to hear Pasuri.
Oh, how many of you like Pasuri here?
I think it was kind of an era at that time.
Yeah, definitely.
Just playing everywhere.
Can we have some music? Our next speaker will be just setting up his setup till then. a quick fun fact about our next speaker. So our next speaker is also known as the Undertaker of tech. I hope I've said it right. I'm not a big fan of whatever that sport is.
Who all were also at React India? A raise of hand. Who all were there at React India? So I hope you all remember the guy who had the Undertaker entry. So that's him, that's Parth, and he's gonna be our next speaker. And there's one more fun fact about him. He's the youngest engineering manager at 1MG. So if you have any questions regarding engineering manager roles, you know who is the guy to contact here.
Let's call Parth. So yeah, our next speaker is Parth, and we'll let Parth also give an introduction to him, and he wants to have a quick chat with everyone. So we're going to give the stage to Parth.
And I'll just give a quick introduction of him. As I already told you all, he's the youngest engineering manager at 1MG. And his talk is going to be around vaccinate against third-party performance impact using PartyTown. So I'm also quite excited for his talk.
And Parth, please tell us a little bit about your experience as
Please
the
join
youngest
us on the stage.
manager.
Let's give him a huge round of applause, everyone.
So what do you guys want to know? First of all, hi everyone. How is everyone doing? Awesome. Let the seats fill in. Meanwhile, if you guys have any questions, please go ahead, shoot. Anything, any queries for, engineering manager, any ranting to be done? Anything? Achha, tell me a quick thing that how many among you have, this query wherein some engineering manager or anyone from the leadership is approaching you and telling you that, your web performance is not good. Try to improve that. If you really want to, let's say, go ahead and really want to prove yourself, you have to, improve your web performance. Anyone, can I see some hands, please? Anyone interested in improving the web performance? I can see some hands now. Now, what if I tell you that you could improve your web performance by maybe 15%? Probably 30%. If you are interested, please raise your hands. I can see some hands in 30%. And what if I tell you that not just 30%, you can double your web performance? Or even more. Are you guys interested for that? Can I hear some noise? Awesome, awesome, awesome. Great. So meanwhile we are setting up, I'll just give you a brief context that how we reached here. So it's a quick story that we at Tata 1MG are really obsessed with the web performance, right? Be it serving to the end users and providing the best experience in the healthcare, or let's say, be it providing the best user experience. And that is when we encounter this problem, a very intriguing problem, that no matter how much we optimize our web performance, still we can't hit that perfect 100 score. Why is that? Any guesses? Anyone who might have faced a similar issue? You do everything right, you do code splitting, you optimize your JavaScript code, you do everything. You do server-side rendering, HTTP multiplexing, so on and so forth. But still you get a very laggy performance. Intrigued? So that's what we are going to cover today. So hi everyone, as you already know, I am Parth Mahajan, engineering manager at Tata 1MG, and I majorly work at the performance and improving the performance. So today, we are going to talk about vaccinating web performance and create a vaccination against third-party requests. Do you guys use, let's say, anything like Google Analytics? Probably Facebook Pixel, Criteo, Google Tag Manager, all these things. Now, all these scripts and SDKs are generally used by your analytics team and the marketing team, and they just show up and come up and they say that, maybe just this is a new SDK and you have to integrate. Maybe this is a new SDK for your payments. This is a new SDK for, tracking something else. What impact does it have on your web performance? Let's have a look at it. But do you think that JavaScript can be dangerous? Yes, probably. And what about uncontrolled third-party scripts? If your JavaScript is something you cannot control personally, your JavaScript is controlled by any third-party company, be it Facebook, Google, or any other different company, can you actually trust that? So before getting into different sort of scripts, let's understand what exactly is third-party scripts. Are third-party scripts equivalent to cross-origin? A lot of people might think like that, but that's not always the case. So for example, over here we have different assets, for example, different sort of images, JavaScript, CSS files that will be coming onto my web page, right, from a different subdomain. So that isn't considered a third party, even though that's a cross domain. But at the same time, you can have analytics, Facebook, AdRoll, Criteo, so on and so forth. So that is exactly what we are looking for. So this is something that we do at 1MG. We have 4.5 billion plus weekly requests to handle. At that scale, we cannot expect to have a sluggish performance for the end user. Each and every second, each and every millisecond matters. We have diagnostics, we have pharmacy, we have e-consults, and we have a variety of tech challenges to be solved on the performance level, and we cannot just go wrong. So this is where the problem really arises, wherein the third party starts to invade. And this is not something which is being faced by just us. We observed that this particular issue is being faced by each and every company in the ecosystem. And why this is problematic? Reason being, it can block your main thread completely and basically interrupt in between the processing of your main JavaScript, which you do not want. Let's suppose that you ship an e-commerce page and you want to add any product to your cart, right? And you are not able to do that. The moment you do that, the screen is frozen. Why? Because analytics want to track whether you have come on that page or not. And again, due to this, there are so many different network requests. And also it is very resource intensive in terms of parsing and execution. And very likely you would see that when these resources gets downloaded, the caching time on the browser is, let's say, 7 minutes, 5 minutes, 10 minutes. That's not ideal. I don't want to cache my third-party resources, which would change, let's say, after a quarter or so, in, let's say, 5 to 7 minutes. I don't want that, right? So, the question of the hour, is there a vaccination yet? So meet PartyTown. PartyTown acts as a vaccination against third-party scripts, wherein this is a library by builder.io. It helps you to run your third-party scripts on a parallel thread, right? It could be a worker thread. But if this were so simple, why we were not doing it so far? What exactly is the issue? Can we run each and everything on a parallel thread, on a worker thread that we are doing on, let's say, the main thread? So the issue arises when you start, let's say, exploring or basically accessing any native web library. For example, you want to access window, you want to access the window size, you want to access whether the click has been done or not. Anything like that cannot be accessed by the worker thread directly. You do not have direct access on that. And also, as we all know, that JavaScript is a single-threaded language, right? And by default, everything in JavaScript runs asynchronously, right? So the kind of, let's say we do fetch requests, they are asynchronous. We do promises, those are asynchronous. Then how do we make synchronous calls from the worker thread to the main thread? And if we don't do that, so imagine what could happen, right? You are clicking on a button, you are clicking on, let's say, add to cart button, and you go to the next page, and let's say it is an async task and gets executed after just a second, and that event gets tracked on the wrong page. You could lose the complete context. So you want it synchronous. So how does this work? So as we have already seen that with PartyTown, you have everything running on your main thread. Each and every resource is competing for a single thread. And with PartyTown, we have the complete bifurcation between the main thread and the worker. So let's code. And before we get on to the coding, let's do a simple thing. So here is 1mg loading on local, right? As you can see that everything loads perfectly, but the moment I add any blocking script, it could be any third-party script, any analytics script, right? And this is something that we are doing without PartyTown. And you'll see what kind of effect it has on a real-world application. Now, the moment I reload this page, you'll see what exactly happened. Nothing gets clicked, nothing is loading because the main thread is getting competed by that third-party script. This is something which we want to mitigate. Now let's get on to the code and try to understand how exactly it is done. So it's relatively simple. So let's say that you have installed PartyTown as a package. All you have to do next is add a script. And the type of that script, so let's assume that you wanted to run Google Analytics in PartyTown, right? So what would you do? You would just add an additional attribute that would be type, and text would be, the type would be text PartyTown. That's it. And the code would be running in a parallel worker thread, right? So behind the scenes, what PartyTown does is, it's run a query selector. It sees that, wherever I'm getting this particular data attribute, I'll execute all those, code snippets in a worker thread. Also, at the same time, imagine, let's say you do not know, at the build time what exactly, what kind of scripts do you want, and you need certain scripts on the runtime. For example, let's assume that when the user goes to a certain page, a YouTube scripts come in, right? And you want to, on the runtime, dynamically append these scripts and want them to be executed in a worker. That can also be done. So simply what you have to do is, you have to dispatch one custom event that would be put update, and basically fire your dynamically appended JavaScript into that, using that. So this way, PartyTown would know that, this JavaScript, this piece of code is also needed to be run in a parallel thread. Now this is how the communication works. So from the main thread, there is a post message to a service worker that gets installed on your domain for the party town. And from the service worker, we do a synchronous XHR request. So the people who might have been working in web for a very long time would remember this, that earlier browser used to have this XHR request, and this used to be synchronous. But for the main thread, browsers have disabled it now, but it is still available on the service worker and different workers. So what we are essentially doing is, from the service worker, we are telling to the web worker that, stop your execution and make this code execution synchronous, right? And then web workers does its execution, and then again post message is sent back to the main thread. So let's see this in action. Imagine that this is the code which you wanted to be run on the worker. So it identifies that window.location.href is a line for which I'll need to access the worker thread, right? Because I do not have access to window. So I'll create a proxy. I'll say that let me proxy the main thread, and it will create something like this. And even in the live code, you will be able to see that there are multiple requests, network requests, which go as /proxy town. Now the main thread again sends a post message, and from there, the values are generated on the main thread and sent back to the service worker. And this is how exactly all these things tie up in the end. Most of the execution happens on the worker thread. Just the communication bit and the data sharing from the main thread and the context sharing from the main thread happens on the service worker and the main thread. That's it. And let's just see the behavior after we do the party town implementation. So all we are doing is we are just adding a custom data type. Now this is with party town. We are just gonna reload our page. And everything works, everything is loading. We can interact, we can go on the next page. And that script is running in the background in our worker thread. Now, how do we run this in production? Now, the issue with party town is party town right now is in beta, right? And it is generally recommended not to use party town in production due to certain use cases. So what we have done is we have created a wrapper, our custom library on top of party town, and which is completely safe, and we have tested all the use cases, and we are serving currently so many different users using this custom library. So this is how it works. You install the party town, and you see whether the browser version is supported or not, because the advanced service worker communication or the atomics and shared array buffer communication that is done by party town is not supported in all the browsers. I'll be getting into atomics and shared array buffer in a while. So if let's say the browser version is not supported, I'll create a fallback, and that fallback will be solely responsible for loading all the scripts as it were if they were not loaded with party town. And similarly, I'll check if the service worker is supported in a particular browser or not. If yes, then I'll add the party town config. Otherwise, I'll just go on the fallback. Now let's just get into the code. So here is the sample code. I'll be sharing this code in the end over a QR, so you can just scan it and get this code. So it's a 5-layered process. In each step, we ensure we have a check and we have a fallback in case anything goes wrong. This is more like a simplified version of what we have implemented on our production. So in the step 1, we are simply checking for the supported browsers. So we are checking the browser and we are checking if it's greater than the supported browser version. Check if the service worker is present. So that's how we do this, right? And this is the custom partytown configuration library. So let's say if you were to share some context from the main thread to the worker thread, this is how you do that. So you say that, data layer.push method, I want it to be accessible on my worker thread. And similarly, data layer.splice, that also is needed on the worker thread. All right. Followed by, we can also do one more thing for the optimization, that we proxy our request, which is going to these third party, and host them internally. For example, you were to request GA, right, Google Analytics. So rather than requesting on the Google's domain, to avoid any sort of CORS errors, we can even host them internally and create a URL resolver with the party town, and it will do the heavy lifting for you. And the fourth step would be that we have embedded the party town's native code itself in this library, because we do not want to make that extra network call on the browser, even for fetching the party town service worker. So that's how we have done that. And the final step would be that simply adding the script and offloading the party town. So that's how you do this. So anything goes wrong in this code base, there is a fallback that is mentioned, which is load analytics script. So you can, if anything goes wrong, you can load the scripts in a regular fashion. So next we have the results. How much do you think that we could have achieved with all these optimizations? Any guesses? Let's see for ourselves. So we could see a whopping 200% improvement in our total blocking time. As you can see earlier, the total blocking time of the main thread was near 1.2 seconds, which is now reduced to 570 milliseconds. So that is something which you can achieve with the help of party town. And that is right now when we haven't offloaded all the scripts on the party town. We have just offloaded, let's say, 60 to 70% of the scripts. There is still scope for improvement. And now let's look at the immunity booster that comes with atomics and shared array buffer. So you can understand that, all this communication between main thread and the service worker, and from the service worker back to the worker thread, and this is a complete, a big loop. And there is some cost associated to it. So let's say if we were to, do some very precise analytical optimizations, there could be some delays. Some events could have been missed, right? So for that, atomics and shared array buffer come into the picture. So this is something which we have already seen. And let's focus on the third-party scripts. In the third-party scripts, you can even have, let's say, iframes or videos. There is a very typical use case wherein you can have an embedded YouTube video, and as you scroll down and click on that particular video, there is an advertisement running. But is that advertisement, are those scripts are these companies trustable? Can they, take access of your data? Maybe let's say you are putting in any credit card information at the time of payment, and there is, a marketing script over there. Can it get access or hold on to your credit card details? So can YouTube and Facebook really steal your data? Let's have a look. Hopefully not, because we use same origin policy. So the browser's same origin policy ensure that each and every script that is getting executed from the third party is particularly allowed by that particular domain, by that particular vendor. So that's what is meant by same origin, that let's say if you were requesting from 1mg.com, then either 1mg.com has explicitly allowed all these origins, or they belong to the same origin. Until Spectre. Not this one. This one though. Anyone has heard about Meltdown or Spectre? I can see a few hands. So this is a vulnerability which Chrome announced back in 2018. So these were two attacks which took the web community by storm. This actually proved that, let's say, there is a malicious site running on a tab, and you are, let's say, adding your credit card details on another one. It can get access to your personal details. And how does that happen? It uses high precision timers and speculative execution. So what happens is, these days, even browsers are in a competition. So they want to optimize how the CPUs work. They want to optimize each and everything of the CPU and give you fast results. So there is a cache in the CPU, and let's say you were to run a for loop from 0 to 1000, and the value of your indicator is beyond 1000. The CPU would assume that the value would be within the limit and start executing your code. That's how speculative execution works, right? And then later, when it realizes that, this is not the correct, correct value by the indicator, it falls back. But there is a time for it. So that is where precision timers come into the picture. Each and every record of these timers, each and every microsecond can be recorded and can be, again traced back upon to see whether this result is coming from the cache or this result is going back and fetched from the memory. So what did browsers do? So browsers basically completely did two things. One, they changed their architecture. And second, they disabled powerful features like shared array buffer and the features which used high precision timers. In the new architecture, what they did was that rather than, other tabs or other processes being able to get access to your memory, let's have a completely separate, I would say, workspace for this process, right? So this process would individually have its own memory and its own CPU. But again, we cannot be dependent upon the browser's architecture because Chrome went ahead and implemented it. Then Firefox followed, but still is in process of implementing that. So there needs to be some standardization among the browsers. So that is where site isolation came into the picture. So what do we mean by site isolation? By site isolation, we essentially mean that we are isolating our website, right? And we are allowing particular domains to have access over our memory and our CPU. But why to get into all this hustle? Why do I need, let's say, atomics or shared array buffer? So this enables us to have 10x faster communications between the threads, because now what I have done is I have eliminated the service worker completely from the picture. Now anything the main thread which is storing on, let's say, your memory, the worker thread can access that memory using shared array buffer and the library which is called atomics on top of that. And also there would be no network request from proxy town. And again, one lesser request for the service worker as well. This is how you enable this. There are two headers which you have to enable in your document response. One is cross-origin embedded policy, and second is cross-origin opener policy. By this, we say that only the domains which I personally allow can have the access to my resources. And also, let's say that you are having your own personal assets from different subdomains, which we generally have. So for allowing those assets, what you can do is you can add an attribute called cross-origin, and wherein you do not have access directly onto these assets, you can have a response header which says cross-origin policy for that particular asset is also set to cross-origin. That means that asset is supporting the latest cross-origin isolation. Now here is the browser support for the same. And now before I wrap up, there is a quick quote. Unleash the web performance and defy the limitations of third-party scripts. With PartyTown, you can actually do that. And this is the quotation, not by me. I took the help of ChatGPT. As far as the code goes, if you want to have access over the code, you can scan this QR or take a picture of it, and you will get the optimized code which you can actually genuinely run on your production applications. Now, a big round of applause for our real-life heroes who have actually implemented, went ahead, and really delved into it, wherein this was a very latest thing that has come in the industry, and we have pioneered that. So a big round of applause for all the developers who have worked on that. Thank you so much. This was my time. Thanks, everyone. Thank you. For any questions, for anything else, you can meet me outside. I'm more than happy to answer the questions.
Why I left. Like, otherwise, I loved the company culture. Yeah, yeah.
You spent some like 1-2 years in Microsoft.
Yeah.
So you can't just like 10 months now.
Yeah, it was the other mic and Kushbu's outside. But thank you so much, Parth. That was an amazing session. And yeah, as Parth mentioned, you can reach out to him if you have any questions. Because we are running early, we will be having a pretty big coffee break now. So please go out, network with folks. There's all Publicis Sapient is also having a hiring challenge right now. So make sure you go out with some offers if you don't have one currently. And have a great time. See you back here in some time. Till then, yeah, enjoy your coffee. Thank you.
What if digital could help your organization change the world for the better? better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with Pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here, this is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers, born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is data for engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows, because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is Data for Engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors' ROI and visibility with our in-gallery placements. Supercharge your event experiences with pre-magic's real-time photo distribution. Pre-magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
We just need to understand the data, see the proof, know what works. Call that being particular? We call it being precise. We don't want head-scratching gaps, guesses, assumptions, or opinions. We crave insights and answers born from data. We're engineers who love how having all of our telemetry, metrics, events, logs, and traces cuts through the crosstalk, separates signal from noise, fact from opinion. It's not data for show, it's data that shows because it saves us time, settles debate, cancels meetings before they even start, and says, hey, look over here. This is the problem. When dev, ops, security, and business teams come together around data, it washes away the doubt. It reveals the connections we all know are there, the threads that point to the path forward, and what will really work. This is Data for Engineers.
The visual editor is the heart of Storyblock. The intuitive user interface allows you to manage your content simply by browsing your website. By clicking on a component in your live preview, the configuration appears on the right-hand side. You can jump to multiple components and drag and drop your content wherever you prefer. It's simple to add and change the layout of your content. Rearranging text or optimizing and adding new images is as easy as it can be. Creating great content is a team effort. Storyblock makes it easy for all teams to collaborate in real time within the visual editor. Once you're finished editing, you can either start a feedback loop with a custom publishing workflow, or publish instantly. Users create content and go to market faster with Storyblock's visual editor. Try for free at storyblock.com.
Tired of missing out on event photos? With pre-magic, those days are gone. Just scan the QR code, snap a selfie, and let the AI work its magic. Instantly access event photos through a link sent via email and WhatsApp. But that's not all. Boost event sponsors ROI and visibility with our in-gallery placements. Supercharge your event experiences with Pre-Magic's real-time photo distribution. Pre-Magic, your memories delivered in real time.
What if digital could help your organization change the world for the better? Better technologies, better experiences, better tomorrows. We're Publicis Sapient, a global digital business transformation partner, helping organizations improve lives through digital, elevating experiences, optimizing data, and reinventing products, all to create a better tomorrow for who matters most. Everyone. Publicis Sapient.
With our next session, so we have a very special guest with us. He has a session on pushing the limits of video encoding in browsers with WebCodecs. And we have with us Akash Hamirwasia. He's a software engineer at Razorpay. Please join us. Huge round of applause from this side as well. Cool. So he told me a fun fact about him, that he's a FOSS enthusiast, and one of his GitHub repositories has 1.9K stars. So you might want to check that out. He also told me that there's usually a rule at hackathons that you can't win in 2 subsequent editions, but he was the only exception who actually won in 2 of the subsequent editions because his project was so good. So I'm pretty sure that the talk is going to be amazing as well. Let's give him a huge round of applause and get it started.
Okay. Yeah, I see a lot of seats empty, which is kind of sad. Yeah, just give everyone a call, bring them here. Nobody should miss my talk, even though the talk in the main stage might be good. But yeah, I'm really happy to be here. It's the first in-person edition of Jsconf in India, and that's a huge thing. Aren't you guys excited? I want it a bit more louder. Nice. Okay, so welcome to my talk on pushing the limits of video encoding in browsers with WebCodecs. My name is Akash Amirvasia. I work as a software engineer at Razorpay. I love building a lot of products on the web and learning new technologies and contributing to open source. You might know me from some of my projects, Blaze, Untapped, Diode, Slanted. If you don't know about these projects, well, you have missed out a lot. You are probably living under a rock. You should try them out. You can connect with me on my Twitter, GitHub. I'm at Blender School over there. If you want to know where this handle comes from, there's a long story behind that. I have a website where I talk about myself, akashamirvasia.com. So before we get into WebCodecs, let's start with a little backstory. So a while back, I was building a video editor on the browser to make catchy product videos. I have a lot of projects, and I want to present them in a really catchy way on my social platforms. And I looked at various video editing softwares, Adobe Premiere, Cinema 4D, Blender. Those are hefty softwares that you have to download. You have to learn how to use them. Also, yeah, it's a very time-consuming process. So I wanted to build a very small video editing tool that would make my job as creating product videos much faster. Now, everything was going fine until I started writing the code for the final export process, which is the most important part of a video editor. I got stuck at a bunch of places: video formats, codecs, encoders, muxing, containers. Does anyone know what all of these mean? No one. Oh, there are a few hands. Yeah, it's a good thing nobody knows about this, because that's what the talk is about. But eventually, I was able to finally figure everything out, the entire export process, and I want to share this journey with you, all the learnings I had in this journey. Let's start the discussion by understanding how to draw something like a video on the web today. Video can be simply defined as a set of image frames that are changing at a constant rate, and each frame of this video can be rendered in a variety of ways. You can use CSS animation to render something like a video. You can modify DOM directly with JavaScript. You can set interval and modify the DOM at every interval. It might be performance intensive, but hey, it's still something that's changing at a constant rate. You can use SVGs. This is what Lottie files use under the hood to render the Lottie animations on the browser. Or you can use something called the HTML5 canvas. This HTML5 canvas is a bit verbose in its API, but it's very powerful. You can do a lot with it, and I suggest you, if you're building something like video editor, image editor, or anything that is really complex, you should definitely take a look at HTML5 canvas. There are a lot of things that you can do with it, and canvas is what makes most of the APIs possible in this talk. So when we have rendered the frames of the video, the next step is simply recording those frames and saving it as a video file, right? That sounds easy on the slide, but how do you record something on screen using JavaScript? Now, the reason I mentioned Canvas is because Canvas allows video capture already. This is made possible through its Capture Stream API, which is a part of the media stream recording API standard. This is some code around this idea where I define a function called record. It basically takes in one parameter duration, which is the duration of the video I want to record from the canvas. Then I call capture stream on the canvas, pass the frame rate, which is 30 in this case. And that stream I pass to the media recorder constructor to create a recorder object. This recorder is what we can start, stop to record the actual video from the canvas. Before we can get started with recording, we need to attach two event listeners. First one is data available. So whenever the recorder has some data about the video available, we can do something with the data. In this case, I'm just pushing that data inside an array called chunks. We'll process it later. And the second event is the stop event listener. This event is called when the recorder has stopped, and we can process all the accumulated chunks, convert it into a single blob file, and download it on the user's device. Once the event listeners are attached, it's simply a matter of starting the recorder, stopping the recorder after the duration has elapsed. Really simple code. I really hope this was this simple, but this entire approach, it's not really well suited for this use case. There are 4 reasons to it. The first one is this approach of using capture stream, it does not give you constant frame rate. Capture stream takes one parameter, which is frame rate, but if you dig under the hood, it's actually the maximum frame rate that the browser will capture the frames in. So if the browser realizes that the device's performance is not enough to render the actual frames, it'll start dropping frames so that the performance can be improved. There's no option to change the video file format. You're stuck with the WebM file format. And I'm not sure if you're a video editor, have worked with WebM files before? That's not really a standard file format, right? The third problem is low reliability. So capture stream, since there's a cap on the frame rate, the browser might decide, even if you mention 30 FPS, browser might decide to record in 1 FPS. And let's say I have a MacBook here, it'll record in 30, but if you have a potato, it might record in 0 FPS. So totally low reliability, same code won't give you same output in 2 different machines. And the quality is also okay, nothing great, it's left on the browser as well. Now, it might look like I'm bashing the media recording APIs here, but honestly, they are not designed to be used for such precise and high-quality video exports. Media recording APIs are better suited for transmitting videos in real-time applications, where trade-off of quality is acceptable when you're getting higher speeds. So if capture stream cannot work, can we capture and encode each frame of the canvas ourselves? Here's some pseudocode around that idea. So what I do is, there's a variable called frame that basically stores the frame that I'm rendering right now. And for every frame in my animation, I'll render that frame in the canvas, capture it as an image, and do some processing with it. So let's go step by step. So I first render the frame 1 on the canvas. Then I capture that as an image using the toData URL function that Canvas has, and I store that image in the images array that I have defined. Then the next iteration of the loop runs. I seek to frame 2, I capture the frame as an image, I push it in the array. I keep doing this for all the frames that are there in the video that I want to capture. Once the loop is complete, I come out and I call a function called encode, which takes in the images array and gives me the final video, and I can download that video. Again, this is very high-level code. How do you actually define that encode function, which encodes an array of images to a video? Now, this is a very hard problem to solve because till now, browsers never had a way to actually take an array of images and encode them to a single video file. There was never a standard design for this. There are various implementations in JavaScript that allow you to do something like this, and at this point, I would like to mention a library called WAMI.js. WAMI is a real-time JavaScript WebM encoder. It appeared on Hacker News 11 years ago. I guess most of you were in school studying algebra at that time when this library was launched. So it's very old at this point. But the idea of WAMI is it takes the snapshots of your canvas as images and encodes them to a video file, which is essentially what we're trying to do. So if we look at the encode function that I defined, that I'm calling in the previous slide, this is how it would look like. WAMI has a from-image array function, which we can call, pass in the images data, tell it the frame rate, and it'll give you the final video file that you can download on the user's device. You can check out WAMI at this URL. Now, I tried a lot of these JS libraries, some WASM solutions as well, and I realized that all of them share the same set of pros and cons. The first pro is you get high quality output compared to capture stream. Because we are manually seeking to every frame, drawing that frame, capturing the frame as an image, then converting everything to a video, there's no place of dropping frames or quality loss. You get really high quality output. You get constant frame rate because we are manually controlling in our code how every frame gets rendered and captured. And the entire code is relatively easy. As long as you have a library that can do the encoding process from an array of images, the overall code was really simple to understand. That's the only pro in this approach. Now I'll come to the cons. The list is huge, which is kind of sad. So the first con is the entire process is very slow. And this is because the APIs that we just used are synchronous. The toData URL that we are using to capture the canvas as an image, that is really performance intensive. And when you run it in a loop for thousands of frames of a video, a simple video can take a long time to actually render. There's no hardware acceleration, so even if your device supports some hardware acceleration for faster encoding, decoding, these JavaScript libraries simply can't tap into those optimizations. You're stuck with execution on the CPU. There's no choice of video formats. You're stuck with the WebM file format, and there's no support for adding audio too. Now what? At this point, I felt like I've come at a dead end. I tried a lot of approaches, a lot of solutions, nothing was working. I'd almost given up. But after some time, I realized that there's this interesting new standard that has appeared on the browsers, and nobody has been talking about it enough. There's very little documentation online about it, and I hope this talk actually fills in that gap. And this interesting new standard is, drum roll, there's no drum roll, that's the talk about, it's WebCodecs. So what is WebCodecs? WebCodecs are a set of API that give you low-level access to individual frames of a video. Once you have the access to these frames, you can do the encoding, decoding process at the frame level of a video stream in various formats. The nice thing about WebCodecs is because it's a native web feature, it's asynchronous and hardware accelerated. So any optimizations on your hardware, WebCodecs will make it available to your code. And the APIs are vast. It supports more than just video. You can also encode, decode audio too. But in this talk, I'll only be focused on encoding videos. Now, the other day, I was looking at the WebCodecs article on MDN. This is the first paragraph of the article. And I'm not sure if you noticed, there's a part in this article that got me really excited when I went through it. It's actually this bit. So what the article basically says is that WebCodecs gives you low-level access to individual frames, and it might be useful to build applications such as video or audio editors. That's exactly what I'm building, right? So I felt really excited when I saw this. It felt like I'm finally in the right direction, and this is the thing that I was looking for. Before diving into code, let's look at the video encoding process in WebCodecs at a very high level. So the encoding process is divided into three parts. The first part is actually defining your input source. Yeah, my formatting is messed up, I guess. Just the cons of building your slides using JavaScript. But yeah, you define your input source using canvas, image bitmap, or media stream track. So that's also the reason I suggested you to use canvas, because rendering frames in a canvas is very easy. Image bitmap and media stream tracks are a bit more lower level. Once you have your input source ready, you can pass that to a video frame. You can create a video frame out of your input source, pass that to the video encoder that we create. Video encoder takes in a bunch of video frames together, converts it into a single encoded video chunk, and then you can do a lot of things with that encoded video chunk. You can transmit it over network for real-time applications, or store it somewhere and do very crazy things with it. But in this talk, again, I'll be focused on the storage aspect because we are encoding a video end-to-end. So let's finally look at some code to encode videos using WebCodecs. The entire process starts by creating a video encoder. So video encoder is created using the video encoder constructor. It takes in two callbacks. The first one is output. This is called whenever the encoder has some encoded chunk ready for you to do something with. And the second callback is the error callback. So if anything goes wrong, this is where you handle the error. So for this implementation where I'm actually encoding a video to a file, what I need to do is I need to store all the encoded chunks in an array, and I'll process it later. So I define a chunks array, and inside the output callback, I simply push that chunk. Chunk is basically an array buffer. You won't understand it. It's just ones and zeros, but it's basically the encoded video data. So I'm just pushing this inside the chunks array. And so when some error happens, I just console log. Yeah, this is the production code that you should write. Once you have the video encoder ready, the next step is actually configuring this video encoder, and this is the important bit. So creating the video encoder is the first part. Configuring is where you tell it what format you want to use, what are the frame rate that you want to use, and various other options. We'll go through some of the options over here. The first one is codec. It's set to VP8. I'll come to it in a bit. There's a huge part of the talk which is dedicated to codec. Second is hardware acceleration. You can specify whether you want to use hardware acceleration. Prefer hardware will give a hint to the browser whether if hardware acceleration is supported, try using the hardware acceleration. Frame rate is, well, the frame rate, latency mode. So if you're building a real-time application where, again, you can have a trade-off with quality, but you want higher speeds, you can set latency mode to real-time. Then you'll get the encoded video chunks much faster, but there might be some compromise in the quality. Width, height, bitrate, these are standard parameters.
Now, out of all of these options, the most important one is actually the codec, the first option here. How do you find the right codec? It's not as easy as WebM, MP4, AVI, and various other file formats. If you look at a codec string, this is how it looks like. See, they are random, right? Do you understand what AVC 1.420034 mean? There's a huge document about every single number in that string. And I won't be going deep into it, but the main takeaway you should have from this slide is that video codec is not the same as video file format. And this got me confused a lot. I thought codec is simply a fancy and a professional way of saying what the file format is. If I'm building an MP4 file, the codec should be MP4. But no, they are completely different. And to understand how different it is, let me give you a 101 on video encoding. So the entire video encoding process starts with individual frames of a video. You can think of these as image data, frame 1, 2, 3. All of them are passed to what's called an encoding algorithm. The job of the encoding algorithm is to take all the frame data, compress them, convert them, and store them in a single video stream. And this encoding algorithm is what is called a codec. The output of a codec is a video stream. Video stream contains your original frame data, and this video stream is not the thing that you see on your hard disk. There are still a few more steps left. With the video stream, it's passed through what's called a muxer. The job of the muxer is to take a stream and put it inside a container. In this case, I've taken the video stream and put it inside the MP4 container. And this container is what you see on your hard disk. The video.mp4 that has a video stream inside it, that video stream has the individual frame data. Now you might wonder, what's the job of the muxer here? Can't the encoder also do the same thing that the muxer does? Well, that is because videos are not just visual data, right? There can be audios, there can be subtitles. And have you ever wondered how a single file has all of this data? Well, that's the magic of muxer. It takes in multiple data streams, video, audio, subtitles, combines them, multiplexes them into a single container, into a single file. So here you can see video stream, audio, subtitles, everything in a single file. Let's come back to a codec. So, by the way, the battery is running low over there in case. So codec. So codec is an encoding algorithm, again, to compress the individual frames of the video. A codec and a container must be compatible with each other. So if you have a codec that you're using to encode MP4 videos, the container is MP4, but your codec should also be compatible with the MP4 codec container to be used. So this is a small table which goes over common containers and codecs. So if you're creating an MP4 file, which is quite common, you need to use the AVC or AV1 codec. AVC is Advanced Video Coding. I never knew that before. If you're using WebM container, you have to use VP8 codec. The example strings that I've mentioned, those are actually the strings that you need to pass to the codec option in the configure function. So these are the strings that you can use if you want to use that particular codec. Now, to make this even more challenging, every browser supports different set of codecs. So if this browser supports, let's say, the AV1 codec, some other browser might not support that codec at all. Now, I won't dive deep into what the codecs, the numbers in those codec strings mean. I've left 2 links over here. They are, a lot of information to digest, but yeah, it has all the information you need about codec compatibility across browsers and what the numbers in those codecs mean. It's a deep rabbit hole. Coming back to the code, so this is the same configure. I've just changed the codec to AVC1. I want to use this codec to encode an MP4 file. And since I'm using the AVC codec, I have an option to actually pass some options to this codec itself. So I'm setting AVC and the format of the video processing to Annex B. I won't dive deep into what Annex B means. Yeah, it's just the professional way of saying I don't know what it means as well. So yeah, this is, again, you have a lot of options. The next step is, so as I mentioned that web codecs, certain codecs might not be supported in certain browsers, right? So video encoder has a function called isconfig supported, which you can call with the config, and it will tell you whether this browser supports that config or not. So you can pass in the config data. It will give you whether this codec is supported on the browser. If it's not supported, you can just tell them this message or fall back to another codec. If the codec is supported, you can call the configure and pass that config. And this actually creates the video encoder in this whole process that we had. The next part, we again write the same loop that we just saw in the starting of this talk. So we go through every frame of the animation, render that on the canvas, and once we have rendered a frame on the canvas, to convert that to a video frame, just call the video frame constructor, pass in canvas. If you have other sources, image bitmap, media stream track, array buffers, you can pass any kind of data to video frame to create the video frame object. This also takes a lot of options, but we need to only pass timestamp, which is the most important one. Timestamp tells which, at what time this frame shows up in your video. So I just do some math. Yeah, I didn't use ChatGPT for this. So I just do some math, frame divided by frame rate, multiplying it by million because this property is actually in microseconds. And then you just simply pass this video frame to the encoder using the encode function and close the video frame because our job is done. And that's the entire actual encoding loop. This runs for every frame in the video and passes it to the encoder, every frame that we have. Once the loop is complete, we can come out. We can call the flush function on encoder because, again, these APIs are asynchronous. So once you're done with the encoding process, you need to call flush to indicate that whatever data is pending to be processed, just process them and, yeah, convert them to encoded video chunks. And since the job of encoder is done, I can close it. And the next step here, so remember, I had attached an output callback to the video encoder that was pushing data to the chunks array. Now we can actually use all the data and do something with it. Chunks is actually an array of array buffers, as I mentioned. And in this step, I actually concatenate or flatten that array to a single array buffer. There are various algorithms online that you can refer to do this. It's a very simple process, and yeah, this basically just converts an array of array buffers to a single array buffer. So once we have the video buffer, the next logical step would be to simply download that video buffer, right? No. Recall the video encoding process. This is how it looks like. The first 3 steps is handled by WebCodecs. You get the video stream, the final video stream that you get as the output from WebCodecs. What are the steps remaining to get the file? It's muxer, and that is not handled by WebCodecs. When I first got to know about this, I felt, what is the use of this API if it can't even do the entire thing? But once I understood what the difference between codec and a muxer was, this became really clear. So how do we actually handle the muxing bit? Now, this, again, is an operation that is not documented anywhere. Nobody has had a need for actually muxing a video. Who, in their day job, muxes a video using JavaScript on the browser? Nobody. So I had to try out a lot of things, a lot of libraries, a lot of WebAssembly stuff, figure everything out on my own. And finally, the discussion of this talk shifts to this decade-old library called FFmpeg. No discussion of video and audio encoding gets over with FFmpeg. How many of you know what FFmpeg is? That's good. So FFmpeg is a decade-old library written in C, C++. Can do anything related to video, audio, encoding, decoding. And thanks to WebAssembly, we can use FFmpeg in JavaScript in browsers today. And I'll be using ffmpeg.wasm project for this, but there are various compilations available online. So you can actually try out, see which one works for you. This ffmpeg.wasm, it's the simplest one to work with, which is what I've found. So once when you have ffmpeg wasm installed on your project, ffmpeg exposes one function called createFFmpeg. Call that, call the load function. These are steps from the documentation. Now what you do is you write file. So this video buffer that we just got from the previous step after the whole WebCodecs stuff, we write this file into ffmpeg file system because remember, we are now interacting with a WASM binary. ffmpeg has its own memory space, own file system. So we are passing this video data to ffmpeg using the write file command. The raw.h264 that I've mentioned here, that is also important. H264 is again indicating FFmpeg that this is the codec that was used to encode this video. The next step, which is the run function, that is where the FFmpeg command to actually mux a video from the encoded video stream to the final video file, that is where it's being done. So it takes in the video stream, converts it into a file called output.mp4. And muxing is a very cheap operation. So even though WebAssembly binaries are not really well suited for encoding videos end-to-end, if you are just using them as a muxer, this should work fine. There should be no performance bottlenecks. This process happens really quickly. Once this is done, I simply read the FFmpeg file system to get the data out. So I'm reading the output.mp4, which it had created. And since I'm done with FFmpeg, I clear its memory space. I delete all the files, raw, output, and so on. With this output data, I convert it into a blob and finally download that on the user's device. That is the video encoding process. Not in a nutshell, that is actually what it is. So the next question is, isn't FFmpeg WASM heavy? What do you think is the size of FFmpeg WASM? How many of you think it's less than 5 MB? 5 MB, less than 5 MB. How many of you think it's less than 10 MB? Less than 20? Less than 50? More than 100? More than 100? Okay. So it's just 24.4 MB. Did you actually take it seriously? 24.4 MB. You're shipping this huge WASM binary to the browser, 24.4 MB, just for a simple muxing process. Now, FFmpeg as a library, it's very generic. It has a lot of encoders, decoders, muxers, demuxers, a lot of formats. It has a lot of things. But we are only interested in one part of this library, which is the muxer. FFmpeg calls it libav format, just because. Now, since we are interested in only this part of the FFmpeg library, it should be possible to isolate it and compile it as a separate WebAssembly binary. I haven't done this exploration myself, but there are, some libraries out there like this one, libav.js. So they have some, setup already in place where you can actually extract out libav format, compile it separately as a WASM file, and include that. That will significantly reduce the size of your WASM binary. Another great read, this one. You don't have to take pictures. I'll share the slides with you. But this one also, this has some details about how you can customize the ffmpeg.wasm project itself to compile it for exactly what you need. That's how you encode a video in the browser. Let me actually tell you all the pros with this approach, and it will literally fill the entire screen. I'll show it to you. The first pro is high quality output. We are manually controlling the frames. We are encoding everything in highest quality. There's no frame drop anywhere. Constant frame rate, again, we are manually controlling the frames of the encoding process. The entire process is really fast, and that is because most of these web codec APIs are asynchronous, and they are also hardware accelerated. So if your hardware has some optimizations, WebCodecs can tap into those optimizations. You can use any video format as long as the codec and the container is supported, and you have the support for adding audio too. The last step, which is the muxer, that is where the audio gets added. And FFmpeg already supports adding audio as well. So adding audio is a very trivial process in this setup. The only con in this entire process is it's relatively hard. I can see how hard it is because someone is sleeping over there. Now, the good news is it was hard for me. I spent 2 months understanding all these things so that you don't have to. So it should be really easy for you now after this talk. At least that's the hope. Speaking of browser support, this slide is always there in any JavaScript-related talk. WebCodecs is supported in all browsers except Firefox, which is kind of sad, so I really hope WebCodecs lands on Firefox as well. WebAssembly now is thankfully supported in all browsers, so you can use FFmpeg, WASM, and various other nice compilations of libraries to do crazy things on the web today. Now remember, I was building a tool to make product videos. I finally did end up building it. It's called Slanted. It allows you to make catchy product videos from simple screen recordings in just a few minutes. And the video that you see in the background, that was actually made with Slanted. So I screen recorded my screen of me using Slanted, and then I added these 3D transitions, effects, made the video look like what you would post on Product Hunt and get the #1 product of the day tag. There are a lot of features in Slanted. You can try it out. The URL is in the second box, slanted.app. And that brings me to the end of this talk. Thank you for listening. I hope you learned something from this talk. You can connect with me on Twitter, GitHub, at Blender School. Yeah, they just want me to leave, so they just remove the slide. But yeah, you can connect with me on Twitter, GitHub. I also have a website. If you are interested in getting the slides, it's already up. You can check it out at slides.akashamirwasi.com. Thank you.
That was an amazing session, Akash. Thank you so much. We've been very glad to have such a patient and interested audience. Yeah, that's been amazing. And we will be heading to our last session. We are just waiting for a speaker. And this would be our last session for track 2. But after that, we'll be moving to track 1 where Kyle Simpson's session's gonna be there. Whoa. You can still, there's one more session, folks. Yeah. They're gonna regret it, Jamal. Yeah. Yes. So here we have Jamal today from Netflix. And he's gonna give a talk which was very hard for me to remember, so I'm just gonna read it out. It's on time series forecasting of stock market prices using long short-term memory networks, Node, and TensorFlow.js. Jamal, the stage is yours.
All right, make sure I'm all set. All right, there we go. Hello, Bangalore. Hold up. I flew over here from New York, right? All the way from New York City, many miles away, worked every day, and I'm flying back tonight. I need a warmer welcome from my friends here in Bangalore. All right, that's what I'm talking about. Now we can start. I got the proper welcome. Thank you very much. I appreciate it. So let's get this talk started. So who am I? My name is Jamal Sinclair O'Garrow. I am a senior software engineer at Netflix. But prior to working at Netflix, I worked in the financial services industry for roughly a lot of years. But I worked as a software engineer building algorithmic and electronic trading software for the last 7 or so at a hedge fund / high frequency trading firm, building software that actually trades live orders to the market that processes about $1 billion a day, roughly. So as I mentioned, I'm here from New York City. This is my first time in India. So I had a really good time here, so thank you all. Some fun facts about myself is that I am a hip hop head, a sneaker head, a New York Yankees, Giants, and Knicks fan. So let's go Knicks. We made the playoffs finally for the first time, the second round of the playoffs for the first time since forever. Any fans here of the NBA? Yay. Any Knicks fans? Oh, we have one. All right. Yeah, the Knicks are an international team. Thank you. All right. So let's get into it. So why am I giving this talk? So as mentioned, I have a finance background. Recently, the last year or so, AI and ML research has become a hobby of mine. My primary focus has been on economics and finance, mainly for my own personal investing. So I don't believe in paying someone else to manage my money. I want to manage my own money. But during my time working in the financial services industry on Wall Street, I learned a couple of tricks that I wanted to pick up on. I'm also a JavaScript engineer, very passionate about JavaScript, and have done deep learning in the past, but mostly with Python and R. And then when I heard about TensorFlow.js, it was very interesting to me because I wanted to see how those capabilities can be brought to the JS ecosystem by building deep neural networks and training them within the browser or within Node. So currently right now I'm learning more about LSTMs, long short-term memory networks, for a hobby paper that I'm working on right now, comparing the performance of ARIMA versus LSTMs for predicting stock prices, because I plan to use whichever one I find to be more effective within my own active trading. So also I want to share what I've learned. Sharing is caring. And as mentioned, I cared so much that I flew over here from New York City to see all you guys and give this talk. So let's go into today's roadmap. So first we're going to explore the background of our problem space, right, which is time series forecasting. We're going to learn what that is and why it's important, how we can use it to be better investors. We can review the basics of artificial neural networks, recurrent neural networks, as well as long short-term memory networks as well. And then we're going to examine a very simple, naive, open source project that uses LSTMs for predicting stock prices. We're going to keep it fun. We're going to keep it informative. And the last talk that you guys are going to have to sit through for today, so I don't want to bore you to death before I head back to NYC. So today, we're not going to go deep into the mathematics or the low-level mechanics of time series forecasting or the models that we're discussing. We simply don't have time for that. It's a very, very dense topic. We're going to keep everything high level here. So we won't cover how to evaluate or interpret our models that we're going to work with, and then we're going to look at a very simple, naive example that you should not use to trade your own active money. So with that being said, let's go through a disclaimer. Nothing presented in this talk should be taken as investment advice. It's for educational purposes only. Following anything demonstrated in this talk is likely guaranteed to cause a loss of funds. You will likely lose money. If you don't like losing money, do not employ this in real production trading, coding, whatever you're trying to do. So invest, trade, and participate in the financial markets at your own risk. So I know some folks here like Wall Street bets. You probably woke up one morning and heard about a stock called GameStop, probably bought a bunch of shares, had a briefcase full of money, we're thinking about buying that nice yacht on the Hudson, on the Hudson River in New York, living the Wall Street lifestyle, can't stop, won't stop, doing a Diddy dance like Puffy and Mace, from back in the day, right? Until eventually the game did stop. It was game over, right? GameStop fell, and then eventually, your profits were probably looking pretty good here, as in figure one, and then you ended up with $24, basically nothing. Or in some cases, you could end up with something that looks like this, where you entirely fall off a cliff and lose all of your earnings and then some. So with that being said, do not invest on this, and let's now get to the talk. So first, let's talk about what is time series data. So at the end of the day, time series data is basically data point sequence in time order. So we can think of it as, I like to call it timestamp data. So say if I have data over a particular period of time, hours, days, months, years, we can take that data and then add a simple column that labels the actual time that we actually capture that data. It allows us to keep track of how our data changes over time. Very simple, high-level explanation of what time series data is. Some examples you may have seen in the real world are changes in temperature over the last 10 hours, fluctuations in your heart rate during a short run, rainfall measurements over the past 3 years, Formula One lap times over the last couple of competitions, and price of a stock over the last 4 weeks, years, or whatever. So here's an example of what time series data looks like. Here's an example of stock prices. Here we have open, high, lows, close, adjusted close, and we have this date column here that tells us exactly the day that we actually stamped this data, so we can see how the price changes over time. And we'll see how that's going to be helpful for us in a few. So what is time series forecasting? Time series forecasting is predicting our time series data based on previous trends that we find in that data. So examples are, you want to predict the weather for tomorrow, you want to predict the sales for the quarter in your company based off the last 4 quarters of the year, or you want to predict your stock prices off of the last month's returns. Here's an example of what a time series forecast looks like. This comes from wallstreetjournal.com. This example shows Apple's price over the last 12 months, and they use that 12-month data to actually try to predict where Apple's price is going to be 12 months from now. We see that at the lowest, it'll be $74. At the high, it'll be $150. And somewhere in the middle, it'll be around $133. So how do we actually forecast data? How do we actually forecast stock prices? Well, let me ask you a question. Can anyone in this room predict where this ball is going to go? Is it going to go up, down, left, right, come to me out the screen? It's going to go back in the distance? Like, you have no idea, right? Because without any additional context, we're guessing. We're not making a prediction. Our goal is to predict where it's at. But what if I gave you data about where the ball previously was? Do we now have some idea where it's going to be in the next couple of steps in our time series? So the same idea applies to stock prices. So we look at the previous stock prices, we look at the trend there, and use that to project forward what the new price is going to be. So currently, you can use statistical techniques like regression analysis or REMA, which I'm looking at right now, to forecast these prices. But more recently, deep learning has become pretty popular within this space. So what I want to do right now is just do a very quick overview of deep learning, because some folks here probably may not be familiar with some of the terms. Anyone here, is anyone here familiar with like ANNs and deep learning at all? Show of hands. Okay, so a few. So that's good to know. So I'm going to give you a high-level overview of what deep learning is, and we're going to use it to actually predict some prices. So if I quote my good friend Jason Brownlee, he's not actually my friend, he's my friend in my head. I love reading his literature from machinelearningmastery.com. He says that deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and function of the human brain called artificial neural networks. So whoa, that was a lot of jargon, a lot of terminology. Let's just step back and go through some of the terms we're going to have to understand and be familiar with to continue through this talk. So first that we saw, there was an artificial neural network. For our purposes, let's just think about it as a really good algorithm that can approximate functions, right? Maybe there's some function out there that can take an input of a series of prices and they can give us back a price or a series of prices projected into the future. These artificial neural networks work very well to learn the coefficients of that function so that we can actually feed it data and get back predictions that we can actually use to trade on or perform other business decisions, depending on what the domain is. You can either predict values or also perform classifications. So some things that we have to look at are when we're training neural networks are the epoch, which is the number of iterations we're going to take to train our model. Because what happens is that we have to train our model in steps. We have to do several steps in repetition in order to make our ANN get better so it can learn to predict better. One thing is the learning rate. For our purposes, it's going to be how aggressively we're going to adjust the weights in our training steps. So the weights are just the coefficients in that function we're trying to predict. That's going to allow us to actually predict stock prices. And then also there's an input layer. Think of this as being the data that we're going to pass to this model before we train it. So it's going to be some stock prices in the past. Then there's going to be an output layer. That output layer essentially is going to be our prediction, right? What is the price or prices we're trying to forecast? And what sits in between those two layers are what are called hidden layers. And what they do is they just take our input data and then they process it. Some magic happens in between that allows us to actually learn a function that's going to give us accurate prices. Two other things are our loss function. The loss function just tells us how accurate our predictions are. If the predictions are way off from our target values, the model's not doing very well. If the loss function is low, then we're doing pretty good. And then we use an optimizer, which is an algorithm that's going to help us minimize our loss function. So as an ANN, as we mentioned, it's an algorithm modeled after the way that neurons in our brain send information to each other. They're function approximators, and they're very good at approximating functions given data. So they learn from data. So high level, here is an example of an artificial neural network. So here are the layers. They're basically just like sets of neurons. You can think of these as being individual data points. In the real world, there would be way more items than this. So the idea is we put some input into this ANN. It flows through these hidden layers. Some kind of processing transformation happens to it. And then out comes an actual prediction. And what we do is, at first, we just randomly assign some characteristics, keep it high level, to these hidden layers that will give us some random output. And then what we do is do a process called backpropagation. We go back and try to learn like the optimal values for those characteristics that are going to give us a prediction that's going to be very close to reality when we give it some unseen data. So that's like the training process in a high-level nutshell. So next, I want to talk about recurrent neural networks. So we take a quote from IBM. They say that a recurrent neural network is a type of artificial neural network which uses sequential data or time series data. They're distinguished by their memory as they take information from prior inputs to influence the current input and output. Again, a lot more terminology and jargon. At the end of the day, we're going to look at RNNs as basically being a special kind of like neural network that has a memory. So in our previous example, we can pass data through the network. It flows from left to right, gives us an output, but we can't pass in essentially like sequential data. So you want to just pass in, let's say like 100 stock prices from over the last like 2 quarters or so, right? It's not possible here. The RNN actually has the ability to remember prices from a very long time ago and prices that are current in order to make that prediction. So here's an example of what an RNN looks like. I'm not going to go too deep into this, but the idea is that we take some kind of data, take some input, we store the state somewhere, we produce some kind of output, and then we feed that result back into the network over and over and over and over again for it to be recurring. And then what we actually do is we do something called unrolling the network, where we particularly make copies of each individual input that we're going to create and do this process over and over again. So value 1, we go in, we get a state, get an output, pass in value 2 in that output, and so on and so on. But one thing to notice is that if we have 100 inputs, we're going to have to unroll 100 times. So we'll talk about how that can be something that's going to be make our lives difficult in the future. So the benefits of using RNNs over an ANN is that they use this feedback loop that we just spoke about, right? You get some data in, you get some output, you put it back in, and you can learn and remember previous data from the past. And you use that to make a prediction into the future. So what that means is that we can take today's price plus as many prices as we have in the past, feed this into this RNN, and then get back a price or future price projected into the future. As you can see from that, from the way that this works and the way that the algorithm is built, it works very well with time series data. Or let's say it works well with time series data. We'll find out what some of the downsides are. So one downside is that if we pass too much data to it, it'll slow down the training. That's because we have to unroll the network for every single item. So the longer it is, the harder it's going to be, the longer it's going to take for it to train. And they're also subject to a very famous problem called the exploding/vanishing gradient problem. We're not going to go too deep into that. I can do a separate talk on that altogether. But it's just something that, just know it's just a issue that RNNs have. And the way that we solve it is using long short-term memory networks, LSTMs, which are what our talk is about today. And I promise I'm going to show you guys code. I just want to make sure I get to some of this theory first before we actually go into some code. So if we talk to our friends at MIT, they would say that LSTMs rely on a gated cell to track information through many time steps, making it easier to track long-term dependencies in the data. This allows us to model sequential data more effectively. Again, more jargon, like what are they talking about? What does this mean? So essentially, an LSTM is an RNN that uses long and short-term memories. So if the RNN takes all of our data into account from way back in the past until now and tries to process all of it, the RNN has a way to actually figure out which data from the past makes the most sense to look at today versus what's least important to look at, right? And it does this between using these 3 gates or filters that we have. So first is the forget gate. That forget gate decides how much information from our long-term memory, so think stocks from way back in the past, is going to actually be used for our predictions. The input gate takes a look at how much information from our short-term memory we're actually going to keep. And then the output gate decides what's going to be our new short-term memory based on the values returned from our forget gate and our input gate. And it's going to use that to do the same thing, recur all over, take the output, pass it back in, and then give us predictions. The benefit here is that, so let's actually look at a diagram. So this looks also super complicated, but just know that the main things here are these 3 sections, right? So here is our forget gate. It's going to say, hey, what is my long-term data? What do I need to keep? It's going to perform a special function on it. It's going to squash the value between either 0 or 1. And if the value is 1, we're going to keep all of the data. If it's 0, we're going to keep none of it. And anything in between determines how much of that data we're going to keep bringing forward. Something similar happens here with the input gate, but we're looking at our previous hidden state, which is our short-term memory, along with our current input data, doing something similar and deciding how much of that we're going to add back to our previous long-term state, and then we pass it through to this output gate that's going to decide, okay, what is going to be our new self-stated hidden state based on what we calculated here within this LSTM, and that data gets fed back in the recurrent neural network style. So what are some benefits of LSTMs? We can handle longer sequences of input data than vanilla RNN for reasons that we mentioned. The larger the RNN gets, the harder it's going to be for it to train. With the LSTM, we have these special gates that can actually identify what data we should actually keep and what should have the most influence on our predictions. And it also has the biggest benefit is why we use LSTMs over RNNs is that it gets rid of the exploding vanishing gradient problem. So now let's briefly talk about TensorFlow, then we'll look at a very simple example of how we can do some forecasting. So TensorFlow, as you may have known, may have heard of is a numerical computation library, open source by Google, that's used for performing deep learning tasks, but it can do much more than that, but it's primarily used for building neural networks and different deep learning structures that we can use to perform machine learning analysis or data science type tasks on. It can run on either your GPU or your CPU, and the data flows through these different graphs that you create as tensors. Just think of them as like vectors or matrices that represent your data, and hence the name TensorFlow, because these tensors flow through these different networks that you're going to create. Now, TensorFlow.js is simply just the JavaScript and node bindings for TensorFlow. So if you ever use TensorFlow in Python, it's essentially, you can do essentially the same thing you can do in the Python version of TensorFlow. You can do it all within JavaScript. You can train models in the browser. You can train them in Node. You can train them on devices. You can import existing models. So if you go to a website like huggingface.com, where somebody has spent the time to actually build a robust model, you can take it and import it, give it data, and start making predictions right away. It also supports WebGL, WebAssembly, and your CPU. Has full CUDA support. So basically everything you get in Python you have. And under the hood, it uses the same C++ engine that the Python version uses. So you won't really see any performance hits. The only thing I can see that's different between like the JavaScript version of TensorFlow and the Python version, besides a slightly different API, is that you don't have things like pandas and scikit-learn and matplotlib to help with your whole machine learning and data flow. But if you're looking to embed models into your Node.js or browser-based applications, you can use a lot of that functionality within TensorFlow directly without having to set up a separate Python server, make a call to it, make a full round trip, because you can actually train your models or perform inference directly in your browser, or you can do it directly within Node if you're writing some kind of script or what have you. So very last slide of me like talking before we actually see some actual like stock predictions and looking at some code is that I want to just very briefly go over like the deep learning process, like because we're going to actually go through this to actually forecast some stock prices, is that first we have to formulate our task, and that is, are we making a prediction or performing a classification? In our case, we're predicting stock prices out into the future. Then we have to prepare our data. So we have to clean it, shuffle it, normalize it, right, convert it into tensors or et cetera, because it's going to be natively in JavaScript arrays. So we have to perform some kind of data transformation there. Next, we're going to build and run our model. We'll see that TensorFlow actually gives us several methods and factory functions that allow us to actually create neural networks and recurrent neural networks from scratch. We then select that optimizer that we spoke about, a loss function, and then we confirm that our loss is actually decreasing because our goal is to get our losses as close to zero as possible. And at the very end, we then evaluate the model. So we check the evaluation metrics and make sure that everything looks good. So basically what we do is we hold a certain subset of our data, which we call our test data, and we pass it. So this is new data that our actual model has not seen before, and we see if the predictions actually make sense. So they look like what the actual values are. If they do, then we can actually use it for prediction. So we're going to go through that flow in these last 10 minutes or so. So let's skip over to the browser and look at an example. Now, one thing is that I don't have access to the internet, so I can't run this stuff live. So no live demo, no. I came with a plan B. I preloaded everything already in a separate tab. So just pretend that I'm clicking these buttons to actually go through and fetch the data, and then we'll go through what this open source application does to actually predict stock prices. Then we'll look at some of the code to see how it actually works behind the scenes. So first, what we do here, we actually load the data, stock price data from 2000 until now. We're doing at a weekly frequency. So what we're having here is all the current prices every week is going to be the adjusted close. And the next thing we're going to do is we're going to calculate something called a simple moving average. And all we basically do is pick some kind of window. In this case, we said we're going to look at from time T now. We're going to take all the prices going back 20 days and then compute some average and then use that to create this smooth curve that we see here that allows us to see what the trend in the data is. So what this project actually does, it says that if we can take the simple average and calculate it from 20 days in the past, pass it to some kind of recurrent neural network, in our case is going to be a LSTM, we can then predict the SMA, and that should be a good approximation of what our actual price forecast is going to be. So we're actually forecasting SMAs, but we're saying that this is close enough to the actual price for it to be an actual prediction. So this is an idea of like what the data looks like. So we see here we have an array of the last 20 prices. That's our X values, that's our X input. And what we're doing here is passing it an actual label or the actual SMA for it. And we do that in 20-week windows going all the way back to the year 2000. We pass that to our LSTM. We go here to this section and we tune what we call our hyperparameters. So we tell it how much of the training data we want to keep. In this case, I just accepted the defaults. They did 98%. You normally wouldn't do that. You're probably like an 80-20 test split. You have some 80% training data, 20% to test on. But the default here was 98, so that's fine. Epochs is how many times we're going to actually go through that training process. The learning rate we have here, like how aggressively we're going to try to adjust our weights, and then also how many LSTM layers that we want. So here we actually look and see that for each epoch, for each iteration, we look at the actual loss itself. So a higher number means that we have a lot of errors. We're doing a very, very poor job of predicting the stock prices based on the data that we give it. And every time we go through an iteration, we get better. So we should get closer to 0. And as we look at this chart here for our 10 epochs, we actually start to converge to 0. And you can see the actual values here on each run. We see that it starts to get smaller, smaller, and smaller. Now, the very last thing is to actually validate our data. So we have the actual stock price. We see that we're not really predicting the price directly. But if we look at our SMA, what we're actually trying to target, what we actually were trying to predict, you can see that with this green line, which is our predicted line, right, that we got from our training data, we're pretty much like lockstep, like pretty close to like what we're actually seeing in the actual labels, the Y values that we actually pass to it, like the actual SMA. And then when we actually predict it against the stock price, we see that, okay, we're not exactly line for it, but if you look at like $12.79 versus $12.41, all the way down to the last one, $12.11 versus $12.07, we're getting pretty close. It's not bad. It's enough if if you wanted to trade, I don't recommend you do it, you can get a good approximation of what the price would be. Like forecasting stocks are very hard. You're never going to get exactly on the money. We want to get as close as we can to get an idea of like where the price is going to go so we can trade. Now, the validation looks pretty decent. Let's see what an actual prediction looks like. So we look here, we say, okay, on June 1st, we had a price of $12.11. And we're going to say 1 week later, we think the price is going to be $12.08, right? So it looks like this model actually did pretty decently. If we were trying to predict stock prices, going through this simple flow, we might say that this is something we might want to probably use. We want to try to continue to tune it to make it better. But if we look here at another example, this is Tesla stock, right? The same process, same inputs, different stock price. We see that we look here at Tesla's trading somewhere around like, what, $210 or so yesterday. And then this model is saying it's going to drop all the way down to $177. Just falls off a cliff, just jumps and dies. It says, hey, you know what, I just want to just give you all losses. We're dropping down to, $177, which is highly unlikely. So one thing to take with a grain of salt, if we scroll back up and we look at what the validation looks like, we see that Tesla's stock is swinging all over the place. There are very high changes in the prices. So it's very hard to use at least this SMA to actually try to predict this particular stock. So let's jump over to the code really quickly, and let's look at how this is actually built. And then we'll talk about a few takeaways, and I will share some resources and just some other, hopefully, interesting things with you. So let me blow this up. So at the end of the day, this is the open source project that we looked at. It's very simple. It's a simple HTML file. There are 2 JavaScript files. One is for all of your DOM interactions. All the magic really happens here inside this model.js file. And there are 2 functions that do most of the magic. One is this train model. It takes all of our previous prices, our X, all of our SMAs, our Y values, the window size, the number of epochs, the learning rate, the number of layers that we all selected, and it goes through and does some processing. It converts our data into tensors. And then what we do here is do the actual magic where we say, let's call this TF sequential method. This gives us back an instance of a TF sequential model, and we can actually start adding layers to it. So if you think back to our diagrams that we looked at earlier, we create this model, and we have those different like input, output, hidden layers in between. This is how you actually use it. You actually create it through the TensorFlow API. So first we create some simple dense layer, do some reshaping. Here we actually say, for all of the number of layers that we've chosen, we're going to create an LSTM cell. That's the diagram that we looked at that shows the long-term, short-term memories. We take that, we add another layer, our basic RNN layer, because remember, LSTMs are RNNs, but we give it these actual LSTM cells that we've created. Then from there, we add a simple dense layer, so we can actually get our data and like flatten it to get some kind of output. And the very last thing we do is compile our model. So once we actually build this structure, we have to compile it so we can actually then go through the training step. So when we click train and actually start training the data and start trying to learn that function that's going to give us predictions based on previous prices, we basically call this fit function. And what that does, it takes all of our x values, all of our y values, we give it the number of epochs we want to run. In our case, that was 10. Then the batch size just says how do we want to partition this data as we kind of go through. And then this log callback just says we want to log the results to the console so we can see it and evaluate it. And then we create some object that has the model itself, the history, some normalized data, and we pass that to this make prediction function. So make prediction, very similar. We convert our data to a tensor. The one thing here is that we have to normalize our data. One thing with long-term, short-term memory networks, or just like ANNs in general, we don't want to pass the raw prices to our data to actually model it. We want to normalize it. So this is what we're doing here. We're just like squashing it to some value between like 0 and 1, so we can have more robust training and have better predictions. We then pass our normalized input, right, which is going to be our training data, and we get back our result. And then what we have to do is convert that back to the raw prices. So there's this unnormalized here, this unnormalized function where we actually denormalize the data, and then we return it, and that gives us the stock prices that we actually plotted a second ago. So that's like at a high level how TensorFlow.js works. Here's how you can actually use it to make predictions. If you have prices, you can basically use these same functions, run it in the browser like this example does, or just import TensorFlow/node and run it locally from the server. So what are some takeaways? So TensorFlow.js makes it relatively simple to create an LSTM that can be used to predict stock prices, right? We saw with the Tesla example, Ford did pretty well because the swings in prices weren't very large. But with Tesla, for example, the price swings were huge, so it's very, very hard to at least use this approach to approximate our prices. We didn't look at it here, but in practice, if you try to project prices or predict prices further into the future, it's going to be a lot more difficult, and your results are going to decay the further out you go out. And also, we noticed that like changing our hyperparameter values could give you some better results. You can actually add more layers, remove layers, add more epochs, but there are some pros and cons associated with it. There's overfitting, things of that sort you have to watch out for. And then like the naive approach is good to give us an idea of the direction the price is going to go into, but we probably don't want to use it to actually predict prices unless we're going to like tweak the parameters and try to figure out what's going to give us the best result. And then other things we can do too to improve our performance is that we can actually add additional features. Instead of just the price, we can add the trading volume or other characteristics that can be used and learned by the model to determine what most affects the price to perform our predictions. So here are some resources that I recommend if you want to like learn more about this. MIT has a really good course on deep learning that's online for free. Just go to intro-to-deeplearning.com. The TensorFlow time series forecasting tutorial is pretty good. It's in Python, but you can easily translate it over to TensorFlow.js if you wish. The TensorFlow.js docs are really good, and then a demo of the actual app that we looked at and the actual repository that I just went through just now is available. I encourage you to go through there, look at the code, change it, and try to see if you can optimize it based on what you learn by taking these courses or reading this time series forecasting tutorial, because again, this is a naive approach. So that concludes my talk. So you can please connect with me on GitHub, Twitter, or LinkedIn. Also, as I mentioned, I know my time is up. I just want to do a shameless plug really quickly. Like, this is a passion of mine. I've been writing lots of papers, or a few papers, 2 papers, exactly, not a lot, 2 papers on some of this stuff. So a few of them are here. I'll share the link in the slides when you have it. So one is on deep reinforcement learning. It just broke. But anyway, long story short, these links are some papers that I've written. You can feel free to take a look at them, give me some feedback. The next paper I'm writing is going to be on Neurema versus LSTMs, and maybe I'll do another talk on the actual results and go deeper into some models and applications that I've actually trained. So with that, thank you so much. Thank you for having me here. I really enjoyed being here, and I have a long flight back to New York tonight. Thank you all. Oops.
Nice meeting you. Let's have a huge round of applause once again for Jamal. He has come from New York to deliver this session for all of us today. With that, we come to an end for all the sessions for track 2. We have one more session with Kyle Simpson in track 1, so let's move there and let's close the event.
I can remove the bell pack.
Yeah, please.